Hello everyone. We have just the 6 days left in our next NEET examination. Today we will be doing a mega revision. We have picked some of the most repeated topics, most high weightage topics, and mm, we will make sure that time spent here will be very valuable to you. Um, you will learn one or many things from here. I will start with physics. Later on, we will have Isha ma'am for chemistry, and then zoology, botany. So in physics, I will be doing most of the topics from class 12th, starting with electric charges and fields. Like I said, I have picked the important topics, high weightage topics, and it should surely help you this Sunday. We have two types of electric charges. We have positive charges, we have negative charges, and we have particles which do not carry charge. For example, neutron. For example, stable atoms. They do carry charge, but net charge on them is zero. Uh, like I said, charge we have positive and negative. If you talk about positive charge, let's say positive charge plus Q, it gives out diverging electric field lines. The electric field lines due to positive charge, point charge, they look like this. It gives out diverging electric field lines. And negative charge, it gives out converging electric field lines. So field lines will be similar in shape, but they will be terminating over at this negative charge. So field lines around minus q, if you see, they will be terminating into the minus q charge. Now as to what electric field is, we developed this concept of electric field to deal with electric forces. As you know, electric force acts at long distances, very large range. And to deal with large range forces such as electric force and gravitational force, we develop a concept of electric field, gravitational field. It is that charges in their vicinity, so plus charge or minus charge, they produce electric field around them. And if another charge comes into that field, the field exerts force on it. So this plus q charge you see, it creates electric field around it, as you can see. And if another charge comes into that field, this field exerts electric force on that field, that charge particle. In the same way, minus q charge, it produces electric field around it, as you can see. And if some other charge comes into this field, minus q charge's electric field will exert electric force on that charged particle. Now, as for the electric fields and their magnitude, plus q charge, as you can see, it creates electric field away from it. If I take a point here, let's say point P, electric field here, it will be in the direction of this electric field line. So over at point P, as you can see, electric field line is going towards right. At point P, electric field line, electric field, it will be in this direction. If you forget about the rest of the field lines, just focus on point P. Plus Q charge is here, point P is here. At point P, plus Q charge will create electric field away from it. And same will be the case with any of the point you take. Suppose you take this point, for example. You see where the electric field line is going. Electric field line is going in this direction. So over at this point, if you see, this will be the direction of electric field. And if you uh, forget about the rest of the field lines for once, if you see plus q charge, if you see this point, plus q charge at this point creates electric field away from it. We talk about the magnitude now. See, I'll do it for point P. Suppose point P is at r distance from plus q charge. Plus q charge, you see, as it creates electric field away from it, as we saw at point P. And if point P is at a smaller distance from this plus q charge, this electric field magnitude will be of k q by r square. and same will be the case with the negative charge. See, electric field lines for this negative charge, they are entering this negative charge, they are terminating over at this negative charge. So any point I take, let's say I take point A here, you see the direction of electric field line over there. Electric field line is heading towards negative q charge. Electric field at point A, it will be towards negative q charge. This will be the direction of electric field. So for positive charge, it is away from the charge, as you can see. For negative charge, it is towards the negative charge, as you can see. And in his, this point A is at r distance. Again, the electric field magnitude, this electric field magnitude will be of kq by r square. So this was about electric field created by point charges. It is kq by r square, away from the point charge if the charge is positive, towards the point charge if it is negative. Now electric field, it has magnitude kq by r square, it has direction. So obviously it is a vector quantity, and we deal with vector quantities with vector mathematics. We do not do algebra here. See what I mean? It's this. Suppose you have uh, two charges. Let's say you have q1 charge and you have another um, q2 charge or minus q2 charge. q1 charge, you see it's positive charge. q2 charge, you see it's negative charge. I'll write q1 greater than 0. q1 is positive charge and minus q2 is the negative charge. So I will write minus q2 is less than 0 or q2 greater than 0. Two charges I have taken just for an example. One is positive, one is negative. q1 is positive and this minus q2 is negative. I wrote q2 positive because this minus sign will then make it negative. Think of a point P over here. Now you have to see how much electric field q1 charge will produce over at point P. You have to see how much electric field minus q2 charge will produce at point P. So suppose point P, you see, is at r1 distance from q1 charge and r2 distance from minus q2 charge. I will extend this line of r1 a little bit. q1, you see, it's positive charge. Over at point P, it will create electric field away from it. So over at point P, electric field due to q1 will be this. I will call this E1, and since it is a vector, I will write it as E1 vector. Magnitude of this electric field we saw, it is kq1 by r1 square. Charge is q1 and point P is at r1 distance from q1 charge, so electric field will be kq1 by r1 square. Do the same but for q minus q2 charge. This is the negative charge. Point P is here. Negative charge produces electric field towards the negative charge. So at point P, minus q2 will be creating electric field towards it. We will call this vector E2. Magnitude of electric field, okay, so minus q2 is a negative charge. It creates electric field at point P towards it. We denote it with vector E2. Now point P is at r2 distance from minus q2 charge, so electric field due to it, it will be k q2, charge magnitude is q2, and by r2 square. So these are the electric fields: E1 created by charge q1, E2 created by charge minus q2, and their magnitudes I have written as per kq by r square. Now, if you want to know net electric field at point P, I want to see what is the net electric field at point P. I cannot simply do magnitude E1 plus magnitude E2. These are the magnitude. Electric field is a vector quantity, so we have to treat it like a vector quantity. Electric field due to Q1 is E1 vector, due to minus Q2 it is E2 vector. So we need to add these two electric fields as per vector addition. Net electric field at point P, it will be electric field E1 plus electric field E2, but you do it with vector addition. Now, as to how we do vector addition, you have to complete a parallelogram using these two electric fields as adjacent sides. So you make a side parallel to E1 this way, you make a side parallel to E2 this way, and then you complete this diagonal from point P to here. This will be your net electric field at point P. Now to add two vectors, uh, suppose the angle between these two electric fields E1 and E2, suppose this is theta. Net electric field at point P, this magnitude you want to see. So as per vector addition, magnitude of the resultant of E1 and E2, it is given by square root of magnitude of E1 square plus magnitude of E2 square plus 2 E1 E2 cos of angle between them. Angle between the electric fields, we are taking it as theta. So this will give you the net electric field at point P. Now using this concept, we will solve one question. It's a relatively simple question. We won't be making use of this a lot. Yes, we will be making use of the fact that electric field is a vector quantity. Let's see the question. We have 2-point charges plus q and plus 4q separated by a distance d. Find the position on the line joining them where the net electric field is 0. Express your answer in terms of d. So do as they say, you make a diagram first, you make a picture first. You have two charges, one is plus q, you have plus q charge, and you have a plus 4q charge. Separated by distance d, so make a line that joins them, make a line this way, and they are separated by d distance. So this separation, I will take it as d. Find the position on the line joining them. Line joining them I already showed with this dashed line, where the net electric field is 0. Express your answer in terms of d. Now we have to figure out where will the electric field can possibly be 0. See, this straight line, line that joins them, you can divide it in 3 parts. A portion of straight line that is to the right of 4q, portion of straight line is that is to the left of q, and the portion of straight line, the line segment between q and 4q. These 3 different places we will see where net electric field can be 0. So if I take a point here, if I call it point P1, let's say, I will show the electric field due to these two charges. See, it's a positive charge plus 4q charge, and point P1 is here. As we saw, positive charge will create electric field at point P1 in a direction away from the charge. Positive charge is here, point P1 is here. This direction would be towards the positive plus 4q charge. Electric field should be away from the plus 4q charge. So plus 4q charge at P1 will create electric field away from it. This will be the direction of electric field due to plus 4q charge. Let's see what is the direction of electric field due to plus q charge. Now plus q charge is also a positive charge. Over at point P1, it will also create electric field away from it since it is positive charge, same as plus 4q charge. Now, if two electric fields are in the same direction, when you do its vector addition, it will essentially be the algebraic addition also only. So, for example, if plus 4q charge creates 200 electric field here and plus q charge creates 50 electric field here, those electric fields will add up and become 250. So, if you take a point to the right of plus 4q charge, electric field due to plus 4q, electric field due to q, they will end up being in the same direction. And when you do their vector addition, it will never be a 0. Let's try to have a point over to the left of plus q charge. Let's take a point here. Call it point P2. Let's see if things change here. Plus q charge and point P2 is here. As we saw, positive charge creates electric field away from it. So electric field due to plus q charge over at point P2, it will be away from it in the left direction. And electric field due to plus 4q charge over at point 2, this is also a positive charge. Over at point P2, it will create electric field away from it this way. Okay. So once again, we took a point and electric fields due to q charge, 4q charge, they ended up being in a direction away from it. So over at point P2, our electric field will never be 0 because both of these electric fields are adding up. They are in the same direction. So let's try taking a point in between these two charges. Let's say we take one point here. We take point P3 here. I will take this point to be at x distance from plus q charge, and since the total separation of charges is d, distance of point P3 from plus 4q charge, this distance, it will be d minus x. So in case you add d minus x and x, you will end up getting the separation of d. Over at point P3, see the direction of electric field created by plus q charge, created by plus 4q charge. Plus q charge is here, point P3 is here. As we saw, positive charge will create electric field at point P3 away from it. This will be the direction of electric field due to plus q charge. And electric field due to plus 4q charge, again it's a positive charge at point P3, it will create electric field away from it. So here the electric field due to plus q and plus 4q charge, they are in opposite direction, unlike the first case, unlike the second case. Now these electric fields are in the along the same straight line but in opposite direction. If their magnitudes end up becoming the same, net electric field can be 0 here. For example, if plus q charge creates 200 to the right and plus 4q charge here creates 200 to the left, net electric field at point P3 will be 0. So a point in between these two charges has electric fields due to plus q, due to plus 4q in opposite directions. If these magnitudes are same, net electric field will be 0. So I will explore on that condition. In case your electric field due to plus q charge, which is to the right, and electric field due to plus 4q charge, which is to the left, if they are exactly same, then the net electric field over at point P3 will be 0. We have to solve for x. We have to find the position where the net electric field is 0. So write the expression of electric field due to q charge due to 4q charge. Q charge is at x distance from point P3. So electric field at point P3 due to plus q charge, it will be kq by x square is equal to electric field due to 4q charge. Point P3 is at d minus x distance from 4q charge. Electric field will be k charge magnitude 4q divided by d minus x square, and we have to solve for x. here. We can cancel out k, we can cancel out q. Write down what's left. We have 1 by x square on left side and 4 by d minus x square on right side. Send this to the left, send this to the right. D minus x square is equal to 4x square. If you take square root both sides, this will become d minus x. This will become 2x. You will have d is equal to 3x, and therefore x is equal to d by 3. X is d by 3, meaning point P3 is at d by 3 distance from plus q charge, and it will be at 2d by 3 distance from 4q charge. So a point which is at d by 3 distance from q charge to d by 3 distance from 4q charge, here the net electric field will be 0. Now see, electric field we saw, we will see Coulomb force between two point charges or bodies carrying charges whose sizes are not significant. See, suppose you have point charge q1 and we will take this charge to be positive. So our q1 is positive. You have another point charge q2. We will take this q2 charge to be positive again. Now both of these are charged particles or charged bodies, and they are separated by a certain distance. Charged bodies exert electric force on each other. It can also be understood using the concept of electric field that we saw. But if we have charged particles in vacuum in free space, we can directly deal with charges using Coulomb force expression. See, both of these charged particles, we took q1 and q2 as positive. Q1 is positive, q2 is positive. So with electric force, they will repel each other. If you have pair of charges, pair of unlike charges, so if one is positive, other is negative, you will have attraction between those charges. But if you have like charges, Okay. So if we have positive charges pair, Q1 is positive, Q2 is positive, they will repel each other. If you have a pair of negative charges, if both of them were negative, then also they will repel. But if there is a pair of positive negative or negative positive charge, they will attract each other with electric force. So here I have taken two positive charges, Q1 and Q2. Suppose they are separated by r distance. So as per Coulomb force, both of these charges will exert electric force on each other. That force will be of repulsive nature since both of these charges are positive here. Force with which Q1 repels Q2, so Q2 gets repelled by charge Q1. This force I will write it as force on charge Q2 due to charge Q1. And in the same way, charge Q2 positive being uh, Q2 being positive will repel charge Q1 also positive along this line that joins them. Q2 repels Q1 away from it with electric force. I will write it as force on 1 by 2. So this is how the electric forces will be acting between these two charges Q1 and Q2. Again, Q1 repels Q2 with force F21 because force is on Q2 by Q1. And in the same way, Q2 will repel Q1 with force F12, force on charge Q1 due to charge Q2. Now both of these forces are in opposite direction as you can see, but both of these forces, force due to Q1 on Q2, force on Q1 due to Q2, they both will be of same magnitude, and the magnitude is given by K, product of charges, so Q1 into Q2 divided by their separation square. This will be the electric force between the two charges separated by r distance. This K value is in SI units 9 into 10 power 9 and unit is Newton meter square per Coulomb square. This is the K value. Now if the charges were positive negative, force magnitude will be same K Q1 Q2 by r square, but the forces will be towards each other, unlike this case. Here Q1 is repelling Q2, Q2 is repelling Q1. If one was negative, one was positive, they would be attracting each other with the same K Q1 Q2 by r square of force. Based on this, let's see a question. A small uncharged conducting sphere is placed in contact with an identical sphere but having 4 into 10 power minus 8 coulombs of charge and then removed to a distance such that the force of repulsion between them is 9 into 10 to the power minus 3 newtons. The distance between them they are asking. You have two conducting spheres, one is uncharged, the other one is charged, and they are identical. So take this as your first sphere which is uncharged, take this as your second sphere. This has charge, so charge on 1 is 0, charge on 2 it's not 0, rather it is 4 into 10 power minus 8 coulomb, it's positively charged. So both of these are brought in contact and then removed to a certain distance. See, one of them is uncharged, the other one is charged, and both of these are conducting. So if you connect them, if you bring them in contact, the charge transfer will take place. This is uncharged, this has positive charge. So some electrons from the first sphere, first uncharged sphere, they will jump onto this positive charge, and this will become less positive and this will become positive. Some electrons jump from first to second sphere, so positive charge on the second sphere will reduce, and since first one is losing electrons, it will gain some positive charge. Now if both of these charges are identical, as said in the question, both of these spheres are identical, after the contact is made, both of them will have exactly same charges. So essentially whatever charge this second sphere has initially, half of it will go to the first, and both of the spheres will have same charges after the contact. So after the contact, I will show the situation. After the contact, first sphere and the second sphere, this will have lost half of its charge. If initially it had 4 into 10 power minus 8, after the contact it will have positive charge, but it will be less. It will be half of what it was before. It will be 2 into 10 power minus 8 coulomb, and this will have lost some electrons in the process. It will have got exact same charge as the second one. It will also have 2 into 10 power minus 8 coulombs of charge. So essentially this charge divides into both of these spheres. Now you bring them, now you take them to a certain distance. Suppose you separate them by r distance. They are saying force of repulsion between them is this much. So before this was uncharged, this was positively charged. After the contact, both of them are positively charged, so they will repel each other. You take these two spheres at a certain distance and then they repel each other with this much force as per the question. They want you to find out how far they are from each other. What is the separation of these two spheres? So use Coulomb's force here. Both of these spheres, they repel each other with electric force of k q1 q2 by r square, and this force of repulsion is given as 9 into 10 to the power minus 3 newtons. K value you put in SI units, it is 9 into 10 to the power 9. Q1 Q2 are charges on these spheres. Each of them has 2 into 10 power minus 8 coulombs. So Q1 is 2 10 power minus 8, Q2 is 2 10 power minus 8. This will be Q1 Q2 by r square. This r square you want to find out is equal to 9 into 10 to the power minus 3. So clear out here, and you can clear out. R square sent to the right side, 10 to the power minus 3 to the left side. You will have 10 power 9, 10 power minus 8, 10 power 9 into 2 into 10 power minus 8 into 2 10 power minus 8. 10 power minus 3 comes here, and r square goes the other side. We want to find out r. 10 power minus 3 send up, it will become 10 power 9 plus 3, it will become 10 power 12 into 2 into 10 power minus 8, 2 into 10 power minus 8. If you multiply these two 2's, it will become 2 into 2, 4. Powers to 10 you calculate, 12 minus 8, 12 minus 8 is 4, 4 minus 8 is minus 4. This will be your r square. You take square root, 4 square root is 2, 10 power minus 4 square root is 10 power minus 2. This answer will be in meters, and this 10 power minus 2 meter you can sum up in a centimeters. So the separation of charges, separation of these spheres must have been 2 centimeters for the force of repulsion to be 9 into 10 to the power minus 3 newtons. So these are some simple electric field questions you should never skip in your exam. We will see a bit about electric potential energy of point charges. Taking infinity as your reference point for zero potential energy. First, potential energy is defined for conservative forces. Electric force is a conservative force, much like gravitational force, same as spring force. So for gravitational force we can define potential energy, for spring force we can define potential energy. In the same way we define electric potential energy for electric force. Now for potential energy you have to have a reference point. If we talk about gravitational potential energy, if you take ground as your reference height of 0, at h height, potential energy expression is mgh. So in the same way, for electric potential energy, we take infinity as our reference point. If two charges, let's say q1 and q2, if they are very far away from each other, if their separation is, let's say, very large, if they are infinitely far away from each other, as per Coulomb force, we saw kq1 q2 by r square. R will be infinity, electric force will be 0. So if they are very far from each other, there is negligible interaction between them, there is no interaction between them. We take infinity as our reference point for electric potential energy. And using that as our reference point, if two charges q1 and q2, they are separated by r distance from each other, we define potential energy of this pair of charges, of pair of q1 and q2 separated by r distance, as k, the same k from the Coulomb's force, q1 q2 by a single r. In case of point masses, gravitational potential energy, if you remember, it was minus g m1 m2 by r. So we have a similar expression here. Taking infinity as our reference for zero potential energy, when two charges q1 and q2 are at r distance from each other, electric potential energy bound between the two, it is given by k q1 q2 by r. So based on this one question we will see. Also, anyone has any questions, they can ask in the comments. I will have a look at time to time. Two charges 7 microcoulomb and minus 4 microcoulomb are placed at minus 7 centimeter 00 and 7 centimeter 00. Epsilon naught permittivity is given. The electric potential energy of the charge configuration is. You need to understand the coordinates a little bit. You must be familiar with the Cartesian XY coordinate system. You have x-axis, you have y-axis, you have origin, and the points are given by a certain x comma y, x coordinate comma y coordinate. Here we have three coordinates. We have x coordinate, we have y coordinate, and we have z coordinate. For the other point also, we have x coordinate, y coordinate, and z coordinate. This you can take it as the first point. Call x1, y1, z1, x2, y2, z2. They have given you coordinates. It has y and z as well. But if you look closely, y coordinate is 0, z coordinate is 0, y coordinate is 0, and z coordinate is 0. So both of these points are essentially on the x-axis only. And these charges you see, they are lying along the x-axis only. So you do not even need to make y-axis and z-axis. Just make the x-axis, show the points, show the origin. Let's say this is your x is equal to 0. Okay. You will need x is equal to minus 7. So this is your x is equal to minus 7, but it is in centimeters, so do keep in mind. You will need x is equal to plus 7. So these are the 2 points. Okay. Now over these point, you have placed 2 charges. At x is equal to minus 7, you are putting 7 microcoulomb of charge, and at x is equal to plus 7, you are putting minus 4 coulomb of charge, minus 4 microcoulomb of charge. 7 microcoulomb minus 4 microcoulomb. And they are asking you electrostatic potential energy of this charge configuration. Geometry is given, charges are given 7 microcoulomb minus 4 microcoulomb. You will need to find the separation of these charges. So see, from the origin to minus 7 centimeter, this will be 7 centimeter long, and from the origin to plus 7 centimeter, this will be another 7 centimeter. So if you look at the total separation of these two charges, it will be 7 plus 7, total of 14 centimeters. The R we saw in the formula, it is separation of charges. Here it is 14 centimeter, and our options are in joule unit. Our separation should be in meter unit. 14 centimeter, you can write it as 14 into 10 to the power minus 2 meters. This will be the separation of charges. Now find out the electric potential energy of these two charges using our formula. Our expression is K Q1 Q2 by separation of charges. K value you can put, or you can also do 1 by 4 pi epsilon naught, and for that they have given epsilon naught, but since we know what K is, just write K as 9 into 10 to the power 9. Q1 Q2 product of charges. One charge is 7 microcoulomb, but write it in coulombs. So microcoulomb to coulomb conversion, it's 7 into 10 power minus 6. And Q2, this is very important, it's minus 4 microcoulomb of charge. Microcoulomb to coulomb conversion you have to do, but you also have to take care of this minus sign. This expression when you use, you write charges with signs. So if you have positive charge, you write positive charge. If you have negative charge, you write negative charge. Here you have minus 4 microcoulomb. So Q1 you did times Q2. Q2 will be minus 4, and microcoulomb to coulomb conversion is 10 to the power minus 6 again. Divided by their separation is 14 centimeter. In meter it is 14 into 10 to the power minus 2 meters. So this is one thing you keep in mind. When you use Q1 Q2 by R as potential energy, you take charges with signs. So charges, if they are positive, you take positive. If they are negative, you take negative. Q1 I took positive, it's plus 7. Q2 I took negative, it's minus 4 microcoulomb. And work out this. 7 times 2 is 14. Minus 4 by 2, it will be a 2 in the numerator. If you do minus 4 by 2, it will be minus 2. Minus 2 times 9 will be minus 18. And see the powers of 10. You have 9 here. 9 minus 6 is 3. 9 minus 6 is 3. 3 minus 6 is minus 3. Minus 3, and this minus 2 goes up. It will become minus 1. It will be minus 1.8 joules. This will be the electric potential energy between these two charges. Can you go a little fast? I'm trying my best. Okay. Dipole. Let's see a little bit about dipole. See, electric dipole is two equal and opposite charges. So you take a minus q and a plus q. Two equal and opposite charges separated by a small distance, typically in micrometers or nanometers. So you have minus q, you have plus q. They are separated by a small distance. This small distance, for calculation purpose, we take it as 2a. Otherwise you have to deal with lots of fractions. This is your electric dipole, a minus q charge or plus q charge, and separated by a fixed 2a distance. This is your electric dipole. Okay. Some very important terminology and expressions I will write. You make a line that joins these two charges, minus q and plus q. This line is called axis of dipole. On the axis of dipole, between these two charges, the midpoint of charges, this midpoint is called center of dipole. Okay. You make a line perpendicular to axis of dipole and passing through this center. This line, it is called equatorial line. Now this is the terminology. Few things. With electric dipole, we define a physical quantity, a vector physical quantity. It is called dipole moment or electric dipole moment. We represent it with the p vector. Electric dipole moment, it's a vector quantity, vector p. Magnitude of this is given by separation of charges, which is 2a times the charge magnitude. This is the magnitude of electric dipole moment. Now it's a vector with magnitude 2aq. It also has a direction. Direction of electric dipole moment, it is from minus q charge to plus q charge. This is the direction of electric dipole moment. Magnitude, charge separation 2a times magnitude of charge q, so 2aq. Direction of p is from minus q to plus q. Two things are important: electric fields at axial point, electric field at equatorial point, and electric potential at axial point, electric potential at equatorial point. So first we talk about axial point. Suppose you take point P1 here on the axis of dipole. This will be your axial point, and distance of point P1 is measured from the center of dipole. Point P1 on the axis of dipole, axial point, at this much distance from the center of dipole. This distance we will call small r. Distance is always measured from center of dipole. Okay, one approximation we use, this small r you see, it is very large compared to the separation of charges. So this point P1 you see, it is very far off from how far these two charges are. So we take this approximation, r is very large compared to the separation of charges. Now electric field at point P1, axial point of dipole, it is given by 2 times k p by r cube. 2 k p by r cube. P is your electric dipole moment 2aq. And direction of electric field at point P1, it is along dipole moment. So electric field at point P1 I will show here. This is the direction of electric field at point P1, and the magnitude is 2 kp by r cube. P is dipole moment magnitude 2aq, and r is distance of point P1 from the center of dipole. Okay, and electric potential at point P1, do you remember, it is given by kp by r square. Electric potential, it is a scalar quantity, so no direction here. Magnitude is kp by r square over at point P. Same we will talk for equatorial point. Over at equatorial point P2, let's say, at r distance from the center of dipole. Here also we have to use an approximation for when r is very large compared to the separation of charges. For equatorial point P2, electric field at P2 is given by kp by r cube. Axial point, it is 2 kp by r cube. Equatorial point electric field is kp by r cube. And one more key difference is electric field over at axial point, it is towards right, in the direction of the dipole moment, towards right. Electric field at an equatorial point, it is towards left, opposite to the electric dipole moment. This electric field is of magnitude kp by r cube. And as for electric potential at point P2, equatorial point, the idea is this point is equidistant from plus q charge and from minus q charge. This point is at root r square plus a square distance from both of these charges. Electric potential over at point P2, it is 0. So you do need to remember this electric field at axial point, equatorial point. You need to remember electric potential at axial point, equatorial point. Based on this, one question we will see. For a short dipole placed at origin, The dipole moment P is along x-axis. So you have placed a dipole here. This is your dipole. Dipole moment is P. If the electric potential and electric field at A are V naught and E naught respectively, then the correct combination of the electric potential and electric field respectively at point B on the y-axis is given by. At point A, electric field is given as E naught. Like we saw, it is an axial point. If you see this P, you think of this as minus Q, you think of this as plus Q, and then point A will be our axial point to this dipole. Point A is at r distance from our center of dipole as well. So electric field at point A, which they are calling E naught, it will be 2 kp by rq. Let's see what will be electric field at point B. Point B, you see, it is equatorial point. Electric field on an equatorial point, it is kp by rq. R is distance of point B from our dipole, which is 2r in this case. So you do 2r cube. This will then be kp by 2 cube is 8, r cube is r cube. This will be our electric field at B. They are asking electric field at B will be how much? So it is kp by 8 r cube. I will write this as 1 by 2. I will write this as 1 by 8 into kp by r cube. I will write this as 1 by 2 into 2 kp by r cube. Okay. I have rearranged it a little bit, but mathematically nothing has changed. It's kp by 8 r cube. I wrote it as 1 by 8 kp by r cube and then multiplied with 2 divided by 2. This is so as I can put 2 kp by r cube as E naught, and then 8 into 2 is 16. 2 kp by r cube, it is our electric field at point A, which is E naught. Our electric field at point B will be E naught by 16. And point B is on equatorial line. It's an equatorial point. As we saw, electric field on equatorial line is 0. Electric potential on equatorial line is 0. So at point B, electric potential B, VB must be 0. So this will be our right answer. They're asking electric potential and electric field. Electric potential is 0. Electric field is E naught by 16. This will be our answer. One question we will see from capacitors. Parallel plate capacitor consisting of two circular plates of radius 10 cm is being charged by constant current 0.15 ampere. If the rate of change of potential difference between the plates is 7 into 10 to the power 8 volt per second, then the integer value of the distance between the parallel plates is. See, capacitor, parallel plate capacitor, it has two metal plates and a small separation between them. We write, suppose these are the plates of capacitor. Small separation between them, we take it as D. Area of these plates you see in a vertical plane you cannot see here. Area of these plates we take it as A. Both of these plates will be of A area, and you connect them using a kind of a battery. Okay. See, there will be a switch here as well. Once you turn on the switch, battery starts to charge these plates. Due to the battery, electrons move from this plate onto this plate. One plate will get positive charge, the other plate will get negative charge. So at an instant, suppose the left plate has positive charge, Q of charge, the other plate will have just as much but negative charge, minus Q. Okay. This charging is done using constant current as per the question. These plates you see, they create electric field between them. You have plus Q charge, you have minus Q charge on this plate. So there will be an electric field between the plates. Okay. And if the separation of these plates is D, then the potential difference between these two plates, here, potential difference between these two plates, you can write it as E into D. Electric field between the plates of capacitor. You essentially have two plates, one with plus Q charge, one with minus Q charge. Plus Q charge, it will create Q by 2 epsilon naught of electric field in the middle to the right. Minus Q charge will create just as much towards right as well. See what I'm saying? It's this. Suppose this has Q charge, area is A. This much will create electric field to the right, and this electric field is of sigma by 2 epsilon naught. Our sigma is charge by area by 2 epsilon naught. It will be Q by 2 epsilon naught. And if you have minus Q charged plate here, if you have negatively charged plate here, it will do the same. It will create just as much electric field towards it, just as much as in Q by 2 epsilon naught. So the net electric field between the plates, it will be Q by 2 epsilon naught due to the positively charged plate, Q by 2 epsilon naught due to the negatively charged plate, and both of these electric fields are in the same direction from left to right. Net electric field therefore will be Q by A epsilon naught into D. This will be potential between the plates, potential difference between the plates. Now see what they have given. Radius is given, so area we can figure out. Constant current, we are charging these plates by constant current. If the rate of change of potential difference between the plates is 7 into 10 to the power 8, what you do, you differentiate this equation with respect to time. So left side you will have rate of change of potential difference between the plates that they have asked in the question, and right side you see D is separation of plates, does not change. A is area of plates, does not change. Permittivity of free space does not change. Your Q, you differentiate it with respect to time. Upon differentiating both sides with respect to time, you will get this. Okay. One more thing. D by A epsilon naught. This dq by dt, you see, Q is charge on this plate. dq by dt will be the rate at which charge is coming onto this plate. If dq by dt is 2 coulombs per second, meaning 2 coulombs of charge will be coming to this plate every second. And if 2 coulomb of charge is coming on this plate every second, it means there will be a current equivalent to 2 coulombs per second, 2 ampere flowing in this circuit. So this dq by dt, you see, it is effectively your electric current flowing in the circuit, and that current is also given. It is constant, it is 0.15 amperes. What you have to solve for is distance between the parallel plates. So keep d here, send everything to the other side. You will have A epsilon naught in the numerator, I in the denominator, and a rate of change of potential difference between the plates. This will be our separation of plates. This you need to find out. dV by dt. Now area of plates, They are circular plates. Radius is 10 centimeter given in the question. So right area is pi into radius square. Pi they are asking you to take 22 by 7. So I will write area as 22 by 7. Radius square. Radius is 10 centimeters. You do need to convert this into meters. 100 centimeters is 1 meter. 10 centimeter will be 0.1 meter. So radius 0.1 meter. 0.1, 0.1 pi r square is done. Epsilon naught, it's 8.85 10 power minus 12, but for this very question they are asking you to take its approximate 9 into 10 to the power minus 12 value. Take this as epsilon naught. dV by dt, rate of change of potential difference, it is given in the question. It is 7 into 10 to the power 8. So write this value, and we have a denominator as well, divided by current I. It is being charged with constant current of 0.15 ampere. So this will be your I. You solve this, will have separation of plates. These 7 you can cancel. 15 into 6 is 90. 0.15 into 6 would be 0.9. 0.15 into 60 will be a perfect 9. So you can do 0.15 into 60. Answer is asked in micrometer. So 10 power minus 6 we need. 10 power minus 12 plus 8 is 10 power minus 4, and 2 0.1s will make 10 power minus 6. So work out this, you will have 22 into 60 into 10 power minus 6 meter. This has become your micrometer. This numerical you see will be your answer. It will be 0.1320 micrometer. This will be the separation of plates, distance between the plates. This question we have from current electricity. It is about parallel series circuit combination. Wire of resistance R is bent into an equilateral triangle, and an identical wire is bent into a square. Ratio of resistance between the two end points of an edge of the triangle to that of the square. Here you can start by taking a wire of L length of our resistors, and you see how series parallel combination goes. See, take one wire total resistance is R, take its length as L. Okay, wire of resistance is bent into an equilateral triangle, so make an equilateral triangle out of this. That triangle will look like this. Now all the sides you see, they will be same. This will be L by 3, the other two will be L by 3 as well. And if you remember, resistance is directly proportional to the length of the conductor. L length had R resistance. All of these sides will have 1/3 of the resistance. L length has R resistance, so this L by 3 will have resistance of R by 3. This L by 3 of length will have R by 3. This L by 3 will have resistance R by 3. So write the resistances. I will write this resistance as R by 3, R by 3 and R by 3. Now what we have to do, they are asking the ratio of resistance between the two end points of an edge. Take this as your end point, take this as your end point, find out the resistance between these two end points.
if you do this R by 3 and these two R by 3s, you see they will come in a combination. Top R by 3s two, you see they will be in a series combination, and again they will be in a parallel combination with the other R by 3. So simplify this circuit with time. This top, you see R by 3 plus R by 3, they are in a series, so they will become R by 3 plus R by 3. This one, keep it as is. It was R by 3, keep it as R by 3. We want electric resistance between these two. This top branch R by 3 plus R by 3, this will become 2 R by 3. This will become R by 3. Now they are in a parallel combination, so you solve for parallel combination. Equivalent resistance for our triangle, I will call this R1. 2 R by 3 and two resistances R by 3 and 2 R by 3, they are in a parallel combination. So for parallel combination, equivalent resistance is R1 R2 by R1 plus R2. So take 2 R by 3 as your R1, 2 R by 3, R by 3 as your R2, R by 3, and then 2 R by 3 upon 2 R by 3 plus R by 3. This will be the equivalent resistance of your equilateral triangle between two endpoints of an edge. Denominator 2 R by 3 plus R by 3 is becoming R. Numerator, you see 2 by 3 and another 3, it will be 2 by 9. R into R is R square. So for equilateral triangle, between the endpoints of an edge, resistance is coming out 2 R by 9. Now the same you have to do for a square. This wire you take, you make a square of it. So it will be a square like this. All these sides, you see, they will be 1/4 of the original wire, and therefore the resistances will also be 1/4 of the original wire. Again, you take an edge such as this. Between these 2 points, you have to find equivalent resistance. So this time these 3 will be in a series combination, and then they will be in a parallel combination with the other R by 4. So for the top branch, here this resistance will be R by 4 plus R by 4 plus R by 4. Since they are in a series combination, it will be 3 R by 4, and you have R by 4 here. You have to find out equivalent of these two in a parallel combination now. So I'll call this R equivalent to R1 R2 by R1 plus R2, same as before. This, take this as R1, take this as R2. So it will be 3 R by 4 into R by 4 upon 3 R by 4 plus R by 4. Denominator will again become R. Numerator is 3 by 16. This will come out 3 by 16 R. This will be our squares edge endpoint equivalent resistance. And they are asking you to take a ratio of this, is it? Okay. The ratio of resistance between the two endpoints of an edge of the triangle to that of square. Of triangle it is 2R by 9. Of square we found out it is 3R by 16. They are asking the ratio. So you do 2R by 9 divided by 3R by 16. 16 will go up, 9 will come down, R's will cancel. So it will be 2 into 16 by 3 into 9. It will be 32 by 27. This will be this will be the ratio of their equivalent resistances. One more question we have from current electricity. Galvanometer having a coil resistance. Galvanometer resistance we denote it with a G. Okay. galvanometer, you can make it into an ammeter, you can make it into a voltmeter. See, if you want to make galvanometer into an ammeter, the idea is this: galvanometer, it's a very sensitive instrument, it cannot take up large currents. If you want to make if you want to measure large currents, you need to modify it a little bit. So to measure large currents, to make an ammeter which can measure currents, what we do, we put a small shunt resistance in parallel with the galvanometer. In parallel with the galvanometer, what it does, it increases the range of the ammeter. You can measure large currents using ammeter. So see, the circuit diagram looks like this. You have galvanometer here, and you put a shunt resistance, a very small shunt resistance in parallel with it. This is your main circuit. Current I enters this ammeter setup. Now shunt is very small resistance. Most of the current passes through the shunt resistance, and the current through the galvanometer is very less. We call the galvanometer Ig. Remaining I minus Ig flows through the shunt resistance. This is your limiting condition as well. If you want to measure maximum of I, you can pass maximum of Ig through the galvanometer. We call Ig the full scale deflection current. That when galvanometer needle is showing the maximum, the current passing through it, it is Ig. So in order to measure I current, you can pass Ig of maximum full scale deflection current through the galvanometer, and the remaining I minus Ig passes through the shunt resistance. If you apply Kirchhoff voltage law here, you will find that Gig should be equal to I minus Ig into shunt, and therefore the shunt resistance to be connected in parallel with the galvanometer in order to measure current is Gig upon I minus Ig. Here G is your galvanometer resistance, Ig is full scale deflection current, I is the current that you want to measure, the range of current you desire to measure. Okay. To make it into a voltmeter, voltmeter measures potential difference or voltage. Now the constraint is the same, you cannot pass a large current to the galvanometer. To design voltmeter, what we do, we put a large resistance in a series with the galvanometer. Voltmeter circuit looks like this. Suppose you have an instrument, some kind of instrument you have, across which potential difference is V, which you want to measure. Okay. Our voltmeter setup looks like this. You have a galvanometer, but because you cannot pass a large resistance, a large current through it, you put a large resistance in series with it. This is our voltmeter setup. Here what will happen? You have Ig current passing through our galvanometer again. So here if you apply Kirchhoff voltage law, you will have V is equal to G Ig plus R into Ig, or Ig into R. Ig into G plus Ig into R as per Kirchhoff voltage law. You can send Igg term to the left. You will have V minus Ig into G is equal to Igr. Then you can divide both sides with Ig. This is the resistance you will want to connect with the galvanometer in series to be able to measure voltage V across an instrument. Conclusion is, for emitter you put a small shunt resistance in parallel with the galvanometer so that galvanometer passes small current, and then you can measure I using the galvanometer. Voltmeter has to measure voltages. So if some instrument is creating voltage of V, to measure that voltage V, we design a voltmeter. Again, you do not pass a large current through galvanometer, so you put a very large resistance R in series with it. So this big resistance will allow very small current to pass, which is Ig. And then using Kirchhoff voltage law, we can figure out how much resistance R to be put in series with the galvanometer as per this formula. Okay, let's solve one emitter question based on this. Galvanometer having a coil resistance of 30 ohms. Coil resistance of galvanometer, it's our G. G is 30 ohms. Need 20 milliampere of current for full scale deflection. Our full scale deflection current, it is the maximum current that you want to pass through the galvanometer. That is our Ig. Ig is given as 20 milliampere. Okay, I will write this in ampere as well. Milliampere to ampere conversion is 10 to the power 20 into 10 power minus 3 amperes. If a maximum current of 3 ampere is to be measured, the current that you want to measure, it is I. I is our 3 ampere. Using this galvanometer, the resistance of the shunt to be added to the galvanometer. Shunt resistance they are asking. Shunt should be how much? So remember the formula if you can, otherwise you can make a small circuit like I did before. Shunt expression, it is G galvanometer resistance, Ig full scale deflection current, divided by current that you want to measure using the emitter minus full scale deflection current Ig. Now put the values. G is 30, Ig is 20 milliampere. So write it as 20 into 10 power minus 3 upon I minus Ig. I is 3 minus Ig is 20 into 10 power minus 3. Now, as per the question, this shunt is equal to 30 by x. They are asking you to find this x value, how much this x is. So you do not have to find shunt here exactly. You have to write the expression for shunt, and then you have to equate it with 30 by x. You need to solve it for x. This 30 will clear easily. Send x here and the other sides here. X to the left, it will go up here. This will go up, this will come down. That will be 3 minus 20, 10 power minus 3. This will go up upon 20, 10 power minus 3. Yes. Now what you do, 3 minus this by this. So write it as 3 by 20 into 10 power minus 3 minus this by this, 20 10 power minus 3 upon 20 10 power minus 3. Solve further. 3 by 20 10 power minus 3. Send this 10 power minus 3 up. It will become 10 power 3, and 10 power 3 I will instead write it as 1000 by 20 minus 20 10 power minus 3 by 20 power 20 10 power minus 3. This is 1. This is 300 by 2 is 150. 150 minus 1 is 149 ohms. This is your x. It's not shunt. Shunt resistance is 30 by x. They asked us to find x. X I found out. It is 149 ohms. Not ohms. It's not ohms. It's x. It's x 149. Okay. One question we will see on RC circuit. RC circuit questions, mostly they will be on a steady state only. So either you turn on the circuit or you have left the circuit on for a long time and you have to see how things are. See, if you have hmm, one circuit I will show, some resistance is there, capacitor is there, and a battery is there. Battery of EMF E, let's say, and a switch. A simple RC circuit, one resistance, one capacitor, and a battery. At t is equal to 0, I close this switch. Remember 2 points. First is, when you just close the switch, capacitor acts like a conducting wire. So when you just close the switch at t is equal to 0, I will redraw the circuit. You can think of it as a resistance, a plain conducting wire, and a battery. This, simple this. When you just close the circuit, capacitor starts to engage, but when it has not engaged yet at this instant, it will act like a conducting wire, and then you will have current flowing in it. Current will flow as per Ohm's law, as per Kirchhoff's voltage law. Current will be of E by R. So this is the first point. When you just close the switch, capacitor acts like a conducting wire. So you replace the capacitor with a plain conducting wire such as this, and you solve the circuit. Second is, after a long time has passed, after a very long time has passed, what will have happened? This battery, you see, it will have completely charged this capacitor. There will be positive charge on this plate, there will be negative charge on this plate. Capacitor will be fully charged. When it is fully charged, it does not let current flow in the circuit. See, after a long time, once again, electrons will have moved from here to here. This will be fully positively charged, this will be fully negatively charged, and once capacitor has fully charged, there will not be any electrons flowing in the circuit. There will not be any current flowing in the circuit. So when long time has passed, current does not allow charge flow in the branch that carries it. You can make capacitor as open ends of a circuit. This will be your equivalent circuit. Okay, current will indeed not be flowing in this circuit. So you replace capacitor with open ends of a circuit. Same you have for inductors, exactly opposite. In case you have a series RL circuit, if you have an inductor, simple RL with a battery, when you just close the switch at t is equal to 0, this inductor, you see, it will see that there is charge trying to flow through it, there is a current trying to build up, and inductor will induce opposite EMF, back EMF, to counter it. Initially it counters it perfectly. So when you just close the switch, inductor will show a resistance of a sort. It will not let current pass through the circuit, it will not let charge pass through the circuit, it will develop its own EMF. And as the time progresses, that current starts to build up in the circuit slowly, and after long time has passed, this inductor will no longer be showing resistance to the current flowing in the circuit. Again, when you just close the switch, current is trying to build up in the circuit. Inductor perfectly shows the resistance. Inductor does not let charge pass. And as the time progresses, current starts to flow. After long time has passed, inductor does not show any more resistance. It lets charge through fairly easily. So at t is equal to 0, you do the opposite here, opposite to how you treat capacitor. At t is equal to 0, it shows 100% resistance. You can replace it with open ends of a circuit. does not let current flow through the circuit. Okay, and after long time has passed, inductor has no role in this circuit. You have resistance, you replace inductor with a simple plain wire, conducting wire. This will be our circuit. After long time has passed, you will have current flowing in this circuit as per your Ohm's law, as per your Kirchhoff voltage law. So inductor capacitor, in a way they are exactly opposite how they are at the beginning, at a long time has passed. Okay, one question we will see based on this. Steady state. Steady state means after this circuit has been running for a very long time. At steady state, the charge on the capacitor as shown in the circuit below is how much? Okay, so steady state, like I said, after long time has passed, after long time this circuit has been kept on. This capacitor, you see, it will be fully charged. You have positive terminal of battery left side, so here you will have positive charge. This plate will have got positive charge, let's say plus Q, and the opposite will have got negative charge, let's say minus Q, and there will not be any current flowing in the branch that has capacitor. The rest of the circuit will have current flowing. However, you have 5-volt battery, current will be coming out of it. 5-volt battery, current will be coming out of it. It will be coming to this junction, but it won't enter this capacitor branch. Entire current will flow through this 10 ohms. Out of 10 ohms, once again, no current, no charge transfer in this branch. Entire I will just flow through the 15 ohms resistance, and it will flow back into the battery. We have to find charge on the capacitor. We will require this current flowing in the circuit, so you can use Kirchhoff voltage law in this circuit. You can start from any point you want. You can start from this point, start writing the potential differences. From this point we will go to the left. You have a 5-volt battery going from negative terminal to positive terminal. Voltage will increase, potential will increase. It increases by 5 volt, so write plus 5. Then you have I current flowing through 10 ohms resistance, and you are going in the direction of current, so potential decreases. It will decrease by IE into R. You keep going till you reach this point again. You have 15 ohms resistance in your path. You are going in the direction of current, so once again, when you cross this resistance, potential will decrease, and it will decrease by I into R again. Once you have crossed this, there are no more elements. You return to the point as per Kirchhoff voltage law. For a loop, this will be 0. Net potential change once you have crossed all the circuit elements will be 0. Solve this for I. 5 minus I into 10, 15 into I. This will be 25I. I will be 5 by 25 or 1 by 5 ampere. Okay. Now as to why we need I, we need to calculate charge on the capacitor, and for that we will need to run another Kirchhoff voltage. Write Kirchhoff voltage this way. This is KVL1. Start from here. You have I current flowing through 10 ohms resistance. You are going in the direction of current, so once again potential will decrease. It will decrease by minus I into R. Then you have a capacitor. This side you have negatively charged plate, charge is minus Q. The other side you have positively charged plate, charge is plus Q. So when you go from negatively charged plate to positively charged plate, potential increases, and it increases by a magnitude of Q by C. This you do remember. Potential change across a capacitor is of Q by C. So in this loop I did minus I into R plus Q by C, and then back at the point is equal to 0. Q by C Send this to the other side. It will be 10 into I, Q by C. I we calculated. I is 1 by 5 ampere. So Q by C 10 by 5 is 2. And this is potential change. So its unit will be volt. Q will be 2 times C, 2 times capacitance. Capacitance is 8 microfarad. Now you can convert it into SI if you want. But in case you write capacitance in microfarad unit, if I write 8 microfarad here, 8 into 2 is 16. The charge I will get, it will be directly in microcoulomb. So you do not need to convert units again and again. So our charge on capacitor, 8 microfarad capacitor at a steady state, it will be 16 microcoulombs. In the given circuit, the sliding contact is pulled outward such that electric current in the circuit changes at the rate of 8 ampere per second. At an instant when resistance is 12 ohms, the value of the current in the circuit will be, okay. You have a battery, a direct battery of 12 volts. You have 3 Henry inductor and you have a variable resistance. What we are doing, we are pulling this slider outwards towards right. What that will do, it will end up increasing this resistance. And if this resistance increases, current in this circuit will be decreasing. The rate at which current decreases, they are saying changes at the rate of 8 amperes per second, but current rate change essentially it is decreasing. It will be minus 8 ampere per second. Again you are pulling this slider outward, so you are engaging more resistance to the circuit. Your current in the circuit will be decreasing. Rate of change of current, you write it as di by dt. Current changes at the rate of 8 ampere per second, but it is essentially it is effectively negative. It is decreasing, so it will be minus 8. Okay. At an instant resistance is 12. They are asking the current in the circuit. See, this inductor you see, inductor of 3 Henry inductance. As per Lenz's law, it will produce EMF. See, positive terminal of battery, negative terminal of battery, current will be flowing in this direction. And since we are moving the slider outward, since you are putting more resistance, this current will be decreasing. What inductor does? Inductor provides EMF. It induces EMF so that it can support this current. If this current is decreasing, this inductor will provide EMF in a way that supports this current. So in order to support the current, it will have to produce EMF in this way. This will be negative, this will be positive. And as to how much EMF it will induce, it is given by L di by dt. This will be the induced EMF. So inductance is 3. Rate at which current is changing, it is minus 8. But with this mod sign, it becomes positive. Logically also, induced EMF should be this way, minus plus, so that it can support the decreasing current. Okay, how much will this be? It will be of 24 volts. At an instance, resistance is 12. So redraw the circuit diagram with this much induced EMF and when resistance is of 12 ohms. Your circuit will look like this. You have 12 volt battery. We did not do anything here. This coil you see, inductor, it is producing induced EMF. It is inducing EMF of 24 volts. And in this variable resistor, resistance is of 12 ohms. They are asking you how much will be the current in this instant, at this very instant. So here also you have to apply Kirchhoff voltage law. Minus to plus, it will be plus 12. negative to positive again plus 24, and if I current is flowing through 12 ohms, it will be minus I into R. This will be equal to 0 as per Kirchhoff voltage law. 36 minus 12 into I is equal to 0. I will be 3 ampere. We have one question from alternating current here. In a series LCR circuit, resistance is of 300 ohms, capacitance is of 25 nanofarad. Nano conversion is 10 to the power minus 9 farad, and an inductor of 100 millihenry. Millihenry to Henry conversion is 10 to the power minus 3. They are used. For maximum current in the circuit, the angular frequency of AC, omega they are asking. Now, in simple LCR circuit, you have capacitor, you have inductor, you have resistance. We cannot do anything about the resistance, but capacitance and inductance we can here we are changing the frequency of source. Capacitance and inductance part we can do a little bit. See, resistances are effective resistance that the inductor shows. We call it reactance, inductive reactance. Inductive reactance we denote it with XL or chi L. This is omega into L. And effective resistance that the capacitor shows, we call it capacitive reactance. Capacitive reactance we denote it with XC. XC is 1 by omega C. So net of these two, it is XL minus XC. Okay. If we minimize this, we can minimize the impedance. I will show the expression for impedance as well. Impedance is square root of R square plus XL minus XC square. Resistance part we cannot do much, but if we minimize this XL minus XC part, if you can somehow make it 0, your impedance will be minimum, and then your circuit will be flowing maximum possible current. So to do that, our XL minus XC must be 0. Omega L minus 1 by omega C must be 0. Omega L must be equal to 1 by omega C, and therefore omega square must be equal to 1 by LC. Omega must be equal to 1 by square root of LC. Now you have to solve this for omega. Omega is 1 by square root of LC. L is 100 10 power minus 3. C in SI unit, it is 25 10 power minus 9. 25 square root is 5, 100 square root is 10, and 10 power minus 3, 10 power minus 9. They will be 10 power minus 12. When you remove them from square root, it will become 10 power minus 6. So this will be 10 power 6 in the numerator by 50. Ten power 6 you can write it as 100 into 10 power 4 and then by 50 will be 2 into 10 power 4 radian per second. One question we have from dual nature. two metals A and B have work functions. Work function is the minimum energy required uh, to eject an electron. If you give an electron if you give an electron less than 2 electron volt, it will never come out. If you give it 2 electron volt, it may come out, and if you give it more than 2, it may come out. But less than 2 electron volt, electron does not come out. That's the idea of work function. It is the minimum energy required to be given to the electron in order to eject it. So for metal A, work function is 2 electron volt. I will write phi A. Phi is work function is 2 electron volt. And for metal B, work function is 4 electron volt. So for the second metal, if you give electron less than 4 electron volt, it does not come out. 4 electron volt is the minimum in order to eject it. More than 4 it can come out, less than 4 it cannot. They are illuminated with light of wavelength 200 nanometer. Find the ratio of maximum kinetic energies of the emitted electrons. So in photoelectric effect, interaction between photon and electron takes place. Photon, or this light you see, 200 nanometer light, it hits the electron. Electron might come out electron might come out without any collisions. It can come out as soon as the photon is hit, or it can undergo collisions. In case photon hits the electron and electron comes out immediately without any collisions, it will have maximum possible kinetic energy. And in case after absorbing photon energy, if electron undergoes collisions, it won't have as much kinetic energy. It's also possible that electron absorbs all the photon energy and spends it all in the collisions. So what we are concerned with are the maximum kinetic energy of electron. The interaction we are interested in, it is photon hitting the electron with its energy at c by lambda, and then electron coming right after without any collisions. So when that happens, kinetic energy, maximum kinetic energy of electron will be energy that the photon gives it minus the work function tax that it has to pay in order to come out of the metal. Work function rule, it's this: photon has to have minimum of work function amount of energy. If photon energy is less than work function, electron does not come out. If photon energy is more than work function, then electron can come out. So when the electron leaves the metal, it loses work function amount of energy. You think of it that way. I'll show a small picture. Suppose you have an electron, a photon hits it with EP of energy. This electron, you see, it is a part of metal. When this electron leaves, it will lose work function amount of energy as well. And when it leaves, it will leave with kinetic energy of photon energy minus work function. So this we need to find for these two metals. Now see, maximum kinetic energy for electrons coming out of metal A, it will be energy of photon. We are using the same photon light, 200 nanometer for both, minus work function of A. And for electrons coming out of B, their maximum kinetic energy, it will be energy of photon minus work function of metal B. Like I said, it absorbs photon energy, but when it leaves, it loses work function amount of energy to the metal. Again, it absorbs photon energy, and when it leaves, it loses work function amount of energy to the metal. This ratio they are asking you to find. So energy of photon, you write it as hc by lambda minus work function of A. Same light So same hc by lambda minus work function of p. Yes. Now see, work function is given in electron volt unit. So uh, instead of changing everything to SI, we can use electron volt value of HC. HC, you see, you can take it as 1240 electron volt nanometer. It's not SI value, it is electron volt nanometer value. This in this electron volt nanometer unit, HC value is 1240. So do remember this and make use of it as well. HC I will write it as 1240 EV nanometer divided by lambda. Lambda is the wavelength of light we use. Lambda wavelength of light we use, it is 200 nanometer minus work function of A, it is 2 electron volts divided by again HC by lambda. HC you take 1240 EV nanometer divided by same light 200 nanometer we are using minus work function of B, which is 4 electron volts. This ratio they are asking you to find. Okay, work out this. 1240 by 200, it will be 6.20 or 6.2 minus nanometer units will cancel here and here. This will be 6.2 EV minus 2 EV. This also 6.2 EV minus 4 EV. So electron volt units, they will get cancelled here. You do not need to go into SI. 6.2 minus 2 is 4.2. 6.2 minus 4 is 2.2. It will be 42 by 22, 21 by 11. Stopping potential for a metal is 1.5 volt when illuminated with light of wavelength 400 nanometer. Find the threshold wavelength of the metal. Energy of photon or energy of light is hc by lambda, and for photoelectric effect to take place, this photon energy must be higher than the work function of metal. If not, photoelectric effect does not take place, electron does not come out. So if I bring phi this side and lambda that side, hc by phi must be greater than lambda. Lambda must be less than hc by phi. Wavelength of the light of photon we use, it must be less than this hc by phi for photoelectric effect to take place. If your wavelength is longer than hc by phi, photoelectric effect does not take place. This hc by phi is called threshold wavelength, and this we want to find out. So wavelength shorter than this can give photoelectric effect, longer than this cannot. Stopping potential of metal is 1.5 volts. In the second experiment of photoelectric effect, stopping potential is the reverse potential required to stop the fastest electron, the highest kinetic energy electron. Our equation is maximum kinetic energy of electron is energy of photon minus work function. To stop fastest electron, highest kinetic energy electron, the reverse potential required, it is stopping potential, and with that stopping potential you have to do electron charge E times V naught amount of work. So you have this, you set up a V naught of stopping potential and it stops fastest electron, highest kinetic energy electron. This So we have this. Based on this, we have to find out threshold wavelength of the metal. Mm. Find out work function from this, or I will rewrite this. E into V naught stopping potential is equal to energy of photon minus phi. Okay, we are using wavelength of 400 nanometer. In place of E, I will write charge on electron 1.6 10 power minus 19. Stopping potential is 1.5 volt. Energy of photon, I will write hc by lambda minus 5, 1.5 volt. Now see, you can convert volt into electron volt by multiplying it with see 1 electron volt is 1.6 10 power minus 19 joules. If this 1.5 volt is multiplied with 1.6 10 power minus 19 coulombs, this becomes 1.5 electron volt. Do you remember this? Then we will use these units only. Hc we will take 1240 electron volt nanometer. Upon lambda wavelength we will take 400 nanometer. This will give us the work function of metal. This, how much will this be? It will be 3.10. Unit is EV. Work function will then be 1.6 electron volt. Threshold wavelength, like I have written there, it is hc by phi. Hc I will again take in electron volt unit. It is 1240 electron volt nanometer, and phi we found out it is 1.6 electron volt. So this will be your threshold wavelength. Answer will be in nanometers. (775 nanometers). So wavelength shorter than this can produce photoelectric effect, longer than this cannot. This is from hydrogen Bohr model. The number of spectral lines emitted by atomic hydrogen, that is in the fourth energy level. Fourth energy level. So first energy level is n is equal to 1 over ground state. Second energy level will be n is equal to 2. Third energy level will be n is equal to 3, and fourth energy level will be n is equal to 4. This. Now, how many spectral lines will it produce? Hydrogen atom, it produces, it emits electromagnetic wave. Hydrogen atom, it emits electromagnetic wave when electron de-excites. So from higher energy level to lower energy level, when it jumps, it gives out an electromagnetic wave. We have to think of number of possible ways electron jumps out. We have to think of possible de-excitation ways. So from 4, how many ways it can de-excite? From 4 it can jump into 3. You will have one electromagnetic wave coming out. From 4 it can jump into 2. You will have another electromagnetic wave coming out. Or from 4 it can directly jump into 1, and then again it will have one electromagnetic wave coming out. But these aren't the only ways EM waves can come out. Intermediate de-excitations can also take place. So from 4 to 3 we got 1, 4 to 2 we got 1, 4 to 1 we got 1. But if it goes from 4 to 3 and then 3 to 2, you will have another electromagnetic wave coming out. From 3 to 1, if it directly goes, again it will have one EM wave coming out. And from 2 to 1, if it goes, again it will give out one electromagnetic wave. So from 4 to 1 it can de-excite in 6 different ways. It can go from 4 to 3 or 4 to 2 or 4 to 1. You have 3 lines coming out. Or it can go from 4 to 3, then 3 to 1 you have one line coming out. 3 to 2 you have one light coming out, and then 2 to 1 you will have one light coming out. You can remember the formula. If this number is large, number of field lines, number of spectral lines coming out, it is n into n minus 1 by 2. So here if you put n is equal to 4, you will have 4 into 4 minus 1 by 2. It will be 4 into 3 by 2. You have 6 lines coming out. Instead of 4, if they say number of spectral lines emitted by atomic hydrogen that is in the 6th energy level, you do n into n minus 1 by 2, 6 into 6 minus 1 by 2. You will have 15 lines emitted by atomic hydrogen in that case. An electron in the ground state of the hydrogen atom has the orbital radius of 5.3 10 power minus 11, while that for the electron in third excited state is 8.48 10 power minus 10. Ratio of de Broglie wavelength of electron in the ground state to that in the excited state. See, ground state means n is equal to 1. First excited state is n is equal to 2. Second excited state is n is equal to 3. And here you have third excited state, meaning n is equal to 4 they are talking. The ratio of de Broglie wavelength of electron in ground state, so in the ground state, to that in the excited state, in the n is equal to 4 state, they are asking this ratio. Now, like how you treat light as particle in photoelectric effect, light can act like a matter. Particles can act like waves in certain situations. And corresponding to those particle waves, you have de Broglie wavelength. De Broglie wavelength is Planck constant h divided by linear momentum of the particle. This is your de Broglie wavelength of particle, electron here. So see, as per Bohr, we know that angular momentum of electron in the nth orbit, it is quantized, it is given by nh upon 2 pi. Angular momentum in nth orbit, I will also write it as mvr in nth orbit, nh upon 2 pi. So your mv you can write it as nh upon 2 pi r. Further, your radius of hydrogen atom, radius of electron, nth orbit, it is proportional to order of the orbit square divided by z, but here we are talking hydrogen only, so z stays 1. So with this in mind, you can write mv as h by 2 pi n by r. I wrote it as h by 2 pi n by r. And if your radius of orbit is proportional to n square, you can write mv as proportional to n by n square, or simply 1 by n. Linear momentum of electron, it will be proportional to 1 by n. So inverse of momentum of electron will be proportional to n. And de Broglie wavelength, as you can see, it is h upon mv h is the constant, so de Broglie wavelength will be proportional to n. De Broglie wavelength for the first state divided by de Broglie wavelength for the uh, third excited state or fourth state, it will be 1:4. This they are asking. Frequency of revolution of the electron in Bohr's orbit varies with n, the principal quantum number s. So we need to find out how the frequency changes with n. Okay. Our electron revolves in the atom due to the electric force provided by the positively charged nucleus. So we write it's Bohr's orbit. Okay. So we write centripetal force provided to the electron as mv square by r. It is due to the electric force between nucleus and the electron. Nucleus provides k into Z into E by r square of electric force on the electron. From this you can write mv square as kz E square by r. And second thing we can work with, it is Bohr's second postulate, that angular momentum of electron, which is mvr, it is quantized and is nh upon 2 pi. Making use of this, we need to see the relation between frequency and n. First is centripetal force is provided by the electric force. So I wrote k q1 z q2 is e by r square. And secondly, angular momentum of the electron mvr is nh upon 2 pi. So using this, we need to figure out the frequency of revolution. Okay. If I divide these two, if I do mv square upon mvr, I will get kz square by r and nh upon 2 pi. M you can cancel and 1 v you can cancel, 1 r also you can cancel. If you will see, your v on left side is equal to kz e square 2 pi by n into h. Everything you see here, kz e square 2 pi and h, for a particular atom it will be a constant. So you can write v is proportional to 1 by n. Now time period of revolution of electron, you can write it as 2 pi r, the perimeter of the circle it does, divided by linear speed v with which it does, or go from v. Linear speed v with which it covers the perimeter of 2 pi r divided by time period t. And then you can write t as 2 pi r by v. Frequency is inverse of time period, so it will be v upon 2 pi r. This will be your frequency, v upon 2 pi r. Now you have to see how is it proportional. This v you see, it is proportional to 1 by n, and radius of Bohr orbit is proportional to n square. So your frequency will be proportional to 1 by n for v and 1 by n square for r. Frequency will be proportional to 1 by n into n square will be proportional to 1 by n cube. We have one question from digital electronics semiconductors. Output of the circuit is 0 for which of these inputs they are asking. So for a simple circuit like this, you do not need to go into Boolean algebra. You can simply make a truth table and that should be enough. You have x and y going into the input of OR gate. This is OR gate. This is OR part and this is a NOT part. So this is NOR gate. So start making truth table. Start with x and y. Make 0 0, x0 y0, x0 y1, x1 y0 and then x1 y1. X and y are fed into OR gate. OR gate output I will write it as Z. Okay. OR gate output is Z. The logic of OR is if one of x or y is out is on, output will be 1. If both of them are 0, output will be 0. Once again, x y put into OR gate, output logic of OR gate is if x or y, one of them is 1 or both of them are 1, output will be 1. If both of them are 0, then only output will be 0. So OR gate output we are calling it Z. x0 y0, here they are both 0, so your output will be 0. x0 y is 1. Now if y is 1, output is 1. x1 y0, that's fine, output will still be 1. x1 y1, they are both 1, so output will be 1. So OR gate logic is this. Now you put this OR gate output Z into a NOR gate. So for NOR gate, don't do anything different. You write OR gate output and then you negate it. So if you put Z and Z in OR gate, so Z or Z, you do 0 or 0. 0 or 0, it will be 0. 1 or 1, it will be 1. 1 or 1, 1. 1 or 1, again 1. But this gate is not OR gate, it is NOR gate. So your final output, if you call C will be exactly opposite of what OR gate output is. Z or Z we wrote here. C will be exactly opposite of it because it is not operation. So 0 if you negate, it will be 1. 1 if you negate, they will be 0 0 0. Question is, output of the circuit is low for which one? Output of the circuit is 1 for when x and y are both 0. It is 0 for all other combinations. So for when x is 0, y is 0, your output is 1. For all other, your output is 0. Choose the correct answer. So the output of the circuit is 0 for B, C and D. Your option will be D here. That will be it for the physics part. Stay tuned for chemistry. Isha ma'am will be soon here. And all the very best from my side. Do your best on Sunday.
Hello, students. I hope you all are doing well and your preparations are going smoothly. So, my name is Isha Jain and I am taking your chemistry classes. So, in this, we will be doing a few chapters revision, which will include solutions, electrochemistry, chemical kinetics, and biomolecules. Okay, let me open the slide first of all. Yeah, so let's start with our session. So we'll be doing solution, electrochemistry, chemical kinetics, biomolecules, and at the end we will do salt analysis. So what we'll do the revision of a few important topics, that is going to be the high weightage of each chapter and the expected questions which can come in your NEET 2026 examinations. Okay, so let's start with a few revision part. First of all, we have a few formulas for the concentration terms. The first one is molality, which is number of moles of solute and by mass of the solvent. The solvent mass should be in kg. The highlight over here is solvent. The second one is molarity, in which you have number of moles of solute divided by the volume of the solution. The highlight is solution and the unit should be in liter. The next one is mole fraction. Mole fraction is simply number of moles of whatever component that we have divided by the total number of the moles of component. So let's say we have A, B and C in our solution. So we represent the mole fraction by this symbol. I'm writing this as XA. Yeah, you can say psi A. Number of moles of A divided by the total number of moles, which will include A, B and C. Next up we had percentage weight by weight, which is simply mass of the component, whatever solute we have, and by the total mass of the solution into 100, making sure both of them should be in liter or both of them should be in ml. Don't do 1 liter 1 ml. Okay, so mass of the, you can say, solute divided by the mass of the solution. Percentage volume by volume is simply mass of the volume of the solute by the total volume of the solution. Again same, both of them should be in liter or in ml. Here both of them should be in kgs or in gram. Next we have volume weight by volume. So again this is the mass of the solute divided by the volume of the solution. Now this should be in gram and the other one should be in ml into 100. These are the formulas. Now we also have few relationships between them. The first one is the relationship between molality and molarity. Okay, so we have the formula molality is equals to 1000 into molarity divided by 1000 into density minus molarity into mass of the solute. Okay, this is the formula and the relationship between molality and molarity. Next up we have relationship between molality and mole fraction. The relationship is that molality is equals to XA by XB into 1000 by MB. Okay, so this is the formula that we have. Next up, you can say the relationship between molarity and percent by weight or percent by volume. So we have volume, percent by volume into 10 divided by molar mass of the solute, and there's also one relationship with percent weight by weight. So weight by weight percent into density into 10 divided by molar mass of the solute. So these are the few relationships that we have which will be helpful while solving the question. Okay, next topic that we have is Raoult's law. Simply Raoult's law say that when you are mixing two components together, both of them being volatile and miscible, okay, both of them are volatile and miscible. So in this case, for the first component, the vapor pressure that will come out will be P0 A XA. Now P0 A is the pure vapor pressure for that component and XA is the mole fraction of the first component. Similarly for we also have for B. So we have PB is equals to P0 B XB. Now the total vapor pressure will come out to be PT is equals to P0 A XA plus P0 B XB. This is the Raoult's law which relates the vapor pressure when we have mixture of two components, volatile and miscible. Next up we have ideal and non-ideal solution. So ideal solution are those solution which follows Raoult's law at all temperature and at all composition, whereas non-ideal solution are those solution which does not follow Raoult's law at particular concentrations, compositions and temperature. So for ideal solution, the formula Pt is equals to P0 AXA plus P0 BXB is true. It is equal to that, right? But for non-ideal solutions, we have two types of non-ideal solution. They are not equal to the formula. So with the negative, when we have negative deviation, you can simply write that the PT which is observed is less than the total pressure which you are calculating using this formula. But for positive deviation, we have PT, total pressure which is observed, is more than the total pressure which you are calculating using the formula. Now all of this happens because of the difference in interaction between the components. Now in ideal solution, we assume that the interaction between A molecules, B molecules and AB molecules are same. But in non-ideal solution, the interaction between AA and AB are different, or you can say AAAB is different. In the negative deviation, we have the after when you are mixing, A and B interaction becomes more, whereas in positive deviation the interaction becomes less. So when you have in negative deviation, what happens? So you have AA, something like this, and what will happen? Because of AB, the interaction, what it has increased. Now interaction has increased, you can say it looks like this, and now you can say that the volume, they're occupying a little less volume, right? So the volume of the mixture will be less than 0, it will be negative, and delta H mixing will also be less than 0, negative. Now for positive deviation, this is the interaction between AA. What happens? The interaction decreases between AB molecule, right? Something like this. So what happens is, so you can say it is occupying more space, and thus you can say that the volume will increase, and thus the volume of the mixture is more in this case, whereas the delta H, which is the enthalpy, is also more than 0. Now we talk about the change in entropy and Gibbs free energy. Now entropy, whenever you're mixing something, the randomness is increasing, and because of that, the delta S mixture will always be more than 0 in all of these cases, even if you are mixing ideal or non-ideal solution. And for delta G, now see, this is a spontaneous mixing, is spontaneous, right? When you take water and you mix salt in it, it happens as it is, it happens by its own. So that is why delta G will come negative. That means that the reaction that we have is a spontaneous reaction. Okay, so this is ideal and non-ideal solution. There's also one graph for ideal solution. If we draw the graph between mole fraction and the vapor pressure, so here we start from XA equal to 0. That means only XB is present. I mean, when XA is equals to 0, A is not present in there, only B is present. And when XA is 1, that means XB has to be 0. That means A is only present, B is not present. So this will become the P naught A value, pure A. This is the P naught B value. Okay, and the graph for the ideal solution looks like this. Whereas for the non-ideal solution, the graph is not like this. It is not straight, but there is some deviation. And the deviation is that for a negative deviation, we have our graph lesser than the expected. So we were expecting our PT. This is the graph for PT. We were expecting, and we actually got a little lesser value. And whereas for the positive deviation, we have more value than the expected value. That is why positive deviation. Next up, we have a colligative properties. So we have a total of 4 colligative properties, which are relative lowering of vapor pressure, osmotic pressure, elevation in boiling point, and depression in freezing point. These are the 4 colligative properties, and the formulas are written over here. So for the first colligative property, which is relative lowering of vapor pressure, the formula is P naught minus P by P is P naught. This is the relative lowering of vapor pressure, and the formula is simply IXB, or you can say IX for the solute. which also you can write as I NB by Na plus INB. This is the relative lowering of vapor pressure, which you can also represent in the other way. Okay, the other way to represent is P naught minus P by P. Now this is not relative lowering of vapor pressure. This is not a colligative property, but this is simply used in our questions so that the calculation becomes easier, because the simple formula is this: NB means the number of moles of the solute by the number of moles of the solvent. Okay, so this is not a colligative property, this is not relative lowering of vapor pressure, but we can use this formula if we want to calculate the number of moles of solute or number of moles of the solvent. Okay, next up we have relative lowering. Next up we have elevation in boiling point. So simply the formula is delta TB, which is representing the elevation, is equals to I kbm. Here m is the molality, kb is the molar elevation constant, or you can say ebullioscopic constant, and I over here is the Van 't Hoff factor. Next up we have depression in freezing point, which is I kf m. Over here again m is the molality, kf is the molar depression constant or cryoscopic constant, and again I is the Van 't Hoff factor. The last colligative property is osmotic pressure, which is represented by pi, which is CRT, and here I again is the Van 't Hoff factor, C is the concentration in molarity, here it is in molarity, R is the universal gas constant, and T is the temperature. Temperature should be in Kelvin. Now these are the four colligative properties we have. Now I is the Van 't Hoff factor, which is simply the observed colligative property divided by the calculated colligative property. Now the thing is, when you take a solute, okay, it might happen that it is going into the solvent and it is being dissociated and associated. So basically you added, let's say, 100 molecules and you were expecting the results to come from those 100 molecules only. Now because of the dissociation, there is a possibility that you had 200 molecules in the solvent, in the solution, instead of having the 200 molecules. So in that case, we have the observed colligative property for 200 molecules, and the calculated one that you thought was going to happen is only for 100. Okay, so in the case of association, in the case of dissociation, we have two formula. In the case of dissociation, we have 1 plus n minus 1 alpha. In the case of association, we have 1 plus 1 by n minus 1 alpha. Okay, here n is simply how many moles are being how many molecules into are they being dissociated, and I is the Van 't Hoff factor that we have to calculate. I'm taking one example. Let's say we have NaCl. Now NaCl is definitely being broken down into Na plus and Cl minus, so n value becomes 2. Taking another example, let's say calcium phosphate. So it is Ca3PO4 whole 2. So it gets dissociated into calcium plus 2 and PO4 3 minus. How many calcium? 3 and 2 phosphate. So total 5 will be the n ka value. N value will be 5. In the case of association, let's say I'm taking the example of CH3COOH in benzene. So what happens is, in benzene it gets dimerized and 2 molecules will become 1. So I'm writing it like this. They gets dimerized. So instead of 2, now we'll have only 1. So the value of n will now become half, because from 2 it changes to 1. So this is how we calculate the value of n, and this is the case of association. So I value will be 1 plus, it will be 1 plus 1 by n minus 1 alpha. Alpha over here is the degree of dissociation, sorry, degree of association. And in this case, when dissociation is happening, we have I is equals to 1 plus n minus 1 alpha. Again here alpha is the degree of dissociation and n is what we calculated over here. So this is how we are going to do colligative property, and this is the most important topic for this whole chapter. You simply have to use this formula. These are the 4 colligative properties that we have, and then in the case of association and dissociation we'll use 2 different cases. Okay, so then let's solve a few questions which might come in your examination. So I'll be giving you 1 minute for each of these questions. Okay, so solve it. Okay, so let's solve. In the question here it is given that the freezing point depression, okay, that means delta T F value is given, which is 7.10 into 10 raised to the power minus 3 of 0.01 m. That means the molality for this is also given, which is 0.001. Okay, the salt which is given over here is Kx FeCN6. So how is it going to be dissociated? It will be dissociated as K plus and FeCN6 whole minus. Now since there is X over here, we have a total of X K plus. Okay, so the value of N over here will become X for K plus and 1. So this is the value of N. That means when you add this compound, this is a coordination compound, into water, it will be dissociated into X molecules of K plus and 1 molecule of FeCN6 minus. So total value of N will become X plus 1. Okay, so N also we know. What else is given? Kf value is also given. Kf is given 1.86. So simply we have to calculate the value of X. Now we already know the formula. The formula for solving freezing point depression is delta Tf is equals to I Kf m. Okay, the value of delta Tf is already given. Delta Tf is already given, which is 7.10 into 10 raised to the power minus 3. The value of I is what we don't know yet. Kf is given 1.86 and m is given 0.001. From here we'll calculate the value of Van Hoff factor. When you calculate it, you will get a value which is 3.8. Okay, when you solve this, you will get 3.8. Now, how to proceed further? The value of I is what we have got. Now, since in the question they have not mentioned anything about alpha, the degree of dissociation, that means we are going to assume this to be a strong electrolyte, and strong electrolyte means it is going to be 100% dissociated, and that means the value of alpha will be simply 1, and then we can solve it. So in this case, when the value of alpha is 1, we just now saw the formula for calculating the want of factor in the case of association, right? If you solve this, putting alpha value 1, you will get N. That means N and I is the same thing for a strong electrolyte. That means this is nothing but N. So now we have got that 3.8 is equals to N and N is equals to X plus 1. So from here we can solve X will become 2.8. But since 2.8 is not in the option, we can take a nearby answer, which is 3. That means the value of X will be 3, matlab K3FeCN whole 6. This is the answer. Moving to the next question. Solve this. So in this question, we have to take which of them are correct. The first statement is the elevation in boiling point temperature of water will be the same for 0.1 m NaCl and 0.1 m urea. So first statement, let's see if it's correct or not. So the formula that we have is delta TB for elevation in boiling point is equals to I kb m. Now in this question they are saying that the value of m is the same, 0.1 m NaCl and 0.1 m urea. So m is the same thing. Kb is a constant for water, definitely is going to be the same. That means the elevation boiling point depends only on the want of factor in this case. Now if we compare between NaCl and urea is a non-electrolyte, that means the value of I will be 1. But for NaCl being a strong electrolyte, I will be equals to N and the value of N will be 2 for NaCl. That means delta TB for NaCl is going to be more as compared to urea. So this statement will become incorrect. Next statement is azeotropic mixtures boil without change in their composition. Yes, this statement is 100% correct. This itself is the definition of azeotropic mixture, that they boil at constant composition. They do not change their composition when on boiling. Now the third statement is osmosis always takes place from hypertonic to hypotonic solution. Now this statement is incorrect. When we talk about a hypotonic solution is a solution in which the concentration is less, concentration of solute is less, or you can say in this solution the amount of water is more. Now water goes from its higher concentration to lower concentration. In osmosis, water goes from higher concentration to lower concentration. So here in hypotonic solution, the concentration of water is more, and in hypertonic, the amount of water is less. That means the osmosis must be taking place from hypotonic to hypertonic solution, and that is why the statement is incorrect. Now next is the density of 32% H2SO4 solution having molarity 4.09 m is approximately 1.26 gram per ml. Okay, so in this question we have to calculate the density, whether it is coming to be 1.26 or not. Okay, so in this question what is given to us? Weight by weight percent is given, which is 32. Next up is given the molarity. Molarity is given 4.09, and we have to calculate the density. I just told you a relationship between molarity and percentage weight by weight. The formula is percent weight by weight into density into 10 divided by the molar mass of the solute. Okay, so just substituting the value, we'll get 4.09 is equals to 32. Density is what we have to calculate, into 10 divided by the molar mass of H2SO4, which is 98. From here we can calculate the value of density. It will be 4.09 into 98 by 32 into 10. When you solve this, we will get 1.256 or something, some value similar to this. That means yes, this statement is also correct. So the correct answer will be B and D, and out of this we will mark D as the correct answer, that only B and D statements are correct. Okay, so moving on to the next question. These are all the important questions that might come in your examination. This is the pattern which is going to come in your examination. Okay. So in this question, vapor pressure of mixture of 1 mole of A and 2 mole of B is given. We have to see what is happening, whether it is no deviation from Raoult's law or positive deviation or negative deviation. Basically, we have to see whether the mixture A and B is ideal or non-ideal. If it is ideal, then there will be no deviation from Raoult's law, and if it is non-ideal, there can be deviation, maybe positive, maybe negative. That is what we have to see. So here what is given, I am writing for A. What all value is given? P naught A is given 150 torr, and Na is given, means number of mole of A is given 1. For B, it has been given P naught B, which is 250 torr, and the number of moles of B is also given, which is 2 moles. So from here we can calculate the mole fraction of A, which is 1/3, and mole fraction of B will be 2/3. Now mole fraction is what? Number of moles of component A divided by the total number of moles. Total number of mole is 3. Now the formula to calculate PT from Raoult's law is P naught A XA plus P naught B XB. So we have P naught A value is given 150, XA is 1/3, plus P naught B value is 240, and XB is 2/3. So on solving this, we'll get 50 plus, here we'll get 80 into 2, which is 160. Total value we are getting 210 torr. Now the thing is that this is the value that we have calculated. So this is the PT, total pressure calculated. In the question it has been given the vapor pressure of mixture is 200 torr. That means in the question PT observed was given as 200 torr. That definitely means that it is not an ideal solution. Why? Because the calculated and the observed value are different from each other. That means they are not ideal. Now we have to think whether it is positive deviation or negative deviation. Now PT observed and we have PT calculated. Now if the PT calculated is more than PT observed, this means it is a negative deviation. It is a negative deviation from the ideal situation. So the correct option for this will be option number D. There is a negative deviation from Raoult's law. Why? Because the calculated value was more than the observed value, meaning it is a negative deviation. Moving to the next. Here, this is the question of Henry's law. KH value for 3 gases is given. We have to see the solubility of these gases in water. So if we talk about Henry's law, it says that the partial pressure of the gas is directly proportional to the mole fraction of the gas. The partial pressure is directly proportional to the mole fraction, and when we remove the proportionality sign, we get a constant KH. Okay, this is Henry's law. So basically this KH value is inversely proportional to the mole fraction, or you can also say that this KH value is inversely proportional to the solubility. So when KH value is more, the solubility is going to be less. Okay, so here we have 3 gases A, B and C, and the KH value for them is given. For A it's 145, for B it is 2 into 10 raised to the power minus 5, and for C it is 35. Okay, so more the value of KH, less will be the solubility. So KH order first of all is A, C, B. That means the solubility order will be B, C and A. This is Henry's law. Okay, that the pressure is directly proportional to the solubility. More the partial pressure in the air, more will be the solubility in water. And when we remove the proportionality sign, we get KH, which is the Henry's constant. So simply Henry's constant is inversely proportional to the mole fraction of the gas in the solution, or you can say in water. That means it is inversely proportional to the solubility. More the KH value, less will be the solubility, and the answer will be BCA, which matches to option number A. So this is going to be the answer. Last question from this chapter solution. Next we'll move to the next chapter, which is electrochemistry. Okay, so in this question, the correct option for the value of vapor pressure of a solution, we have to calculate the vapor pressure of the solution at 45 degrees Celsius. जिसमें we have benzene and octane. So we have benzene and octane. Here it is given the molar ratio. That means the number of moles are in ratio 3 and 2. So here we can calculate the mole fraction for benzene, which will be 3 by 5. Total number of moles will be 5. And the mole fraction for octane will be 2 by 5. What all we have been given the P naught benzene value, which is 280, and for P naught octane value is given as 420. So simply we have to calculate it. We have to calculate the total pressure. We have to assuming it is a ideal gas. So the formula is simply P naught A XA plus P naught B XB. Here we have benzene, so P naught B XB, plus for octane P naught O XO. So P naught B value is 280 into 3 by 5, plus we have 420 into 2 by 5. We simply have to solve this, and the answer for this question will come out to be 336 mm Hg. Okay, so the answer is option number A. I hope you understood this chapter. So first of all, what we did was that we started with a few concentration terms. So we have to calculate the concentration, which is molality, molarity, mole fraction, percent weight by weight, or you can say percent by mass, percent by volume, percentage weight by volume. And then we saw a few relationship between them. Molarity and molality has a relationship. Then we have molality and mole fraction. Then we have molarity and percent weight by weight and volume by volume. So these are the few relationship. Then we jumped to Raoult's law. So Raoult's law is nothing but to calculate the total pressure when we are mixing two volatile and miscible liquids. Okay, so that is Pt is equals to P naught AXA plus P naught B XB. We also have Henry's law. So Henry's law is basically the partial pressure of the gas, the solubility of the gas which is present is directly proportional to the partial pressure of that gas. So we had the formula P is equals to KH X. Okay, KH is the Henry's constant, X is the mole fraction, which is basically the solubility. Okay, next up we did ideal and non-ideal solutions. So basically if a solution is obeying Raoult's law, matlab Pt is equals to P naught AXA plus P naught BXB, that means it is an ideal solution. But if it is not equal, that means it is a non-ideal solution. So when you calculated the Pt, so if the observed value is less than the calculated value, it's a negative deviation. If it is more, it is a positive deviation. And all of this is because the interaction between the components A and B changes. Okay, in the last we did colligative property, which is again the most important topic for this chapter. So in colligative property, we have four colligative property. The first one is relative lowering of vapor pressure, which is P naught A minus Pa by P naught A, which is equals to I XB. I is the want-off factor and XB is the mole fraction of the solute. Okay, I also told you one more formula which makes a calculation a little bit easier, but it is not the relative lowering of vapor pressure. It is not a colligative property. Next up we have elevation and boiling point, that is delta TB is equals to I KBM. Then we have depression and freezing point, which is delta TF is equals to I KF M. And last we had osmotic pressure, which is simply pi is equals to ICRT. Okay, then in want-off factor we discussed about association and dissociation. The formula for association is 1 plus bracket where we have n minus 1 alpha, and then for association we have 1 plus in bracket 1 by n minus 1 and then alpha. So these are the major important points for the topic solutions. Okay, next up we are moving to electrochemistry. Okay, and in electrochemistry, the chapter in the first part we are going to study about the galvanic cell. So this is an example I've taken of a Daniel cell in which we have zinc and copper. So setup is like this. We have a beaker in which a electrode zinc metal plate is dipped in a solution of the same metal. So we have ZnSO4. In the right side we have copper metal dipped in its own solution connected by a wire, and both of them are connected by inverted U-tube, which is known as salt bridge. So when we are connecting this, what happens is at the anode side it acquires a negative charge, the cathode side acquires a positive charge, and the salt bridge, the function of salt bridge is to maintain the electrical neutrality of the solution, okay, and obviously completing the circuit. So the trick over here is lone. For galvanic cell we have lone, that means left oxidation, anode negative. This is the trick that we need to remember for galvanic cell. So in the left side we'll always make anode, okay, in which oxidation reaction happens and the anode is negatively charged. As we can see, the zinc metal solid is being oxidized into Zn plus 2 and 2 electrons are being released. And in the right hand side, okay, so right side will have reduction, it will be cathode and it will be positive. Okay, so in this again you can see reduction reaction is happening, so copper plus 2 ions from the solution is gaining 2 electrons and copper solid is being formed. Here reduction reaction happens. The overall reaction is represented like this, and this is our galvanic cell. In galvanic cell, now again what we can do is we can calculate the value of E cell. E cell is simply the EMF of the cell. So we can calculate the EMF of the cell, how much volt it is producing, and the formula is the reduction potential of cathode minus the reduction potential of anode. Now this we can also represent in standard terms, which is simply E naught cell. E naught cell will be E naught reduction potential of cathode and E naught reduction potential of anode. This naught represents standard condition, which simply means that we are doing the experiment or we are doing the calculation in the standard temperature, which is 25 degrees Celsius, standard pressure, which is 1 atm, or you can say 1 bar, and the concentration that we are taking for electrodes, मतलब cathode and anode, are 1 m, मतलब 1 molarity. Okay, so we can represent the formula like this, and from here we can also do Nernst equation. So the Nernst equation is simply that E cell, or the EMF of the cell, we can calculate the EMF of the cell when we are changing the concentration of the anode and cathode. So let's say we have a reaction as XA. Let's take the example of zinc and copper only. So we have zinc plus Cu plus 2 will give Zn plus 2 and copper. This zinc over here is solid, is being oxidized to Zn plus 2 aqueous, and copper plus 2 aqueous is being reduced to copper solid. So for this, if we change the concentration, we can calculate what will happen to the EMF of the cell, and the formula that we have is E cell is equals to E naught cell, again the standard condition where the concentration is just 1 m, minus 0.0591 by n. Here n is the number of electrons, number of cancelable electrons involved in the reaction, and then we have log Q. Now Q is simply the reaction quotient. Okay, so in this case we'll write product by reactant. Okay, reaction quotient is written in the form of product by reactant. Now solid will not be considered. We never write reaction quotient with solid, only Zn plus 2 concentration will be written, and again zinc will be ignored, and then we'll write plus 2. So basically when you have pure solid and when you have pure liquid, we do not include them in the reaction quotient because simply their value, the active mass of solids and liquid is 1. So that is why we can neglect it. This is our Nernst equation. Okay. Now this is when there is no equilibrium established, that is why we have written it as Q. Now when an equilibrium is established, in the case of equilibrium what happens is delta G becomes 0, and because of that E cell also becomes 0. So when you are doing this, E cell will become 0, and the formula for E naught cell will be simply 0.0591 by n, and then you can simply write log K, and with this formula we can calculate the equilibrium constant. If we know the value of E naught cell, we can calculate the equilibrium constant. Now to make our calculation easier, what we can do is instead of writing 0.0591, we can simply write 0.06. This will make our calculation a little bit easier. Okay, so this is Nernst equation. Next up we have concentration cell. So basically concentration cell means that the cathode and the anode that we are taking are made of same material. Okay, the cathode and the anode are made up of the same material. You can say the electrolyte solution at the cathode side and at the anode side is made up of the same electrolyte. The difference is the difference in the composition. The difference is in concentration. So when you have electrolyte concentration cell, what changes? We're changing the concentration of the electrolyte, as you can see here, C1 and C2. But when we're talking about electrode concentration cell, what we're doing is we're changing the concentration of the electrode. So this is only possible when you have gas or aqueous solution in the case of electrodes, right? So here we have taken the example of hydrogen. So we are changing the electrode composition or concentration. Okay, so this is concentration cell. Now if we want E cell to be positive, if we want E cell to be positive, or you can say that delta G to be negative, what we have to do is that the concentration at the cathode side, the concentration at the cathode side should be more than the concentration at the anode side for a electrolyte concentration cell. Now in the case of concentration cell, the most important point that we need to remember is E naught cell is going to be 0. Okay, so cathode side should be more than the anode side, and for the electrode concentration cell, the anode side should be more than the cathode side. Let's understand this with the help of an example. So we have, I'm taking the example of, let's take the example of PT. We have H2 gas, H plus salt bridge, H plus and H2 gas, and then again PT. So basically what we write is, this is the representation, which is A, B, C. A is anode on the left side, C is cathode on the right side, and B is the salt bridge. Okay, first of all we'll write the salt bridge, and then on the left hand side we'll write the anode. Anode में क्या होता है? Anode में हो रहा है oxidation. Anode oxidation reaction takes place. So basically H0 oxidation state to H plus oxidation state. In the cathode side, reduction happens. So plus 1 oxidation state to 0 oxidation state. Now basically H2 is the electrode in these cases. Now the simple thing is that we cannot tie the wires. If you see the representation here, what we have to do is we have to tie the wires over here, okay, on the electrode. Now H2 gas mein to we cannot tie a wire, so that is why we take the help of an inert electrode, which is written PT. PT is here inert electrode, which is not taking part in the reaction, but simply helping us to tie the wires so that the circuit is connected. So this is the hydrogen electrode. Okay, here what I am doing is I am changing the pressure. So let's say this is 1 atm and this is 10 atm. Okay, what I have done is the concentration of H plus is same in both the cases, but the pressure of the electrode is changing. That means it is an example of electrode concentration cell. So how do we write? First I am writing the anode side. Anode oxidation is taking place, so we have H2 will give 2H plus 2 electron. Okay, here the pressure is 1. And at the cathode side we have 2H plus 2 electron will give us H2. Here the pressure is 10. So when we write the overall reaction, H plus gets cancelled because the concentration is same. Electrons will obviously be cancelled. Here we'll have H2 at 1 atm pressure will give H2 at 10 atm pressure. So now if we have to write the Nernst equation, the formula will become E cell is equals to E naught cell. I'm using 0.06 to make the calculation easier, divided by N. N is simply the number of cancelable electrons. Here the cancelled electron is 2. So N value is 2 log Q. Q means simply product by reactant. So the H2 concentration, here you can say H2 pressure at the, this is from the cathode, divided by the pressure of H2 from the anode. Okay, when you solve this, first thing that will happen is E naught value will become 0. E naught cell for a concentration cell is 0. So we can calculate E cell is equals to minus 0.06 by 2 log cathode is 10 by 1. Okay, overall it will become 0.03 log 10 value is 1. Okay, so we got E cell value as negative. So that means the delta G value, delta G formula is minus NF E cell, right? This is the formula. So minus minus it will become plus and delta G plus means the reaction is non-spontaneous, which we don't want. For galvanic cell to work, basically what we are doing, we are converting the electrical energy, we are converting chemical energy into electrical energy. So basically we are doing a reaction and electricity is being produced. So for this to work, delta G should be negative. That means the reaction should be spontaneous, and here delta G is coming out to be positive. When it came out to be positive, when the pressure at cathode is more than anode, and here it was simply written, for electrode concentration cell, the pressure at anode should be more than that of cathode. Only then this will be spontaneous. And this is the reverse in the case of electrolyte concentration cell. And this is again important. Why? Because just a simple statement will come that for electrode concentration cell, it is spontaneous when P2 is more than P1, and you have to say false. It is not true. P1 should be more than P2. So for electrolyte concentration cell, cathode ka concentration should be more. For electrode concentration cell, anode ka concentration should be more, or you can say pressure should be more. Okay, this was about concentration cell. Next up we have electrolysis. So in electrolysis, what we do is we take a beaker, we take two metal, which is again cathode and anode, and we connect it to a voltage source. Basically we are connecting it to a battery. So the one which is connected to the positive terminal of the battery will become positive, and the one which is connected to the negative terminal of the battery will become negative. Here the change is that the anode is positive. Here we have loop. In the case of electrolysis, we have loop, matlab left oxidation, anode is positive. So this is where many students do mistake. They confuse between galvanic cell and electrolytic cell, and they are using lone in all of the cases. Okay, don't do that. In electrolytic cell we have loop. Here left oxidation, anode positive, and cathode is negative. So what happens in electrolysis is that we have taken a solution in our beaker. Let's say I've taken NaCl, molten NaCl. Okay, I've taken molten NaCl. This is my anode, this is the cathode. Anode is positive, cathode is negative. They're connected by a battery, something like this. So in NaCl, molten will be broken down into Na plus and Cl minus. So basically what we have over here is, in the solution we have Na plus ions and we have Cl minus ion. Now this Na plus will go which side? It will go towards the cathode, and the Cl minus will go towards the anode. So in the anode, what is happening? Oxidation reaction is happening. So Cl minus will be oxidized to, so oxidation state is -1 as of now. It will become 0, so it will be oxidized to Cl2, and it will release 2 electron. So this is our reaction. At the cathode side, who will go? Cathode is negative, so a positive ion will go towards the cathode. So basically who is going? Na plus is going towards the cathode, and it will get reduced. That means it is going to gain an electron and it will be converted into Na. So this basically is our electrolysis. Now there are more cases in the case of electrolysis. We can also take the example of aqueous NaCl. So in the case of aqueous NaCl, we have two categories. Okay, we have Na plus and Cl minus ions, so definitely will be there. Since we're talking about aqueous solution, we'll also have water. Okay, and water also can be oxidized or reduced, right? The trick here is, instead of writing water, we can also write H plus and OH minus. So we have to choose between these, between Na plus and H plus. Basically Na plus and water, actual thing is Na plus and water, and Cl minus and water. Okay, but I am saying Na plus and H plus, Cl minus and OH minus. That's the trick. So whenever you have to choose, we'll always choose H plus. H plus will be the one that will go towards the cathode. Okay, simple reason is that the SRP value, standard reduction potential, okay, the standard reduction potential for H plus is lower. Okay, so it's higher, so it will want to get reduced. The standard reduction potential of H plus is higher. That means it will want to get reduced. Okay, so I was telling you the trick. The trick is to always choose H plus. Okay, except for the metals, when you have copper plus 2, Hg plus 2, you have Ag plus, you have Au, you have platinum. Okay, when you have these metals, you have to choose them instead of H plus. So it is CHAPA. So except for copper, mercury, gold, platinum and silver, we have to always choose S plus. So if it is K plus and H plus, we will choose H plus. If it is Mg plus 2 and H plus, we will choose H plus. If it is copper plus 2 and H plus, we will choose copper. Okay, so this is the trick. So whenever you have to do reduction, we have to do electrolysis, reduction and oxidation, and you have multiple ions, so we have to select between them. Okay, so when we are selecting for the reduction, we will select H plus except for CHAPA, and for this Cl minus and OH minus, we will select Cl minus. Simply the trick is whoever has lesser oxygen will be oxidized. Okay, why? Because the SRP value, the standard reduction potential value pe depend karta hai. Whoever will have lesser standard reduction potential value will be oxidized. So we'll choose here Cl minus. So what will happen at the anode? At the anode, again Cl minus will be oxidized to Cl plus 2, and at the cathode what will happen? At the cathode, Na plus ke jagah H plus will be reduced to H2. So when you are doing electrolysis of aqueous NaCl, what will happen? At the anode, Cl2 gas is being released, and at the cathode, H2 gas is being released. Okay, and you can use this trick for all of the cases. Just say, let me take an example of aqueous copper sulfate. Okay, so in this also category is copper plus 2A. We have SO4 2 minus, and aqueous means water is also there. So I am writing instead of water H plus and OH minus. So out of these two we will choose copper plus 2, because we always choose H plus except for this case. So we'll choose copper plus 2. And in these two cases we'll choose whichever has lesser oxygen, which is OH minus. So OH minus will be oxidized at the anode, and Cu plus 2 will be reduced at the cathode. So this is all about electrolysis. Next up we have Faraday's first and second law of electrolysis. The first law says that whatever the mass is being deposited at the electrode is directly proportional to the charge. Okay? Or you can also say IT, I into T, current into time. So we have W is directly proportional to I into T. Okay, when you remove this, we get a value Z. So we have ZIT. When you remove a proportionality sign, we get a constant. This constant is known as electrochemical equivalence. This is Z. So basically, when you give 1 ampere current for 1 second, the amount which is deposited over at the electrode is known as the electrochemical equivalence. Now when you expand the formula that we get is M by NF. The formula for Z is M by NF. M is the molar mass, whatever is being deposited. N is the N factor, you can say the number of electrons needed for the deposit. And F is the Faraday's constant, and the value is 96500 coulomb. Or you can also write the formula as so this is what equivalent weight. So this was the molar mass IT by NF, and when you divide the molar mass by N factor, we get equivalent mass. So W is also equals to equivalent mass IT by F. So the formula is W is equals to ZQ. You can also write it as ZIT. Okay, you can also write it as MIT by NF. M is the molar mass, or you can also write it as equivalent mass. I'm writing it like this, MEQIT by F. F is the Faraday's constant, which is 96500. Okay, this was the first law of Faraday. The second law says that when you are connecting 2 or 3 electrolytic beaker in series, so basically what you're doing is you're passing the same current for the same duration of time when it is connected in series. So in this case, the mass that is deposited over at the cathode, okay, the ratio of mass deposited over at the cathode or anode is actually equal to the equivalent mass of the component which is deposited. So we are writing the mass deposited in A and B will be equals to the equivalent mass of A and B. So it is directly proportional. This is the second law of Faraday's law of electrolysis. Next up is the third part of this chapter, which is conductance and conductivity. So conductance is what? It is simply inversely proportional to the we have G is the conductance and R is the resistance. Okay, so the unit for resistance is what? Ohms. So the G value becomes ohm inverse. You can also write it as MHO, or you simply write as Simon. Conductivity, which is represented by the symbol kappa, is again inversely proportional to the resistivity, which is here rho. Okay, the formula for rho is equals to R L by A. So the formula for kappa will become A by R L. Okay. We can write 1 by R as G, which is the conductance, and L by A. This L by A is written as G star, which is known as cell constant. Okay. L is simply the distance between the two electrodes. Okay, these are the two electrodes, anode and cathode. L is simply the distance between the two electrodes, and A is the cross section area of these electrodes, which is dipped inside the solution. So whatever is dipped is the area. Okay, so the formula for kappa becomes G into G star. G star is the cell constant, G is the conductance. Okay, two more formulas we have for molar conductivity and equivalent conductivity. Okay, so the molar conductivity formula is simply kappa into 1000 by M. Writing the M is what? Molarity. And we have equivalent conductance, which is kappa into 1000 by N. N is what? Normality. Now if we have to find out the relationship between them, you can do the ratio, and when we solve it, we will get delta M by EQ is equals to N by M. Okay, normality ko you can write as M into N. Normality का formula क्या होता है? Normality is molarity into the N factor. So after cancelling we will get N. So the ratio between the molar conductivity and equivalence conductivity is simply equal to N, which is the N factor. And last up we have Kohlrausch law. So basically when we are trying to calculate the limiting molar conductance, okay, when we are trying to calculate the limiting molar conductance, that means the conductance at infinite dilution or zero concentration, we are able to do this for strong electrolytes by extrapolating the graph. So when we are doing, we can extrapolate the graph. So this is the graph is in between delta M, which is the equivalent molar conductance, and under root C. So when you are decreasing the concentration, the value of conductance is going to increase. So when we extrapolate the graph, we can calculate the value of limiting molar conductance. But this is only valid for strong electrolyte and not for weak electrolyte. So Kohlrausch law comes to the help. Kohlrausch law ka application is to calculate the limiting molar conductivity for weak electrolyte by using this way. Okay, the second is to find out the degree of dissociation. So we can calculate the value of degree of dissociation alpha. Okay, and the formula is molar conductivity divided by limiting molar conductivity. So we can find out the value of alpha, or degree of dissociation. Now if we're writing an electrolyte, we can also calculate the equilibrium constant KEQ. The formula is C alpha square by 1 minus alpha for equilibrium constant. Okay, so just substituting the value, we get, I'm just substituting the value of alpha, 1 minus delta M by. So this is the equilibrium constant. So this is the second application, and the third application is that we can also calculate the solubility and KSP, matlab the solubility product. The formula is that if we have limiting molar conductance is equals to kappa into 1000, instead of m we write s. So this is the limiting molar conductivity. So at limiting molar conductivity, a sparingly soluble salt is maximum soluble, which is s. And now when we know the value of s, we can also calculate the value of ksp. So if our salt is, let's say, an AgCl, AgCl gets dissociated into Ag plus and Cl minus. So in this case, these are the solubility S and S, and Ksp will be simply equal to S square. So you're also able to calculate the Ksp and the solubility as well, if we know the value of limiting molar conductivity. Okay, so this is Kohlrausch law. So this was all about all the important, very important topics for this chapter. Okay, the galvanic cell, in Nernst equation, and concentration cell. Then we did electrolysis, in which I told you a trick how to know which ion to select if you have multiple ions. Okay, the trick was, at the cathode positive ions will go. Okay, we have to select H plus except for CHAPA. Okay, and then at the anode side we have to select whoever has less oxygen. Okay, then let's do a few questions. Then solve this question. The question is a similar cell to Daniel cell. Basically, a galvanic cell is being constructed, in which you have a electrode X and electrode Y. At electrode X, you can see A is being oxidized to A plus 2. That means over here, oxidation reaction is taking place. Over here, oxidation is taking place, and here at Y, reduction is being taking place. So that means we know when reduction is being taking place, that means electrode Y will be our cathode and electrode A will be anode. How do we know this? By the trick alone. Oxidation means anode. Okay, always oxidation is going to take place at anode. Okay, so okay, let's see the option. Electrode Y is where reduction is occurring, hence it behaves as anode. Bilkul nahi, this is incorrect. Electrode Y is where oxidation is happening, yes, hence it behaves as cathode. No, wrong. The flow of electron is from electrode X to electrode Y. Okay, so yes, this is the correct option. So when we are constructing a galvanic cell, here is our 2 electrode and this is the wire. So electrons come out from the anode. Why? Because oxidation is taking place. Loss of electron means oxidation. So electron come, it flows and goes towards the cathode where reduction is happening. So yes, C is the correct answer for the question. Moving to the next question. The question is, the standard electrode potential of different metals are given. Okay, let's make a list. So we have for copper, we have for zinc, we have for iron Fe plus 2, and then we have for Ag plus. The values are given 0.34 minus 0.76, Fe 0.44, and then 0.80. Okay, we have, on the basis of the standard electrode potential, we have to predict which reaction cannot occur. Okay, so let me arrange it in the order of increasing. Okay, the order is increasing SRP value. So the minimum is for zinc, then we have for then we have for iron, then we have for copper, and then we have for Ag. Okay, when we see the displacement reaction, in that we always say that whoever is on the top of the electrochemical series, this is the electrochemical series here, so whoever is on the top of the electrochemical series can displace whatever is at the bottom. So here we have Zn, which is replacing copper. Can that happen? Yes, zinc can replace copper because whatever is on the top can replace the bottom. So yes, this reaction can occur. Iron is replacing copper. Okay, can iron replace copper? Yes, it can definitely replace copper. Here zinc is displacing iron. Can zinc displace iron? Yes, it can displace iron. Again, the trick is to remember whatever is on the top of the electrochemical series, okay, that can replace the element which is present at the bottom of the electrochemical series. Okay, next up we have Ag is displacing copper. Can Ag displace copper? Not at all. That means this reaction cannot occur. Okay, you have to always remember, in the case of displacement reaction, whatever is on the top of the electrochemical series will displace whatever is present at the bottom of the electrochemical series. So the answer will be D. Next up is find the EMF of the cell. Okay, this is the Nernst equation question. So we have to find out the EMF E cell. Okay, the formula is E naught cell minus 0.06 by N log Q. This is the Nernst equation. So let us find out what is the value of N. That means how many electrons are required. So first of all, I am writing the oxidation reaction. Oxidation is happening from Ni0 to Ni plus 2. So we have Ni will give Ni plus 2 plus it will release 2 electrons. For the reduction reaction, we have Ag plus is being reduced to Ag. So we have Ag plus is being reduced to Ag. How? By gaining electron. Okay, we have to make the electrons cancelable. Ye dekho, it has been cancelled. Both of them has 2 electrons. That means the value of N is 2, which is simply the cancelable electrons. The overall equation will become Ni, which is solid, plus 2Ag plus, or ions are aqueous, will give Ni plus 2, again aqueous, and then you'll have 2Ag, which is solid. Okay, so now just solving it, E naught cell value is already given in the question, which is 1.05 minus 0.06 by N. Value of N over here is 2 cancelable electrons log Q. Again we have to write product by reactant. ठीक है, तो product में solid को हटा दो पहले, तो we'll remove the solids whatever is present because their active mass is a constant 1. So product में we have Ni plus 2 concentration, and in the reactant side we have Ag ka concentration, but we'll square it because of the stoichiometric coefficient. Now the values are already given. I'm solving it over here. So we have 1.05 minus 0.03 log Ni plus 2 concentration is 0.001 divided by Ag plus 2 concentration is also 0.001. You have to you have to square it. Okay, on solving you have 1.05 minus 0.03. If you solve it, you will get log 1000. Okay, this will be cancelled, 1000 will go up. That means you can write it also as 1000 ko you can write as log 10 raised to the power 3. Power will come out, have 1.05 minus 0.09, and then log 10 will be 1. So if you solve it, you will get your answer, and the answer for this question is this 0.9615 volt. This is the EMF of the cell. Okay. Next up, what will be the EMF of the cell if P2 is equals to P 0.1 P naught? Again, this is the question of, as you can see, electrodes are same, anode and cathode are same. That means it is a case of concentration cell. कौन सा concentration cell? As you can see, electrolytes concentration is not given, matlab it is same. Pressure is given, that means it is a electrode. It is a electrode concentration cell. Okay, again in this also we'll apply simply Nernst equation. E cell is equals to E naught cell minus 0.06 by n. The value of n will be 2 log. Okay, the reaction, let me write the reaction. So at anode, oxidation is happening, so you have H2 being converted into H plus plus electron, it will be 2. At the cathode side, reduction is happening, so we have 2H plus 2 electron will give us H2. Electrons cancel. Since it is a electrode concentration cell, the concentration of electrolyte is same, so we have H2. P1 will give us H2 P2. Okay, so we are writing here log P2 by P1, product by reactant. P2 value is already given as 0.1 P1. P1 and P1 cancel, we get a log 0.1. For concentration cell, the value of E naught cell is 0, so the formula will become E cell is equals to minus 0.03 log. 0.1 ko you can write as 10 raised to the power minus 1. Minus 1 will come aage. Answer will be 0.03 log 10 will be 1. Answer will be option number A. So the EMF will be this. Moving to the next question. Mass in grams of copper deposited by passing a current of through a voltmeter containing copper sulfate solution for 10 seconds. Okay, so let's see what all is given. The molar mass of copper is given 63. The value of Faraday is given 96487. Okay, and this is the actual value of Faraday, but we can use 96500 to make a calculation easier. The time is given 100 seconds. Always make sure that when you are solving this question, the time should be in seconds. Okay, if it is given in minutes, convert it to seconds first. And I current is given 9.6487. What we have to calculate is the mass deposited. So I told you the formula of the weight deposited according to the first law is MIT by NF. M value is 63, I value is 9.6487, T value is 100. Divided by n value will be 2, f value is already 96487. So if you cancel out this, यहाँ पे आ जाएगा 10,000, यहाँ पे इसको cancel करोगे तो you will get here on solving this 31.5 by 100. So it is actually 0.315 grams. Simple. Answer is 0.315 grams. Okay, this is the answer. See, what I did is I accumulated all the values that is given. I know the formula, it is MIT by NF. Substitute the value and that's it. Moving to the next question, we have to match the list. So conversion is given and we have to calculate the Faraday which is required. Okay, the answer for this question. So you have 1 mole of H2O, 2 O2. So in this case, what we need to remember is the mole fraction. What we need to remember is the N factor. Okay, so N factor for H2O, oxidation of water, the N factor is 2. That means it will go to 2F. Okay, whatever is the N factor, you can say whatever the number of electrons is involved. Okay, when you are doing this reaction, whatever number of electrons is involved, that will be the N factor and that will be equivalent to the number of Faradays required. So we have H2O being converted to O2. So what we can do is we can write over here half O2, balancing it out. Okay, plus you have 2H plus and then you'll have 2 electrons. As you can see, the number of electrons came out to be 2 electrons, right? So 2 electrons, that means 2 Faradays is required. Next up we have MnO4 minus to Mn plus 2. So we have Mn MnO4 minus to Mn plus 2. So if you remember redox reaction, we'll know that the number of electrons required is 5. Okay? The N factor for this reaction is 5, and that means 5 Faraday will be required. Let me show you the balanced reaction, how to balance it. So we have MnO4 minus is being converted to Mn plus 2. The first step, whenever you're balancing a reaction, a little bit of redox, whenever you're balancing the reaction, okay, first of all, we'll balance the central atom, okay, except whatever is present except for oxygen and hydrogen. Mn already balanced. Now we have 4 oxygen. So the other side, you'll balance. Oxygen is always balanced with the help of water. So you'll write 4 water. Now you can see 8 hydrogen is extra. So over here, you'll write 8H plus. So we have now balanced all the atoms. First step is to balance the central atom except for oxygen and hydrogen. Next step is balancing of oxygen with the help of water. So 4H2O. And the third step should be balancing of hydrogen with the help of H plus. So it will be 8H plus. Now we have to balance the charges. Okay. So here, total charge is 8 plus is here and 1 minus is here. So overall we have 7 plus. And at the right side we have 2 plus. What we have to do is we have to balance the charge with the help of electrons. So whoever has more charge, add the number of electron here. So if I add 5 electrons here, it will be 2 on the both side, right? So that is how we balance the charges and we get 5 electrons. 5 is the N factor, 5 Faraday will be required. That's it. Okay. So next is we have a CaCl2. It will be converted into Ca plus 2 Cl minus. So we have to calculate 1.5 moles of calcium. So from 1 CaCl2 we get 1 calcium. So we'll have 1.5 moles. We need 1.5 moles. That means we also need 1.5 moles of CaCl2. Now we have to calculate the N factor. So for calcium to go to, here we have what, calcium plus 2, we have to go to reduce it to calcium. It will have plus 2 electrons to go to calcium. So that means 1 mole of calcium plus 2 from CaCl2 requires 2 electrons. Okay. So 1.5 mole will require 3 electrons and the N factor becomes 3 and it will be matched like this. Okay. So we will have A2. So eliminated, these two can be the option. Then we have B4. B4 answer will be D. C is 1 and then D will be 3. Yeah, I hope you understood. So basically when you have CaCl2, it will be converted into Ca plus 2 and 2 Cl minus. So basically when you have 1 CaCl2, you have 1 Ca plus 2. And when you have 1 Ca plus 2, it will require 2 electrons to be converted into calcium atom. Okay, so 1 mole of Ca plus 2 requires 2 electrons. So 1.5 mole will require 3 electrons. Next up is conductivity of a centimolar solution of KCl is, conductivity is given. Okay, matlab kappa ka value is given 0.0210 ohm inverse centimeter inverse, and the resistance is given, 60 ohm. That means conductance is given 1 by 60. And we have to calculate the value of cell constant. So it is kappa is equals to conductance into the cell constant. From here we can simply calculate the value of cell constant. This is kappa by G. Kappa value is 0.0210 by G is 1 by 60. You have to multiply 60 to it and we will get answer as 0.021 into 60. Okay, the answer will be 1.26 centimeter inverse. Okay, answer will be option number B. Okay, we're solving it. Chalo, so this was all about the electrochemistry. Okay, we started with galvanic cell, we did Nernst equation and concentration cell. We also did questions related to those. Then we moved to electrolysis, in which I taught you a trick, okay, how to select the ions. And then we did conductance, in which there were few formulas. First one was G is equals to 1 by R. Then we have kappa is equals to 1 by rho. Kappa ka you have one more formula, G into G star, which is the cell constant. And then we have molar conductance, which is kappa into 1000 by m, and equivalence conductance, which is kappa into 1000 by n. So this is all the formula that we have for electrochemistry. Now we'll move to the next chapter, which is chemical kinetics. So for chemical kinetics, what we do is we calculate the rate for this. So the first thing is differential rate law equation. So when you have a general formula in this format, we can calculate the rate of the reaction. We can calculate the rate of the reaction, which is simply minus dA by dt. Minus dA by dt is what? It is the rate of disappearance of A. Okay, this is rate of disappearance of A, which is simply minus dA by dt. But when we add 1 by A, matlab we are dividing it by the stoichiometric coefficient, it will become the rate of the reaction and not rate of disappearance. Okay, then we have minus 1 by B dB by dt. So again, minus dB by dt is what? Rate of disappearance of B. When you divide it by the stoichiometric coefficient, it will become the rate of the reaction. Now this plus dC by dt is what? Rate of appearance of C. This is rate of appearance of C. Okay, which is this is plus dC by dt. Product may we write plus, and when we divide it by the stoichiometric coefficient, it will become the rate of the reaction. This overall is known as differential rate law equation, which is going to be very helpful for you when you're solving the question. Next up, we have rate law equation. So basically rate law, again, when we write a reaction which is similar to that previous one, okay, the rate of the reaction when we are writing in terms of concentration will become equal to the rate constant. Okay, concentration of the reactant raised to the power some values. This is some value known as the order of the reaction x and y. This x and y can be equal to, okay, this x and y can be equal to the stoichiometric coefficient, or it cannot be equal to. So I am writing here pe may or may not be. X and y may or may not be equal to A and B. Why? Because this x and y are order of the reaction, which is an experimental value, and A and B are the stoichiometric coefficient. So when you have a elementary reaction, elementary reaction means the reaction which gets completed in one step. Okay, so when you have a elementary reaction, yes, order and the stoichiometric coefficient is the same. But when you have a complex reaction, okay, for a complex reaction, the order of a reaction is completely experimental value, and in this case it can maybe or may not be. Okay, it may be, there might be a case where x is equals to A and y is equals to B, and there might not be. But in the case of elementary reaction, it's always that x, the order of the reaction, is equal to the stoichiometric coefficient. Apart from that, there is a k is known as rate constant, which depends only on the temperature and not on the concentration of A and B. Is a constant only depending on temperature, and the unit for k is mole per liter raised to the power 1 minus n second inverse. Okay, and this n is what? N is simply the overall order of the reaction. Here, if we take this as the example, the n value will be x plus y. Okay, n is the order of the reaction. Okay, next up we have integrated rate law equation. So in this case, we have first order, zero order reaction, first order reaction, second order reaction, and so on. So first of all, I am writing it in terms of this is the differential rate law equation, minus dA by dt is equals to k. You can also write it as A raised to the power 0, because the order of the reaction is 0. Okay, so a raised to the power 0, but here as you can see it's raised to the power 1 because order of the reaction is 1 and so on. Now the integrated rate law equation, you're going to integrate this and we get A is equals to A naught minus KT, or you can also write A naught is equals to A plus KT, both is true. Next up we have a first order, the integrated rate law equation is A is equals to A naught e ka power minus kt, e raised to the power minus kt, and you can also when you take log on the ln on the both side and solve it, we get kt is equals to 2.303 log a naught by a. Okay, and for the second order reaction is 1 by a is equals to 1 by a naught plus kt. Yeah, the unit of rate constant k, okay, it's molarity per second. Here we only have second inverse for the first order, and for second order it's molarity inverse second inverse. Okay, here it's molarity second inverse. This is the rate constant value. And then for half-life, now half-life is very important. For zero order reactions, A naught by 2k, matlab T half is depending on the initial concentration. Okay, but for first order reaction, T half value is ln 2 by k, or you can also write 0.693 by k. ln 2 value is 0.693 by k. That means for a first order reaction, the T half value does not depend on the initial concentration, and this is for the overall nth order reaction. So from here I can conclude that T half is directly proportional to A naught raised to the power 1 minus n. So if the value of n is equals to 0, A naught raised to the power 1, yes, that is true. If n value is 1, A naught raised to the power 0, which again is true. So this is a very important relationship which can help us to find out the order of the reaction. So let's say 2 T half value is given and they're telling you to calculate the n value. Okay, they're telling you to calculate the order of the reaction, so you can use this relationship. The T half is directly proportional to A naught raised to the power 1 minus n. Okay, next we have Arrhenius equation, which is equals to k, which is k is equals to AE raised to the power minus EA by RT. K is the rate constant, A is known as Arrhenius constant, or you can say frequency factor. ठीक है, E is our exponential, EA is the activation energy, R is the universal gas constant, and T is temperature, which is taken in Kelvin. Okay, and when you have, what will happen, as I told you that the rate constant only depends on the temperature. So when you are changing the temperature, the value of rate constant is also changing, and that is given to us by this equation, that log K2 by K1. When you are changing the temperature, this is two different rate constant is equals to EA by 3.303 R 1 by T1 minus 1 by T2. So what you can think is, अगर K2 ऊपर है तो T2 बाद में होगा. ठीक है, if K2 is above, it is in the numerator, then you'll write T2 later on. If you are writing it like this, you can write it like this also, log K1 by K2. So this means K1 is written in the top, right? So T1 will be written last, at last. So it will become T2 minus 1 by T1. Okay, this is the one. Okay, just depends on what you're writing over here. And last topic that we have is collision factor. So the rate of the reaction depends upon three things. The first one is the steric factor. ठीक है, how the molecules are coming and colliding with each other. ठीक है, probability or the steric factor, you can say it depends on the orientation. Okay, let's say this is how the reaction should have occurred, this is how the molecules should collide. Now if the molecules are colliding like this, the reaction will not occur, right? So definitely rate of the reaction will depend on the correct orientation, or you can say probability of the steric factor. Next, it depends on the frequency, collision frequency. What is the rate of collision, how many times the collision is happening in a given area, in a given volume per unit time, that is known as collision frequency. And it also depends on the energy factor. So my E raised to the power minus EA by RT represents the energy factor. That means the fraction of molecule which have energy more than the threshold energy, or you can say activation energy, so that it can cross the energy barrier and do the correct reaction. Okay, it is represented with a graph like this. let's say this is the energy barrier. So this is the fraction of molecule which has the correct energy to form the product. So the energy required by the molecule to be converted into product, threshold energy, so they should have energy more than the threshold energy, so that they can cross the energy barrier and form the product. So this is the collision theory. Okay, now moving to the questions. Solve the question. Okay, so the question is, for a certain reaction, the rate is given. The rate for the rate law equation is given, that says the rate is equals to k a square and b. Okay, the question is saying when the initial concentration of a is tripled, keeping the concentration of b is constant. So the new rate will become 3, a is tripled, right? Square and b is the constant thing. So we can write r dash is equals to k. You can write it as a square b, and 3 square will become 9. This is the initial rate. So that means the rate of the reaction has increased by a factor of 9. So B will be the correct answer. Next up, we have for a first order reaction. We have a first order reaction. A is giving product. The initial concentration of A, matlab A naught is given 0.1, which becomes, after some time, A value is given 0.001. Time is given 5 minutes. We have to calculate the rate constant. Okay, rate constant, but we have to calculate in minute inverse, so that's fine. The formula is we have KT is equals to, the formula is KT is equals to 3.303 log A naught by A. Okay, we have to calculate the rate constant K, that will be equals to 2.303 by 5 log A naught value is 0.1 divided by 0.001. Okay, A value is now 0.001. So you simply have to solve this. So you'll get 2.303 by 5 log. This you can write as 1 by 10. This you can write as 1 by 1000. So overall you'll get 100. Okay. 303 by 5 log 100 is equals to 2. So the correct answer when you solve this will become 0.9212. Okay, this is the correct answer, which is option number B. So simply you had to use the formula KT is equals to 2.303 log A naught by A. Substitute the value. Since the question asked the rate constant to be in minute inverse, I did not change this in seconds. Okay, but if the question is asking in second inverse, make sure that you are changing this into seconds. Okay, whenever you're solving any questions from physical chemistry, always make sure that you are double checking the units. Okay, otherwise the question might come out, the answer might come out wrong. Okay, next is if the rate constant for a reaction is given K. Okay, okay, the time required for the completion of reaction. Okay, so we have to complete 99% of the reaction. That means if we started with 100 molecule, 99 has been completed, only one is left. So initial, if we are taking it to be 100, after whatever time, that is what we have to calculate. After some time it will be 99% gone. That means 99 molecules has been reacted, only one is left. So again we are going to use the same formula, that KT is equals to 2.303 log A naught by A. A naught will be 100 and A is 1. So K will be equals to T is equals to 2.303 by K log 100. Log 100 value is 2. So that will be 4.606 by K. That is the answer, and the correct is option number B for this. Okay, again simply I've used this formula. We understand that 99% completion means that we had initially 100 molecules, 99% is gone, only one is left. What mistake student do is they write over here 100 and they write over here 99. Okay, this is incorrect. Always make sure that 99% completion means 99 is gone, only one is left. Okay, next is the given graph is a representation of kinetics of a reaction. The y and x axes for 0 and first order reaction respectively are okay. So this reaction has been given that even on changing whatever is on the x axis, the y is remaining constant. So what can happen in 0 order reaction? Okay, so can I say that rate and concentration, this is for 0 order reaction, that even after you're changing the concentration, the rate is not changing. Why? Because the rate constant of a 0 order reaction will become a constant. It only depends on K. Okay, so even after you're changing the concentration, the rate is the same thing. So let's see, 0 order, y is concentration, x is time. No, rate, y is concentration, x is time. Again same thing. Y is rate, yes, x is concentration. Okay, so these two can be the option. A and B are eliminated. Next up, for first order we have to see. So for first order, as I remember, we had T half is equals to 0.693 by K. That means T half is not depending on the concentration. So you can write it like this, that T half, even if you change the concentration, the T half is going to remain the same. And yes, the answer will be option number C. Okay, for this question the answer is C, that for 0 order reaction, if you change the concentration, rate will be the same thing, and for first order reaction, even if you change the concentration, T half will be the same. Okay, next question. For a reaction A gives B, enthalpy for a reaction is minus 4.2 kilojoule per mole. Okay, so a hint is given, it is minus. The enthalpy of the reaction delta H is negative. That means it is a exothermic reaction, and for a exothermic reaction, the energy of the reactant and product energy is less. So okay, we can see here it is same, here it is more, eliminated. Here also it is more, answer is D, simply. Okay, for exothermic reaction, the energy of the product is less than that of the reactant. Okay, and the enthalpy of activation, now we do not need any of those values. Okay, answer will simply be D. Last question. The rate of reaction quadruples when temperature changes from 27 degrees Celsius to 57 degrees Celsius. Okay, so here we have temperature is changing, rate constant is changing. Okay, and we have to calculate the activation energy. This is a question of Arrhenius equation. So you can simply write log K2 by K1 is equals to EA by 2.303 R 1 by T1 minus 1 by T2. So the rate is quadruples, matlab 4 times. So you can write log 4K by K is equals to EA by 2.303 R. T1 is given 27 degrees Celsius, that means 300, and T2 is given 57 degrees Celsius, matlab ki 320. So you just have to solve this. We get log 4 is equals to EA by 2.303. R ka value is 8.314. Here we'll get 20 by 300 into 320, and we just have to solve this. Log 4 value is 0.6. 2.303 into 8.314 into 300 into 320 by 20. This will be the value of EA and the value will be in joules. Okay, so actually the answer that we get is 38040 joules. Okay, but we have to calculate in kilojoules, so it will become 38.04 kilojoule per mole, and the answer is option number D. Okay, always again see the units, we have to convert it into kilojoule, and the option number D. So this was all about chemical kinetics. So we have done 3 major chapters of physical chemistry. Now the next chapter that I'm moving to is biomolecules. Okay, so in biomolecules, first of all, we have carbohydrates, in which we have glucose. Okay, so we are doing reaction of glucose. So the first reaction is with HNO3. So with HNO3, which is a strong oxidizing agent, it is a strong oxidizing agent. What it does, it oxidizes the terminal groups into acid. So we get this acid, which is known as saccharic acid. Okay, so on oxidation we get saccharic acid. When you are adding Br to H2O, it is a mild oxidizing agent. Okay, this is a mild oxidizing agent. It is going to oxidize only the aldehyde group into acid, so we get gluconic acid in this case. Now when we add H2Ni, which is a reducing agent, what it does is it reduces the aldehyde group into alcohol, and we get this sorbitol. So we have all the OH groups. Now when we add NH2OH, which is what? Hydroxylamine. When we add hydroxylamine, what happens? We form a oxime. So the aldehyde groups reacts and form oxime. 15 minutes. ठीक है. Okay. Okay, so next we have with HCN. So reaction with HCN, what will happen? We know aldehyde groups reacts with HCN, addition reaction, and we get hydrochlorohydrin. Okay. Then we have reaction with Tollens reagent. So since we have aldehyde group, yes, it will react with Tollens reagent to give a silver mirror test. Okay, and it will be oxidized into carboxylic acid. Same was Felin solution. Now these are mild oxidizing agent. What will happen? We'll get a red precipitate of Cu2O, and again oxidation will happen. If we have HiO4, now what HiO4 does is it will break all these bonds and it will convert it into acids and हमारा aldehydes. ठीक है. When reacting with, this is phenylhydrazine. When we reacted with phenylhydrazine, remember 3 equivalents are used and we get OSA zone. ठीक है. On reaction with Schiff's base 2,4-DNP or NaHSO3, no reaction will occur. Why? Because they are very weak reagents, and these weak reagents and these weak reagent cannot open up the hemiacetal ring of glucose. ठीक है. the glucose exists in three forms. This is the open chain glucose and two other alpha and beta, which is the hemiacetal ring form. Okay, whenever a reaction of glucose occurs, all of these reagents, what it does is they can open up the hemiacetal ring, but these reagents cannot open up the hemiacetal ring and react with the aldehyde group. Okay, in the hemiacetal form, the aldehyde group is not present. Okay, only hemiacetal group is present, so there will be no reaction. Now with red phosphorus HI, which is a very strong reducing agent, what it does, it reduces all the carboxylic, all the aldehyde, all the alcohol groups, and we get N-hexane, proving that हमारा जो glucose है उसमें all 6 carbons are in a straight chain. Okay, and when we react it with this acid anhydride, this is an acid anhydride, what happens is acetylation takes place and we get glucose pentaacetate. So all the OH groups react and be converted into OCOCH3. So this is all the reaction that we have of glucose. Next up we have disaccharides. So we have 3 disaccharides: maltose, lactose and sucrose. In maltose we have 2 units of alpha D glucose. Okay, in maltose we have 2 units of alpha D glucose and we have a glycosidic linkage. Which glycosidic linkage? This is C1, this is 1, 2, 3, 4. So we have C1, C4 glycosidic linkage in maltose. In lactose is made up of 2 different units, 2 different monomers, which is beta D galactose and beta D glucose. Okay, we have beta D galactose and beta D glucose, and this is the glycosidic linkage, which is C1 and C4 glycosidic linkage. Okay, what you need to remember is the monomeric unit and the number of glycosidic linkage, C1 and C4 in the case of maltose and C1 and C4 in the case of lactose. Sucrose may we have 2 monomeric unit, which is alpha D glucose and beta D fructose. So alpha D glucose and beta D fructose, it forms a glycosidic linkage. See over here, this is C1 and this is actually 1 and 2. So we have C1 C2 glycosidic linkage in this case. Okay, so these are the disaccharides. So in disaccharides, जो हमारा sucrose है, sucrose is the only disaccharide which is a non-reducing sugar. बाकी remaining maltose and lactose are going to be reducing sugars. Okay, next is classification of amino acids. So amino acid is divided into essential and non-essential. Essential are those which is not made in our body, cannot be synthesized in our body. We have to eat it, we have to consume it, we have to take it from the outside. So we have a total of 20 amino acids which are present in our body, out of which 10 are the essential and 10 are non-essential. Non-essential means our body can synthesize on its own, so we do not need to consume it from the outside. So the trick is private Tim Hall. Okay, the trick is private Tim Hall for the essential amino acid, PVT, TIM, HALL. So we have phenylalanine, valine, tryptophan, threonine, then we have tryptophan, isoleucine, methionine, histidine, arginine, leucine and lysine. So these are the classification of amino acid. Amino acid can also be classified on the basis of the presence of number of amino and the acidic and basic group. So if the number of acidic group, which is COOH, I'm assuming that to be X, and the number of amine group, basic group NH2 is Y. So if both are equal, that amino acid is known as neutral. If the acidic group is more, that is known as an acidic amino acid, and if the basic group is more, it is known as a basic amino acid. So we have 2 acidic amino acid, glutamic acid and aspartic acid. We have 3 basic amino acid, which is lysine, arginine and histidine, and remaining 15 amino acids, as I told you that 2 are acidic, 3 are basic, and the remaining 15 amino acid will be our neutral amino acid. Again, next up we have nucleic acid. So there are 2 type of nucleic acid. We have DNA and RNA. So in DNA we have 2-deoxyribose sugar. So the sugar that we have in our DNA is 2-deoxyribose, whereas in RNA the sugar is ribose sugar. In DNA, we have 4 different types of nitrogenous base, which is adenine, guanine, cytosine, and thymine. Whereas in RNA, the thymine is replaced by uracil. This is the difference between DNA and RNA. So we have 2 more terms, which is nucleoside and nucleotide. Nucleoside simply means sugar and base. Okay, this is known as a nucleoside. Nucleotide is sugar, base, all also the phosphate present in it. Now when DNA is being formed, it is a double helical structure, right? So in this, all the nitrogenous bases which are present forms hydrogen bond, and that is how they are combined to each other. So when adenine and thymine are near to each other, they form a double bond, double hydrogen bond. So they have 2 hydrogen bond in between them, whereas guanine and cytosine has 3 hydrogen bond in between them. Okay, let's do questions. With which glucose does not react? Okay, so tolerance test, yes, glucose gives a tolerance test, silver mirror. Schiff's base, no. Schiff's base is a very weak reagent and it will not open up the hemiacetal ring. HCN, yes, HCN can react with glucose, the aldehyde group of the glucose, and produce cyanohydrine. NH2OH, yes, hydroxylamine reacts with our glucose with the aldehyde groups and forms oxime. NaHSO3, no. NaHSO3 cannot, is again a weak reagent and it cannot open up the hemiacetal ring of the glucose. So the answer will be B and E. B. Answer will be option number B. Last question for today. So we have to match the list. Alpha glucose and alpha galactose. Now alpha glucose and alpha galactose are epimers of each other, only change in one of the chiral center. So that is known as epimer. So A will be matched with 4. Alpha glucose and beta glucose. So alpha glucose and beta glucose, again they are only changed in one position. The chiral center has only one change, that is known as anomers. Okay, one change, if there is change in anomeric carbon, those are known as anomers. So this will be 3. Glucose and fructose, these are functional isomer. Glucose may we have aldehyde functional group and fructose may we have keto functional group. So this will become functional isomer. And alpha glucose and alpha ribose, okay, so these will be homologous to each other. So ribose may, when you add one additional carbon with one H and OH, we form glucose. Okay, so the answer for this question will be A4. So these 2 are eliminated. B3, okay, and C will be 1. So the correct answer for this question will be option number B. Okay, that's all for today. I hope you understood. I hope you all understood the topics. Okay, all the best for your examination. And next up, what will happen? Next up, you will study botany. So stay tuned. Take a break of 5 minutes, and then botany mein you will again study all the important chapters that you have with the important topics and a lot of questions which might come in your examination. So stay tuned, and again, all the best for your preparation. I hope you all do great.
Hello, students. How are you all? I hope you all are fine. And myself, Deepti, and I'm going to take botany for today's revision session. So I know this is only few days left for your NEET preparation, but if you will revise it at the end moment nicely and you can retain the things and able to solve the questions, so definitely in your NEET examination, this is going to help you a lot. Okay, so I'm going to take today the topics from ecology students, and let's see what are the different topics which I'm going to discuss. That is organism and population, ecosystem, biodiversity and conservation. Biodiversity and conservation. Okay. So I know this topic is not so much tough and it is easy to understand even, okay, and it is you know, it's what is important over here is this, that to understand the thing nicely so that you will be able to solve the question. Okay, it's like a story that you can understand ecology, yes, and a highly scoring I would say topic it is. So just want to give you a definition firstly what is ecology is all about. So students, ecology is one of that subject which studies the interaction among organisms and between the organisms and its physical environmental condition or physical abiotic environment. Yes, it is one of that thing which gives us the information how does an organisms they are interacting with other organisms, how the organisms they are interacting with the, you know, their external factors. So how the abiotic and biotic factors, you know, ultimately affecting an organism. So that is what we will going to study, and that is what the ecology is all about. It is basically concerned with the 4 level of organizations. If you see, there are 4 level of organization, biological organization. It is concerning, that is organisms, population, communities, and biomes. So in this chapter, we explore ecology at organism and population levels. Okay? So the first chapter is dealing with the organism population. So in that, the ecology is what is dealing with the itself organism and population. And then the next chapter is all about the ecosystem. That is also we are going to discuss. And then the huge diversity which exists in our environmental conditions that we are going to discuss. Yes. So let's see. Firstly, so something we have studied, let's see the questions related to that. So first is the study of interaction among organisms and between the organisms and its physical environment. So what is that study is all about, students? Yes, it is the ecology. Yes or no? Okay, so let me select the good color out of all this, though there are already a lot of good colors. Chalo, fine, I'll take the green one. So ecology, correct. Okay, ecology is basically concerned with how many levels of biological organization. So just I told you it is concerning with the 4 levels of organization. Yes, biological organizations. So that is the 4, students. Okay, and what are those? We just discussed. Kaun se hai wo? That is the organism, the first one, then the populations, then communities, and then the biomes. Okay. Fine, this is done. Ecology is basically concerned with the level of biological organization, organism, population, biosphere, communities, habitat, niche. So it is the communities. The 4 of them is this: organism, the population, the community, and the biomes. Okay. Which one has the correct sequence of increasing organizational complexity? So students, if it is being asked in the examination, organization complexity you have to see. So it starts from the less complex to the more complex. If you see at the organism level itself, okay, let me tell you little about this, the biological level of organization. Give you a brief about it. Biological level of organization. So biological level of organization, if we see, it starts at organism level itself, and that is starting from, let's say, students, if you see, so we have biomolecules, but that is not something which is going to be, living entity. But these biomolecules, they together somewhere, they are forming the structure which is living, that is a cell. They all together form the structure that is tissue. Tissue that will form the organ, okay, and organ that will form the organ system. And this organ system together is all forming the organism. So this is the biological level of organization, starting from, you see, a very smallest molecule, the biomolecule, cell, tissue, organ system, organism. This is how it is moving up, correct? But now let's see itself from the organism. So many organisms together, they will constitute what? The population. They will form the population, students. Okay. So population, after that, they will form the communities. Many population, they will form the communities. There will be a formation of ecosystem where various communities, what you see is lying. Okay. After the ecosystem, there is one more is there, which is that is the biomes. Actually, in between there is one more, that is the landscapes forms. Okay, we'll consider biomes. Fine. And the biomes, okay, I'll write like this rather than this. Biomes. And the biomes together, they will form together a big sphere, that is biosphere. Okay, so it's moving from here to here, and this is what you see is increasing level of biological organization. So it starts from the organism level itself, group of them forms the population, various population of different species forms communities, they're interacting with the non-living components comes the ecosystem. Ecosystem, what you see is all together, so many of them constitute the biomes. In a biome, there can be many ecosystems, and the biomes you see is all present together in a biosphere, which is itself representing what? Our planet Earth. Okay. So this is how the complexity is going on. So now let's see this question. Which one has the correct sequence of increasing organizational complexity? So population, community, ecosystem, and biome. Yeah, this itself first topic, I mean the first one is correct. Yes. चलिए आगे बढ़ते हैं students. Okay, let's understand ecology at organism level, how we can understand it. Okay, so if you will see, there are the organisms which are living at particular places, and such means, let's say if we talk about the polar bear. Yes, polar bear is living in the polar regions. Why? Because the environment, the temperature is like that, that is suitable for that organism. It cannot be found in the, the tropical countries, the tropical areas, because the temperature varies over there. That means the distribution of organisms very much decided by the external or the abiotic factors surrounding it. Plus, not only the abiotic factor, even the biotic factor also, which are contributing the distribution of organisms in the different geographical part of the earth. Yes. So, and why the different parts of the earth constituting different environmental conditions? So there is a geographical region behind it. There is a like the rotation of earth, the revolution of earth, and the tilting of earth on its own axis, resulting in the various formation of the temperature, various formation of the seasons, and that is what you see is leading the formation of the different the distinct seasons, and hence distinct environmental conditions in different regions. That's the case. Okay, for example, if you see, there is a tropical forest where is supposed to be, the two factors you can consider for considering any of the region, that is the temperature and the precipitation. With that, you can measure the climatic and the environmental condition. Temperature and precipitation. Precipitation. Correct? So, if you see the tropical forest, that having the higher temperature range somewhere around 25 degrees centigrade to 30 degree in between that, okay, and then the grasslands, the desert will be having the higher temperature but the less precipitation. You can see tropical forest, though the temperature is higher, but the precipitation is also higher. Okay, so this particular chart gives us an idea about the mean annual precipitation and the mean annual temperature. Fine. So this is the case. Okay, just coming to the another one. So So let's understand what are the key elements that leads to so much variation in the physical and chemical condition of different habitats. So most important of them are the temperature, the first one. The second is water, light, and soil. These are the factors which what you see is mostly affecting the organisms. Okay, at organism level, this is what you see the factors. So one more thing, the habitats. The habitat of an organism, that is including the physiochemical condition as well as the biotic component, which we discussed already. Like what is habitat? Where the organism is living. The place, the address of an organism is what you see the habitat. Okay, there is one more terminology which comes, that is niche. Okay, so what is niche? That is the, see, the address is what you see the habitat, the functional activity or the physiological activity or the role of an organism in the environmental condition is what you see the niche. You know? So if this is there, so organism, if you see, it has two things. One is the habitat. Okay, another thing is what? Niche. So if you see the habitat, so that is what you see the address, like where it lives. The place where the organism lives. Place where organism lives. Okay? And if you talk about the niche is what? That is the physiological role or the role kya hai? Role of an organisms in the ecological system. Okay? Or you can say functional or the duty. Okay? Role of an organism kya hai? So that is what you see the niche. Fine. And this habitat is affected by, this is affected by what? Affected by, you see, the physiochemical and the, like you can see the biotic. First abiotic, sorry, abiotic and biotic factors. Okay, that's the case. So fine, let's see the different things. I'll just give you a brief about all the factors quickly, not much taking the time. So abiotic factor first is temperature. It is the most ecologically relevant factor, students. Okay, and temperature on land, it varies. Like if you move from the let's say equator to pole, so this is going to decrease. Correct? Like suppose this is our planet Earth. Here surface hai, okay, and this is the equator, correct? And these are the polar regions. Okay, this is the North Pole, this is the South Pole. So if you move from equator to the polar region, so this is what you see, the temperature keeps on going decreasing. Yes, यहाँ पे जो तापमान होगा, यहाँ पे जो temperature होगा, that is lesser. Here the temperature is higher. Similarly, if you move from the equator towards the poles, the temperature is going to what? It is going to decrease. Fine, students? So that's the case. I think this is easily to understand. So two categories of, in fact, on the land also, if you see, let's say the mountainous, this is what you see the, in terms of latitudes. Yes, latitudinally, if you see, the temperature is like this way. It is going to decrease, will decrease, correct? And if you see with respect to the altitudes from the sea level, altitude from the sea level, so again here the temperature will be higher, students, and yahan pe top region pe temperature kya hoga? That will be less. So again, if you move from the base to the top of the mountains, so the temperature is going to decrease, correct? Okay. Okay, a few things left. So two categories of organisms are there in with respect to the temperature, student. What are those categories? That is, first is eurythermal. There are the eurythermal animals, there are the stenothermal animals. What does it mean? Eury means the wide range of temperature tolerance is there, that is eury, and steno is the narrow range of temperature tolerance, that is stenothermal, students. Okay, generally the cold-blooded are what you see the stenothermal, and the warm-blooded is going to be the eurythermal. Significance of temperature to living organism is what you see. Living organisms, that it affects the kinetics of enzymes. Okay, so what it is affecting? Kinetics of enzymes, and through it the metabolic activity and other physiological functions of the organisms are being affected. That's why the temperature is the most ecologically relevant factor. Okay, now next is the water. Another most important factor, that is the water, because we know the life originates in water, students. Yes, when you have started the evolution part, the origination of life, that is what you see in the water only the life originated. And for aquatic organisms, the quality of water becomes very important. What type of quality it is, so that is going to affect the organism, correct? So like there is a salt concentration which has been taken, that is part per 1,000. That is part per 1,000. So it is on the basis of the value of this, the water body is being classified. Like there is a less than 5, that is comes under the inland waters, 30 to 35 in sea, and greater than 100 in saline lagoons, mein jo hai, it is too much high. More than 100 part per 1,000, the salt concentration is too high, students. Yes, not easy to tolerate. So that is what you see on the basis of the salt concentration. Talking about the light for plants, how the light is useful, you see it is again the most important abiotic factor. See, so the photosynthesis factor, the photosynthesis process, and the photoperiodism which is required for flowering. For animal, it is useful for diurnal, seasonal variations. Okay, then foraging means the food search. They are going to that, for that this thing is required, and the reproduction and migratory activities completely depend upon the light, students. There is a UV spectrum, or UV component of the spectrum is harmful to many organisms, while not all the color components of the visible spectrum are available for marine plants. That is very important. So in that context, we can understand one thing. There is, suppose this is a water body, students, and this is a sunlight. So the sunlight is going to be here, the sunlight is going to be there. So not every time it is available. So it is being seen that the distribution of algae is different. So green algae is supposed to be present on surface, then there is a brown algae, and at the depth, you see what is present, that is the red algae. Red algae is having the pigment R phycoerythrin, which can uptake the blue wavelength of light, at which the photosynthesis can take place. So that's why for red algae it is easy to be present, and the blue wavelength of light is what you see is a low wavelength and high energy, hence it can go deeper inside the water bodies. So for that's why the red algae is supposed to be present at the depth of the sea, students. Okay, so next is the soil. Nature properties of soil in different places vary. It is not going to be same, it is going to vary, students. It depends upon the following things, like withering process, soil is transported or sedimentary, or how does this soil develops, kaise bani hai, how does it originated. That is all going to be there, students. Okay, I hope I am audible to all the students. I hope so. Okay, so let's move ahead. Okay. Okay, so the soil composition, then the grain size, aggregation, that is all going to determine the percolation and water holding capacity of the soil, students. So these all 4 factors are very important, okay, which affect the organism. Now let's see the questions which is being asked, which can come under in your examination. Yes, a few organisms can tolerate and thrive in a wide range of temperatures. They are called what? So we just discussed, it is what you see, the eurythermal. Yes, they can tolerate the wide range of temperature. Okay, so temperature is the most important ecological relevant environmental factor. Yes, that we discuss. Which statement is wrong with respect to temperature? Average temperature on land varies seasonally. Okay, yeah. Average temperature, this is correct. Average temperature decreases progressively from the equator towards the poles. This is also correct. We just discussed. Average temperature decreases from plains to the mountain tops. Temperature never exceed 100 degrees centigrade on earth. This is what you see is wrong. Why? Because there are the conditions where the temperature exceeds more than 100 degrees on earth. Yes, deep thermal hydro vents, these places are there, which is present on earth itself. So yeah, there are the regions where the temperature can exceed to 100 degrees centigrade. So the D option is what you say is Incorrect. They're asking the incorrect one. Yes. Okay. So the red, green, and brown algae that inhabit the sea, red algae is likely to be found in the deepest water. Just now we discussed. Blue light has short wavelength and high energy and can penetrate deep in water. That is also true. So, and this is the reason, is it, students? So yeah, the red, green, and brown algae, they are inhabit the sea. Red algae is likely to be found. So blue light is this. Yeah, and that's why because the pigment it has phycoerythrin, because of which it can perform the photosynthesis and it can absorb that blue wavelength of light. So somewhere they have not mentioned this thing. So okay, we can go with the B option in that case. Okay, so now there is something different which we have to discuss, another topic, that is responses towards abiotic factor. Responses towards abiotic factor. Abiotic factor. So that you have to discuss the 4 things. That is, one is the regulators. There are regulators, students. There are conformers. There are the migration is also there. Okay, then suspension. Okay, so let's see what all these things are. So firstly, regulators are what? They are going to regulate their, like now they have to respond towards the external factor. How they are going to respond? Okay, either they can regulate their internal environmental conditions, that is homeostasis, in terms of the temperature, in terms of the salt osmotic concentration. Okay. So organisms that maintain a constant internal environment, homeostasis, despite change in the external conditions. So what is mechanism? Energetically expensive, involves thermoregulation, body temperature, and osmoregulation. Example, almost jitne bhi birds and students and mammals, including humans, sweating and shivering, and some invertebrates, they comes under the regulators. Okay, second is conformers, organisms that cannot maintain their constant internal environmental conditions, varies according to the external environmental condition, that is the conformers. Okay. So mechanism, energy efficient, body temperature changes with the ambient temperature. Ambient temperature means the external temperature, external environmental condition temperature. Example, most animals, which include fishes, reptiles, and nearly jitne bhi plants, all plants that comes under the conformers, students. Okay. Then talking about the migration. So if the conditions are not so favorable for the organism, environmental conditions, so what will the thing can be over there? So there will be a migration. In that case, the organism is what? Temporarily leave the stressful habitat to a hospitable area and return when conditions improve. For example, that Siberian birds, they migrate from Siberia to Rajasthan, that is the Keel National Park, for laying eggs because the conditions were not so favorable over there. Suspend is also one of that thing in which organisms escape harsh condition by becoming inactive. Hibernation, estivation. There is a diapause also, developmental delay, suspension in insects, zooplanktons. Okay, this is the case, students. This is what you see, we can understand with the help of the graph. Internal levels are there. There are the external levels. So if internal and external levels, they are fluctuating, like the internal level is fluctuating with the external level, that are the conformers, which we have discussed. All plants, okay, and maximum animals also, that is fishes, reptiles, that are included, hai na? Reptiles that are this. Then regulator, whatever will be the external conditions, but internal conditions going to what? Remain same. This particular value this organism is having, this is going to be continuous. That is the regulators, which contains the animals, certain animals, जैसे कि birds हो गया है ना, birds था, mammals थे, that is all comes under this. And few invertebrates भी इसी में आते हैं. Okay. Okay, there is one more case, that is partial regulator. To certain extent they regulate, and then there is a change according to the external conditions. So that is what you see, the case of responses towards abiotic factor. Okay, let's see the question now based on that. What is true about regulators? That means they can regulate. Organisms are able to maintain homeostasis by physiological means. Yeah, that's true. Able to maintain homeostasis by behavioral means. That is also true. They can do that. Homeostasis ensures constant body temperature. Okay, ensures constant osmotic concentration. Yes, so that is what you see. Osmoregulation, students, if it is being done, osmoregulation, and this is thermoregulation. Thermoregulation. Thermoregulation is exhibited by snakes. Snakes come under this reptiles. This is wrong. What is true? All except fourth. Okay, fine. Next question. Okay, now next what we have to discuss, adaptation. Adaptation is what? It is the attribute of the organism which includes the morphology, physiology, behavioral that enables the organism to survive and reproduce in its habitat. See, the ultimate aim of an organism is what? It has to survive. Not only that, it has to reproduce. Yes, because we know the organism having what their lifespan, certain lifespan cannot continue throughout with a span of time. Okay, so it has to survive plus reproduce. In order to address in that condition, it will undergo the process known as adaptation in terms of its behavioral, in terms of its morphology, physiological, all these things. Okay, we'll see certain examples. For example, and one more students important thing, these adaptations later on, epigenetically fixed, become a part of their genetics itself after a long period of time. Okay, so it is an environment which is what you see triggering the variations also. At certain point we can say that. Examples in this, many examples are there. Like this is one of the physiological example. It is, if you see, so there is example of kangaroo rat, okay, which is there in the North America. This particular rat does not drink water at all in its whole life, but it has to store the, it has to restore the water, whatever it has in its body, correct? How it is going to happen? So it, fulfill its water requirement by internal oxidation of the fat. One thing, then it has the ability to concentrate its urine so that minimum volume of water is used for removing the excretory products. The first point. Okay, that is the case with the rats के case में, animals में. Second, if you see, like if the external conditions are not so favorable, they are very hot climatic conditions. Plants के case में कैसे होता है? What do they do? Generally, they have the physiological mechanisms. Also, they have the morphological mechanisms. Like you have studied, the phylloclad is there. The stem become green in color. Photosynthetic. Okay, sunken stomata. They have CAMP pathway. These are the examples for the plants. Yes. Then mammals, if they go for the colder climatic, generally have shorter ears and limbs to minimize the heat loss. Okay, and this is called Allen's rule. That is what you see, the Allen's rule. If there is a, the colder climatic conditions. So colder climatic conditions may, what will be the case? They have the shorter proximities they have, okay, limbs, no, like ears, all those things. Then in polar seas, if you see aquatic mammals like seals, they have thick layer of fat, which is blubber. Below this thing that act as an insulator and reduce loss of body heat. Okay, there are some organism puzzle adaptation that are physiological, which allow them to respond quickly to a stressful situation. For example, if you see the humans who are going to the higher altitudes, they having a lot of symptoms of altitude sickness like heart palpitation, vomiting, headache, etc. These things. So how this is going to be reduced? So the body is compensate low oxygen availability by increasing RBC production, decreasing the binding affinity of hemoglobin, and by increasing breathing rate. Okay, these are the physiological mechanisms through which the altitude sickness can be compensated. Then there is a lot of other mechanisms also. Some behavioral, let's see, are there, like desert lizards. They lack the physiological ability, but they have the deal the high temperature. So they show some behavioral way to, adjust with the environment. That is, they bask in sun, absorb heat, and their body temperature drops below the comfort zone, but move into shade when the ambient temperatures start increasing. Okay, that is what you see, the behavioral. So if you see the adaptations overall, so adaptations may, you have seen there are the morphological way of adaptation. There will be a change in the morphology, or either there will be a biochemical method of adaptations. Also, there is a physiological method of adaptations. There are the behavioral way of adaptations. Okay, I think I didn't discuss this biochemical morphology. We have seen the plants, physiological, we हमने पढ़ा in the case of altitude sickness, even the rat के case में. Okay, behavioral, that is, you can see in the lizards. Some species are capable of burrowing into the soil to hide and escape from the above ground heat. This is also behavioral. Fine. Biochemical, you see, many fish thrive in Antarctica waters where the temperature is always below zero. So they have the body fluids. Certain chemicals are present in their body fluid, which is what you see, anti-freezing proteins are present, something biochemical which is there, okay, adaptation. Then a large variety of marine invertebrates and fish live at greater depth in the ocean, where the pressure could be more than 100 times. So there is what you see, they live under such high pressures, and do they have any, they have certain special enzymes, they have certain biochemical ways through which they are surviving in certain such a high pressure conditions, okay. So let's see certain questions based on that. Which of the following organisms show biochemical adaptation? Desert lizards, that is a behavioral. Fish in Antarctic water, yes. Fish live at greater depth in the ocean, yes. Archaebacteria, that is also biochemical. So yes, sare hi correct hai except one. Okay, fine. Now next is the population, students. Organism, we understood. What is organism? The external factors, abiotic factor, everything. Population kya hai? What is population? Let's see. It is a group of individuals. बहुत सारे individuals हैं, okay, living in a well-defined geographical area. Let's say this is a well-defined geographical area who share or compete for similar resources, same resources. जो भी resources यहाँ present है उसको ही use करेंगे, and potentially interbreed, okay, potentially ये क्या है, interbreed करते हैं. That is what you see the population. Population, what do you have to study? You have to study population attributes. There are the attributes of population, students, which you have to discuss. Then population growth, okay, in that, because it's not something which is static structure, it is something which is a dynamic, so it keeps on either increasing, decreasing depending on certain factors. We will discuss that. Population growth model, it has, students, that we have to discuss. Then there are the population interaction we will discuss. So little population interaction, okay. So let's see in this, what are the attributes? Attributes are birth rate, death rate, sex ratio, age pyramid, okay. One more is there, that is population density, okay. So birth and death rate are what? It is the number of births per individual, okay, per year, like per capita, that is the birth, and number of death per individual per capita, that is the per year, that is the death rate, okay. So increase or decrease with respect to the member of the population, that is what's the birth rate and death rate, okay. So this is not for individual. Sex ratio, percentage of females and males, how much, that is what is the sex ratio. Age pyramids, they are being construction of the age pyramid based on the age of the population. The population is being divided on the basis of the age groups. For example, they have the pre-reproductive, they have reproductive and post-reproductive, yes. So pre-reproductive, reproductive and post-reproductive, okay. Based on that, we are having the three of the, you can see the models, age pyramids. Expanding, which is this kind, then stable, which is bell shape. So this is triangular shape, okay, triangular shape. Then this is you can say bell shape. और ये कैसा है student? This is declining, this is urn shape. Important note करने वाली बात क्या है? Triangular means, expanding means when the, you know, when the pre-reproductive people are more in number as compared to the reproductive, because they are ultimately going to enter. So this is the expanding case. In this case, there is a pre-reproductive and reproductive also of same number almost. So that is going to be stable. While if the pre-reproductive is less in number, students, so that is what you see is going to be declined, because the pre-reproductive ultimately going to enter in the reproductive. In that case, you will find more post-reproductive people also, or this is seen in certain countries like in Japan. This is the case. Unsafe, that is a declining population, and expanding you can see in our country also. India is one of the example. European countries come under generally the stable population. All right, let's discuss certain questions. What does birth rate in a population refer to? The total number of births in the population, the increase in population due to migration, the number of births per individual per unit time. Absolutely. Like birth rate is what? That is per individual. Jitna differences tha. Okay. That is the case. Find in age pyramid, the number of individual of reproductive age is lesser than pre-reproductive, but higher than post-reproductive one. The population is, yes, students, what it is going to be? Growing, declining, stable. So here it is saying reproductive age is less here and pre-reproductive is more, but higher than post-reproductive ones. So that is going to be growing population. This is what they are talking about. This, and this. So this is going to be like this student. Okay. Next is a broad-based pyramid-shaped age structure diagram is characteristics of population that is growing rapidly. Obviously, when birth rate equals to death rate, so in that case, if it is equal, so definitely the population size can remain constant. Okay, it is equal almost. The age structure of population influences population growth because younger females have more offspring than comparatively older females. Different age groups have different reproductive capabilities. More is the number of immature individuals. Slower is the growth of population. A shorter generation time resulting. So what is the answer, student? The age structure of a population influences population growth because. So yes, younger people have more offspring than comparatively older female. That is not true. Different age groups have different reproductive capabilities. This is what you see the case. That's why the age group is considered. The reproductive, based on the reproductive capabilities, they are being categorized, the pre-reproductive, reproductive, and post-reproductive. Okay. So yes, B option. Select the odd one out with respect to the attributes and characteristics of population, sex ratio, birth rate, death rate. Gender is not comes under this. Okay. Gender is not the right case. Okay. Now next is population growth. So population growth there are the factors which is what you see is responsible for the growth of the population. Okay. So I will just directly explain you with the diagram. Suppose this is the population density. Okay. So the factor which is going to plus the population density, that is the natality, that is the number of birth, total number of birth. That's not the rate, the total number of birth which occur. Okay, which happened in the population. That is the natality. You can see that. Okay. Number of birth during a given period in the population, that is added to the initial density. Number of death in the population, that is the mortality. Immigration, which is the population which add ho raha hai, that is the immigration. So these immigration and natality is what you see is adding the population density. Mortality and immigration is what? Not adding, it is decreasing this. So this is how, if you want to calculate the density of the population at particular time, so that you can do, like what is the initial density, okay, then B plus I. B is what you see the natality, okay, and immigration. Then D is the mortality and E is immigration, okay. So population density will increase if the number of births plus the number of immigrants is more than the, so this B plus I, if it is more as compared to D plus E, so definitely in that case the population density will going to increase, okay. So this is the case, students. So, okay, the size of a population for any species is not a static parameter. We understood. It keeps changing with time depending on various factors including food availability, predation pressures, adverse weather, all of this. So yes, these are the factors which is going to decide the immigration also and immigration also, okay, and also somewhere the birth and the death. So yeah, all the factors are going to play the role. That is, all of this is the correct answer. Then natality is what you see, total number of individuals present per unit area at a given time. No increase in number of individuals in the population due to birth under given environmental conditions. Yes, that is true. Loss of individual, no movement of individual out of the population, that is wrong. So by reading the option also, student, you can just see what is right and what is not correct. When change in population size, NT equal to NO, and initial plus B plus ID minus E, what do IBD stand for? So B is what you see, the natality, students, okay. I is this, yes. What is D? Mortality, and E is E is immigration. So yeah, what is the right answer in that case? They're asking what? IBD. So immigration, mortality, and E. Which is the right answer in this case? Okay, this I is this, D is mortality, which is what do IBD? Immigration, mortality. This is not correct. Immigration, natality comes. Only I they are asking. I think IBD. Okay, yeah. Natality, immigration, and mortality it is. Yeah, this option is correct, students. Okay. All right. Whatever might be the ultimate reason, the density of a population in a given habitat during a given period fluctuate due to changes in. So ultimate reasons जो भी हो, but जो density है वो किस चीज पे depend करेगी students? Two basic process, natality and mortality. Two basic process, immigration. Four basic processes, this. Four basic processes, this age distribution. So yes, it is going to be important. Your two basic process, that is natality and mortality. Okay, fine. Yes. Population density is designated as, we are going to represent it by n student. Okay, population density. The most appropriate measure of population density is generally number, biomass, percent cover, all of this. We generally do it by all of this. I think this is what we have to discuss. Okay, mark the correct option. The population density, how we can do that? It's not only about the number. We can do it by various ways like the pug marks, okay, the fecal matter of tigers, and even, like relative densities. These are the measures of the population density, which ultimately gives us the number of the individual in a particular area. So yeah, these three are all are correct. It's correct case, students. Which of the following contributes to an increase in population density? So increase in population, so that is going to be natality. Yes, that is a birth. If occur in a population, this is going to be increase. Okay. If a new habitat is just being colonized, which of the following may contribute more significantly to population growth than birth rate? Birth rate से ज़्यादा क्या होगा? Obviously बात है, if the people are entering into it. Yes. So what is that entry? It is the immigration. Okay, they're entering. Growth models, students, growth model, the population's growth. There are certain models through which we can understand the population growth models. So basically there are two models which is there. That is, two types of growth can be observed. One is the exponential, okay, exponential. Another one is the logistic. This we consider that when there is a like extreme amount of unlimited resources, okay, unlimited resources present. And here logistic mein it is what? There are the limited resources, and because of which there is also one factor play roles, that is carrying capacity. Carrying capacity, correct? That is what you see, the growth models for the population, growth model. Okay, now let's see what are these. So exponential growth, if in a population size n, the birth rate are represented by B and death rate as D, then the increase or decrease in population during unit period. So that will be dn by dt, and this is equal to B minus D n, and this B minus D you can represent by R. I think this is all we know, that is intrinsic rate of biotic potential, Rn. Okay, that is the equation for the exponential. Then if you take the integration of this particular equation, it comes out this n equal to n or ERT, that is your dn by dt, I mean log if you take. Okay, so that will be equal to Rn. Symmetric growth pattern of population resulting in J-shaped curve. Okay, so what type of curve it obtained? There is a J-shaped curve obtained, student, in this case. Then there is a logistic growth. So logistic growth, it has what? When the unlimited resources are there, limited resources are there, and hence there is a carrying capacity. So the curve which is obtained, that is S shape. S-shaped curve obtained. And in this case, the equation becomes this: dn by dt is equal to Rn k minus n by k, where k represent the carrying capacity, students, which is very important. This factor now added into this, that makes this logistic. This is what you see the curve, and the maximum population can reach to the carrying capacity, that is a k value. So when k is equal to n, that time the curve which becomes, that is asymptote. This is asymptote condition, that is k is equal to n k. Yes. Okay, so nt equal to n naught e to the power rt is an equation of logistic word list. Okay, this logistic this is also known as word list per logistic growth bhi bola jata hai, it's also known as. So this is going to be as exponential growth, student. What is true about the given equation? Dn by dt, let's write, equal to b minus d multiply by n, where b minus d is this. So dn by dt is equal to Rn. Okay, so n is present size of population. Okay, b is per capita birth rate. Okay, yes. D is per capita death rate. This is correct. R in this equation is called the intrinsic rate of natural increase. That is also true. R can be used only assessing impacts of biotic factor. Okay, so yes, R can be used for impact of biotic factor. True. Only assessing impact. No, they are assessing both impact of biotic as well as abiotic, keh sakte ho, students. So in this case, we can see the equation, the options which are clearly correct. That is yes, this. Okay. The last one is wrong. Exponential growth in a population occurs under which of the following condition? Under which condition the exponential growth takes place? So when resources are limited and population growth slows down, when a population reaches the carrying capacity, when resources are limited, leading to rapidly increasing population size. Yes, that is true. This is correct only. The formula for logistic growth: dn by dt Rn k minus n by k. That is what you can just learn, student. Important. In a nature, a given habitat has enough resources to support the maximum possible number beyond which no further growth is possible. This characteristic feature nature is known as carrying capacity. इसी को carrying capacity कहा जाता है. That beyond that, the nature cannot support more number of individuals, the particular population. This is what you see the carrying capacity. Okay. All right. Which of the following is considered a more realistic growth model? So obviously it is a logistic growth is what you see the more realistic. There is a life history variation, okay, in which we discuss about the value of R. We discuss about the R. See, every species want to increase the value of R. R is what you see the Darwinian fitness and intrinsic rate of natural increase, and reproductive fitness also we call it the value of R. Okay, but there are the strategy of the population to achieve the maximum value of R. So every species has this aim to increase the R value, the reproductive fitness, but the species having the different strategies. Okay, for example, either they will going to reproduce once in their lifetime, reproduce once, okay, in lifetime, or either produce huge number of offsprings, produce huge number of offspring, okay, which is of small size, This is how they're reaching to their maximum value. Or either they reproduce multiple times in their lifetime, multiple time in lifetime, okay, and also produce less number of offsprings, offspring, but of large size. Okay. So this is what you see here. The parental care will be less because more of the huge number of offsprings are there. So parental care less. Here parental care more. You can see this in case of birds, mammals. Yes. Okay. Examples are birds, mammals. Here you can see salmon fish. They are producing salmon fish around. They lay a lot of eggs and once in their lifetime, around let's say some 1 lakh eggs, and they're very much huge, but once in their lifetime only, and after that it will not going to. Similarly, bamboo tree just having some span of time, and then before dying it just flower huge and then produce the fruits and seeds. So it is also producing once in its lifetime, but huge number. Okay, so that is the another strategy: salmon, bamboo tree, oyster, pelagic fishes. Okay, they are certain example. Let's see some question based on that. These are the strategies, students. So reproductive fitness of any population is also called. So it is also called Darwinian fitness and having high value of R. Okay. Next, match the list we have to see. So the bamboo, students, bamboo is what you see, breed only once in its lifetime. Yes. A3. Then fish. Fishes produce a large number of small sized organisms. Correct? That is true. B2. Then mammals. Mammals, they are going to produce a small number of large size organisms. So C4. And bird, they are breed many times in its lifetime. D1. So yes, you can go with this A option. This is going to be correct. Yes. Okay. Now next, which we have to discuss, that is population interaction. We know the species which is there, they are not going to live individually. They will going to interact definitely. That is what is the population interaction. Okay. Even the plants also, they are interacting with the soil, the nutrients which is available, the bacteria which is going to break down the microbes which are available. So somewhere you see that every organism they are interacting with. There are no single species who can live alone. Hence there is a population interaction, students. Now what type of interactions are possible? Okay, so population interaction mein what type of interactions are there? Population interaction. So we have some positive interaction, hai na? Let's say some positive we say, or let's say negative interaction. Okay, in positive we have, let's say, some plus interaction. Okay, let's say some plus zero interaction. Negative, we have negative interaction. Okay, negative plus interaction. Okay, negative zero interaction. So what are those? We can name them. This plus interaction you can see in mutualism. That is mutualism, students. Plus zero, that is commensalism. Commensalism. Okay. Then negative, that we can see in the case of competition. Competition. This negative positive that you can see in case of parasitism, in predation. These are the interactions, and this case you will see in case of amensalism. Okay. So finally we have these all interactions within the populations which are possible. Okay. Let's see some question based on that. The symbols what you see is need to remember, students. This is what you see the case. I think this is given in the NCERT itself. Okay. Need to remember what is predation, what is amensalism. Okay. So some questions we'll see. Okay, the prickly pear cactus introduced into Australia in early 1920. This prickly pear is one of the example of predation, yes. Because this pear was havically spreading rapidly into the millions of hectares. Australia did not have natural predator of this cactus. That is true. They have introduced something from outside, some insect, because of which it get controlled. But initially they don't have, that's why this was spreading so much. So this is the correct explanation. So first option we can go with. Then predator, what it helps in? Maintaining species diversity, true. It reduces the competition between prey species, yes, that is true. Maintaining ecological balance, yes. All of these are correct in this case, students. Okay. Then, okay, predation is a way of transferring the energy fixed by the plant to lower trophic level. So it's not to the lower trophic level, it's going to the higher trophic level, students. So this statement is wrong. Predator act as conduit for energy transfer across trophic levels. That is true. Statement 1 is incorrect. Statement 2 is correct. Okay. Okay, then principle of competitive exclusion was stated by That is by Gauss, student. Gauss competitive exclusion principle, okay, which we have seen. According to principle of competitive exclusion, two species cannot continue to occupy the same ecological niche, biome, environmental habitat, range. You can say ecological niche, they cannot. That is more appropriate. Ecological niche, yes. Okay, in some shallow South American lakes, visiting flamingos and resident fishes, they compete for their common food. What is that common food? That is a zooplankton, students. They're competing for zooplanktons. Okay, B option. Okay, then a species whose distribution is restricted to a small geographical area because of the presence of competitively superior species is found to expand its distributional range dramatically when the competitive species is experimentally removed. This is the observation of, so this is the observation of competitive release. The competition is basically released, because of which the inferior one is what you see expanding very much, and that's the case. Okay, it is spreading. Most recent studies out of the species facing competition might evolve mechanisms that promote coexistence rather than exclusion. One such mechanism is resource partitioning, competitive release, interference, competition. So what do you think what it could be? Students, answer me. Let me check how many. So what is the right answer, students? Tell me. Resource partitioning is what you see, one of the case through which the competition can be released. Yes. Okay. Which of the following best describe endoparasites? So endoparasites are what? They live on the host external surface, they live inside the host body, they are plant parasite, they only reproduce asexually. So they live inside the host, what they are talking about, endoparasite, yes? Living inside the host body. A few more questions I will just discuss, students, and then we'll move to the new topic. Okay. Okay, what does seed dispersal receive as a reward by the plants? Pollen only, shelter, fragrance, juicy and nutritious foods. So seed dispersers receive as reward by the plant. So pollen to nahi hota, only shelter you can say, hai na, fragrances, juicy and nutritious fruits. We can say the shelter it will provide. In lichen, fungus and blue-green algae live together without causing significant harm to one another. So it is an interaction, the example of what? Obviously, mutualism. Okay? Attempt to grow either the algae or the fungi independently result in the death of the organism. So they cannot live independent of each other. They are completely positive. Okay, fine. Chalo, some examples. Mutualism. Mutualism is lichens. Commensalism. So commensalism is sea anemone and clownfish. So A3, B4. A3, B4. Yeah. 1 is given. A3, B4, 2 is given. Chalo. Ectoparasites, ticks and lice. C1. So this will be B option is correct. Okay. Now there are few things. Okay, while explaining interspecific interaction of population, plus sign is a sign for beneficial interaction, minus sign is assigning for detrimental interaction, 0 for this. Which of the following interaction can be assigned plus for one species, minus for another? Competition going to be negative, positive, negative, 0, positive, 0. What they're asking, positive and negative, this is the right answer. B is going to be the right answer, students. Yes, this is clear? Okay. So, there are, fine, one more question. Herbivorous plants. So, there is commensalism, mutualism, predation, competition. Herbivores and plants. That is going to be predation. Okay? A3. Then mycorrhiza and plants. So that is going to be mutualism. So A3 and B2 Okay, A3, B2. Sheep and cattle, that is going to be what? Commensalism, like what is left now? Competition, this can be a competition, student, C4. Okay, and orchard tree is commensalism, D1. Because sheep, cattle, they both are herbivores, they can compete for the same resources. That is the right answer, A3, B2, C4, D1. The first one itself, attempting this, going to be right, students. Now let's discuss about the ecosystem. Okay, next topic. So that is all about the organism population. We have to quickly revise all the topics, just considering some important of them. Ecosystem is really very important. This is what you see, the interaction between the biotic and abiotic factors, like biotic components and abiotic component, how they are interacting with each other, and that is leading to a self-sustaining unit. Okay, self-sustaining unit, you can say. So ecosystem, we can understand, like there is no external energy is required, internal something is required. It is self-sustaining something which is happening on its own because of the balance interaction between the biotic and abiotic components of the nature. Correct? Let's see, understand that with the help of one beautiful, these all are the examples of the ecosystem: deserts, coral reefs, tundra, this is all. Okay, let's understand the example of, this is the pond ecosystem. अच्छा, मैं एक चीज और बताती हूँ, I think ecosystem में, this is very important to understand. So ecosystem में there is one thing, there can be natural ecosystem. What we are saying, how does there is an interaction exist, interaction, or you can say the balance interaction among the abiotic component and biotic component. Biotic component. Biotic component. Okay, which makes the thing self-sustaining. Self-sustaining. This can be small ecosystem, there can be large. ठीक है, स्मॉल आपका एक पॉन्ड हो गया है ना, लार्ज आपका बायोस्फीयर itself is a large one. Okay, it is self-sustaining. We can understand about the ecosystem by taking example of pond ecosystem. Let's say it is also one of the example of ecosystem. It is self-sustaining unit. Why it is self-sustaining? Because you see here, there are the producers, there are the consumers, there are the heterotrophs, there are a lot of organisms. So conversion of inorganic into organic material with the help of the radiant energy of the sun by the autotrophs. Okay, then consumption of the autotrophs by heterotrophs, and then decomposition and mineralization takes place over and over again. So this is keep on happening. Ye chalta rahega all the time. This keep on happening. There is the raw material present, which is going to be fixed with the help of the autotrophs. That fixed material is going to travel by the food chain to the different regions, and then finally the entire thing going to die and it is going to decompose, and again it's going to be spread into the non-living or abiotic component. So there is a exchange takes place, abiotic and biotic. How it is going to, that is what you see is ecosystem is helping in us to understand. Okay, the laws of thermodynamics are operating here, students. So that is also being a very important topic. But this can be understood by this. Like there are 4 important things which need to be understood in the ecosystem: productivity, decomposition, energy flow, and nutrient recycling. We will study in your course, we have to study only these 3, that is productivity, decomposition, and energy flow. So productivity is all about the rate of biomass production, okay, per unit area, that is in a unit area like that, okay, per year. That is a productivity. And there is a GPP, primary productivity, and secondary productivity. So unit for the productivity is what? You can say gram per meter square, gram per meter square, okay, per year. Or या फिर you can just write kilocalorie, yes, meter square per year. So this is what you see the case. GPP, NPP is very important. You can understand this by simply NPP is equal to GPP minus R. What is available to the next trophic level is going to be always the NPP, net primary productivity. GPP can never be calculated. Yeah, you can calculate, but for that we need to know the value of R, that is the respiratory loss. Okay, so and the productivity is what is it depends on the following things: the plant species inhabiting particular area, variety of environmental factors, availability of nutrients, photosynthetic capacity of plants. Okay, now next is decomposition. Decomposition is very important thing. So the productivity is then, that is this. Okay, one more thing, students, productivity. There is a, we have seen primary productivity and there is a secondary productivity. Primary productivity and secondary productivity. Okay. Primary productivity at producer level, this is at producer level. Yes. Secondary productivity at consumer level, the productivity, the production, that is what you see the secondary productivity. Okay. Next point is decomposition. What is decomposition? Whatever material is there that is undergoing the process of decomposition, it will degrade. So what material we're talking about, that is what you see the waste or organic waste material. That is basically the detritus we define. This is dead bodies, the dead part of the plants, or the fecal matter. This all comes under the dead organic and the waste organic matter. And this is need to be what you see the decompose. So there are the 5 steps of decomposition. This is fragmentation, leaching, catabolism, humification, mineralization. Very important. This should be in a step. You can say, Balki, you can say this is what you see together takes place: humification, mineralization. Humus is fragmentation. Suppose this is something, a leaf. Okay, there is a leaf, student. That is what you see is not useful. This is going to be decomposed. I mean, this is going to fragment. This, let's say, the fragmentation takes place. Okay, and then whatever nutrients was there, that is all going to, with the water, it's all going to form reservoirs. This is the leaching. Then that the catabolism occur. Okay, the further breakdown with the help of the microbes, and then humification, that is a humus formation, and mineralization. Mineralization. Finally, unlocking of the minerals takes place from this entire organic matter, and this is what is decomposer. The decomposers require this entire process. The dead material is detritus. What are the factors which affecting the decomposition? Chemical composition and climatic factor. Chemical composition: faster, detritus is rich in nitrogen and water soluble. So faster if detritus is rich in nitrogen and water soluble substances, sugars, and slower if contains lignin and chitin. Very important. Okay. And climatic factor: warmer, moist environmental accelerates decomposition, while low temperature anaerobic condition slows down the decomposition, students. Fine. Now next is energy flow. Energy, if you talk about, there is a unidirectional flow of the energy, correct? It is sunlight, producers, consumers, and decomposers. And there is a, what important you have to study, of the incident solar radiation, less than 50% of its photosynthetically active radiation, PAR. Plant capture only 2 to 10% of the PAR, student. So 1 to 5% of the total incident radiation, and this small amount of energy sustain this entire living world. Very important. Okay, so less than 50, what you see is falling in the category of PAR, and the plants are using only 2 to 10% of the PAR only. So that total of the incident light is using only 1 to 2%, 1 to 5%, you can say, basically incident light plants. Okay. So there are the trophic levels, which is their students on the basis of their food obtaining habits, like the producers, primary consumer, secondary consumer, tertiary consumers are there. We have the food chain, grazing food chain, predatory food chain, okay, and the detritus food chain, which starts from the dead organic matter. Very important, ecological pyramids. There is a 3 ecological pyramid: pyramid of number, pyramid of biomass, pyramid of energy. Number, it is upright in most cases. It could be inverted, it could be spindle. These are the cases. Very important. Pyramid of biomass, it could be upright in the terrestrial condition. Aquatic condition, it is the inverted. Energy pyramid is always going to be upright, student. Okay. Let's discuss certain questions. What is considered in the structure of the ecosystem? Input, productivity, transfer of energy, output, degradation, and energy loss. So yes, tell me, what is considered the structure of the ecosystem? If you see the structure, So who is going to discuss? What is going to be discussed? All of the things we can discuss that. Yes, all the things going to discuss the structure, students. Then a pond is a shallow water body which components of an ecosystem are well exhibited by pond. Productivity, decomposition, energy flow, and nutrient cycling. Pond itself is what? It is itself a self-sustaining small example of an ecosystem. So yeah, that's having all the things, the productivity, mineral cycling, nutrient cycling, decomposition, and energy flow. All of this is correct. Okay. What is true about zooplanktons? Please think and tell me the right answer. May have some water. So, what is true about zooplanktons? Passively floating, actively swimming, microorganisms, photosynthetic, heterotrophic. अगर यहाँ पे फाइटो होता तो हम पैसिवली कर देते, माइक्रो तो होते हैं, चलो फोटोसिंथेटिक कर देते हैं ना, बट इट कैन बी एक्टिवली स्विमिंग स्टूडेंट्स, माइक्रो ऑर्गेनिजम्स हो सकते हैं एंड हेट्रोट्रॉफ्स. तो 2, 3 एंड 5 यहीं पे है. Yeah, 2, 3 and 5, D option is correct. Okay. Chaliye, what is true about the annual net primary productivity of the whole biosphere? It is approximately 170 billion tons dry weight of organic matter. Okay. The productivity of the ocean is 115 billion tons. No, it is of the terrestrial condition. The productivity of the ocean is more as compared to land. No. The productivity of the ocean is only 15.5 billion tons. Yes. So first and fourth that are correct, students. A option. So out of 170 billion ton, if you see the productivity we are taking, sorry, tons, we are taking the productivity. So in that only you see 115 is what? For terrestrial, and remaining 55 is for aquatic. Why? Because of the less available, some certain nutrients are there which is not there in the water bodies, because of which the productivity decreases, although the water bodies composition or the area wise it is more in number. Yes. Oh, the important steps in the process of decomposition are, important steps कौन से हैं? Fragmentation, leaching, catabolism, humidification, सभी important है ना? So okay, let's see the options. A first, fragmentation, third, catabolism, and fifth, mineralization, second, leaching, third, and fourth, leaching, catabolism, humidification. But if fragmentation will not occur, then how would the leaching takes place? है ना? So fragmentation important, leaching important, and this. So out of taking all the options, I think we can go with this one, first one. The fragmentation is very important. So leaching automatically happens. So catabolism, humidification happen, and then mineralization. So this three you can take as important one, the first option. What is true about humus? A dark color amorphous substance. Okay. Highly resistant to microbial action. Yes. Undergo decomposition at an extremely slow rate. That is also true. The humus the humus is further degraded by some microbes and release inorganic nutrients. Yeah, degraded by some microbes and release inorganic nutrients. That's true. So dark color amorphous substance, what is true? First, highly resistant to microbial action. That is also true. First, second, and fifth is not there. This option wrong. We can go with the second, third, and fourth. Yes, because there is no fifth option we can see in this case. Little error seems like. Okay. Which of the following is unit of productivity of an ecosystem? So we just discussed now, kilocalorie per meter square per year. Okay, so we can go with this D option. All right, few more questions. Okay, let's solve this. In an ecosystem, if the net primary productivity of first trophic level is 100x, So in that case, we can just make the trophic level, that is, let's say first trophic level, second trophic level, third trophic level. This is first, okay, and this is second, this is third. So if an ecosystem, the net primary productivity of the first trophic level is 100x, the NPP of this is 100x. What will be the GPP of the third trophic level of the same ecosystem? What will be the GPP? इसका GPP कितना होगा? If NPP of this इसका जो है यहाँ पे कितना हो जाएगा? ये 10x and it will be x. Okay. So this will be the NPP for the second trophic level. But for the third trophic level, this NPP of the second trophic level will be the GPP of the third trophic level. That you can say, student. Yes. This is will be is NPP. NPP it will be X, net primary product. This is what is available for the next trophic level. That is true. 10x is available for the third trophic level, but that will not transfer completely. There will be only 10% law takes place, so hence it will be X only. But we can say for this third trophic level, the NPP of the second trophic level will be the GPP of it. Okay, so that will be your 10x. It will be okay. So this is the right one, 10x. Okay, next is in the equation GPP minus R is equal to NPP. GPP is this R is what? Reproductive allocation, photosynthetically active radiation, respiratory quotient, respiratory loss. Yes, what is the right answer, students? It is respiratory loss. Okay. The amount of biomass or organic matter produced per unit area over a time period by plants during photosynthesis is called. So photosynthetic plant it is saying, so that is the primary production. Okay. The amount of biomass or organic matter produced per unit area over a period of time by plant during primary productivity, or you can say, yeah, or you can say with the net primary production. Okay. Produced per unit area over a time period by plants during photosynthesis. What? Tell me what is the right answer? Net primary production, secondary production, primary production. What? What it is, student? This will be net primary production. Yes, your secondary production, primary production. Without that will be net primary production. Okay. In the equation GPP minus R equal to NPP, R represent the respiratory losses. Okay. चलो ये वाला क्वेश्चन कर लेते हैं. If 20 joule of energy is trapped at producer level, then how much energy will be available to a peacock as food in the following chain? 20 energy is trapped at producer level. This is 20. Mice में कितना हो जाएगा? 2. The snake में 0.2. Peacock 0.02. ठीक है? She will be available to peacock as food. तो peacock को कितना available? How much it is available? 0.2 ऐसा available है. ठीक है, पर पॉइंट ये विल बी अवेलेबल फॉर द नेक्स्ट वन. ठीक है, दिस इज व्हाट इज अवेलेबल फॉर पीकॉक. कैन यू से दैट, स्टूडेंट्स? 0.2 joules, that is what you see available. Okay, so we can go with this. Okay, now next we have to discuss the eco biodiversity. Yes, biodiversity, very important, biodiversity and its conservation. So biodiversity को कैसे हम define कर सकते हैं? I'll just simply say that biodiversity usually is being what? It is the total diversity which exists on planet Earth, correct? So it can be, you can define in fact betterly like the diversity which exists at different biological level of organization. That is also what you see, sum total of the different biological level of organization which biodiversity exists, that is the biodiversity. Okay, So in that case, there are the examples like there are more than 20,000 species of ants, 3 lakh species of beetles, 28,000 species of fishes, like that. This all comes under the biodiversity, students. Okay. So we have to firstly know that how many counts are there. So if you see, there are more than 70% of all the species recorded are animals, while plants including algae, fungi, bryophytes, gymnosperms and angiosperms comprise no more than 22% of the total. Okay, then we have vertebrates, this thing. Among animals, insects are the most rich taxonomic group, making up more than 70% of the total. The number of fungi species in the world is more than the combined total of the species of fishes, amphibians, reptiles, and mammals. Okay. So, if you see, let's see some questions. Term biodiversity, it was popularized by, there is a scientist known as Edward Wilson. He was a sociobiologist who explained that what the total, exists entire biodiversity at different biological level of organization. Okay. So chalo ek padhte hain. The genetic variation shown by Rauwolfia might be in terms of potency of respirin, concentration of respirin, fragrance, and this is what you see, one of the genetic biodiversity. Yes, so both 1 and 2 it will be. Genetic diversity is shown by Rauwolfia, rice, mango, sab dikhate hain. All of this, you see genetic biodiversity there. Okay, what does the IUCN means? International Union for Conservation of Nature and Natural Resources. Easy. Out of the total number of species present on Earth, more than conservative and scientific sound estimate was made by the students Robert May. That you have to remember. Okay, then the various questions we can solve. Okay, current estimates do not give any figure for prokaryotes. That's true. Conventional taxonomic methods are not suitable for identifying microbial species. That is also true. That's why we are not able to going to estimates the figures for that. Now, pattern of biodiversity, if you see, there is a latitudinal gradient, so there is a species area relationship which we have to discuss. So this is how the pattern of biodiversity, which we discussed already, as we move from, the diversity will be rich where the precipitation and temperature is very much high, while where it is less, so in that case the diversity is going to decrease. Definitely at the equator we can find more number of diversity, while at this we will find very less. So it will going to decrease when we move from this to this. This very important concept, that is species relationship, which is given by Alexander von Humboldt, and that is what you see, the log S is equal to log P. Okay, that is S equal to C a to the power Z. And when you take the log, so this will come like this, where your Z is very important. Okay, Z ki jo value hai, Z lies in the range of 0.1 to 0.2, regardless of the taxonomic group of the region. And if you analyze the species relationship among very large area like the entire continent, where the value of Z will be 0.6 to 1.2. And for frugivorous, it is going to be 1.15. Okay. Then there is the diversity, this thing. Okay, then you have the biodiversity laws. This occurred due to extinction of the species from Earth. Colonization of tropical Pacific led to extinction of 2,000 some native birds. IUCN Red List 2004, 784 species are lost in 500 years. This much vertebrates, invertebrates. Some example of recent extinction they can ask you in the exams: dodo of Mauritius, thylacine of Australia, quagga of Africa. Okay, and Steller sea cow of Russia. 3 subspecies of tiger are Bali, Caspian. This is all the cases, students. Okay, and this is the examples you can see. Sometimes they ask to which region they belong to. So that is very important to understand. Okay, and okay, let's see what are the major causes, 3 major causes of the loss of biodiversity, which are also known as evil quadrate. So what are those? Let's write. major cause of biodiversity loss. Major cause of loss of biodiversity. So it is what, student? That is the habitat loss and its fragmentation, correct? Habitat loss and its fragmentation. Then alien species invasion, or you can say over exploitation. Alien species invasion, and co-extinction. Of all these, you people have to remember the examples. That is very important. Okay. Then why should we conserve? There is biodiversity. There is a narrow utility, broad utility, and ethical. Okay, this is all comes under the why we should. And there is one term which we have to remember, that is bioprospecting. With increasing resources put into bioprospecting, there is exploring molecular, genetic, and species level diversity for products of economic importance. That is bioprospecting. Then there is a conservation strategies also. We have in situ conservation, that is in their natural condition we are conserving, and we have ex situ. In situ conservations, they are protective area network, that is the national parks, wildlife sanctuaries, biosphere reserves are there, sacred groves, hotspots, that's all come under this. Okay. And ex situ conservations are various like field gene bank, seed bank, in vitro plant tissue culture, cryopreservation, DNA banking, so all comes under this. We have the convention based on that, the Earth Summit, which is happening in Rio de Janeiro 1992, and World Summit on Sustainable Development in Johannesburg 2002. This is what you should remember, South Africa. Okay. So, yeah, that is all about it. Some questions we'll see. Okay. And then you people can go for the revision of next. Chalo, kuch questions dekh lete hain. Which one of the following is not a method of in situ conservation of biodiversity? Biosphere reserve, wildlife sanctuary, botanical garden, sacred grove. So botanical garden is not a in situ, this is ex situ. We are taking the plant to the other places. Okay. Then okay, which of the following both pairs have correct combination? In situ conservation, seed bank, ex situ conservation, national park, wrong. In situ tissue culture, in situ national park, ex situ botanical garden. This is correct. Just now we discussed that. Okay, some other question. Let's see. Okay. So students, I think at last I would like to say that you people can practice more of it. Okay. You can practice more questions and can improve your things by revising more of it and improving it. So few questions also we can take. Okay. The Earth Summit held in Rio de Janeiro in 1992 was called to reduce CO2 emission, global warming, for conservation of biodiversity and sustainable utilization of its benefits, to assess threat posed to native species by invasive weed species, for immediate step to discontinue the use of this. So yes, for conservation of biodiversity and sustainable utilization of benefits. That's true. Okay, World Summit on Sustainable Development was held in. So World Summit was held in the Johannesburg. We studied that. Okay, it's what the World Summit. And okay, so you people can practice more of the question. Okay, chaliye aag badte hain. If A species richness and B is endemism, then biodiversity hotspots have low degree of A and low degree of B, low degree of A and high degree of B, high degree of A and low degree of A, high degree of okay. So yes, hotspots have been recognized by having a high species richness, and they also have high degree of endemism, students. So yes, D option It's correct. Okay, I hope this is clear to all of you. Yes. Okay, so this is correct, student. Now, cryopreservation of gametes of threatened species in viable and fertile condition can be referred to as. So when speaking cryopreservation, this is what you see. We are not doing it in the natural conditions. It's being done under certain given conditions. So that is what you see in situ conservation. It will be the in situ conservation. Ex situ conservation, I mean. So advanced ex situ conservation of biodiversity, that is. Cryopreservation, if you see, so something which is being done, you know, at very low temperature. So that is around minus 196 degrees centigrade. In liquid nitrogen, it is being done. Liquid nitrogen. Okay. So yeah, this is what the case, student, for cryopreservation. And this is not the in situ, because we discussed already. In situ is what? Is the one which is in the natural conditions basically done. Okay, and ex situ is what? Which is when the things being taken out from the natural conditions. So overall, if you see, these 3 chapters are very not so tough. You can just go through it, understand the concepts. I hope little bit beneficial for you today's session. So I just want to say all the best to all the students. Okay, and just remain stay tuned, student, for the next session, which is going to happen over here. Yes, for zoology. That's all from my side. Thank you, students.
Hi everyone. Please let me know if I'm audible and visible. Please give me thumbs up if you're watching live. Please give me thumbs up if you're watching live. Am I audible for everyone, guys? All right. So I believe I'm audible for everyone. I'm just checking the comments. Okay. Please give me thumbs up and like if I'm audible and visible for everyone. Cool. Thank you. Thank you so much. So shall we start, guys? Give me thumbs up again. Shall we start? Give me thumbs up again. Shall we start, guys? All right. I will be watching your chats. Okay. All right, guys. So let me introduce myself. My name is Jyoti Sharma, as you can see on the screen. Welcome to the NEET revision session. And I know this is very important time for you because it's less than 7 days you have right now in your hand for the preparation. And you must have seen the update of the NEET, the recent update, where the NTA has declared that NEET exam is not a cup of tea for everyone. But don't worry, okay, we are trying hard, and that is why we brought you this mega revision session. We will be trying to cover all of the important chapters which have very high weightage. Okay, you have completed 3 subjects already: physics, chemistry, and botany. This is the last subject, zoology. My name is Jyoti Sharma, IT Zoology, and I'm going to take this whole session, be there for complete 2 hours. Okay, if I need to extend, I will extend it also, but be there consistently. And please let me know if you understand everything. If any doubt is there, also let me know. Shall we start? All right, guys, thank you. So this you can see, we are going to cover here in this session all the important topics and questions. Okay, the chapters which are very high weightage. Also I will share a strategy, okay, and the mind maps and everything. So let's start. The first chapter that I'm going to share, as you can see, the chapters I'm going to cover in this particular session, these are the chapters: human reproduction, reproductive health, human health, and animal kingdom. I will try hard to cover maximum of the topics and the points. So these are the 4 chapters we are going to cover in this session. Okay, so I have brought you the PYQs, and through the PYQs only we are going to revise the chapter. Okay, so you have to answer me the first question. You can see, match the column: head, middle piece, acrosome, and tail. You know already these are the part of the sperm. So if you can easily recognize the answer, the head is the part which contains the genetic material, right? So you must remember the structure of the sperm. So this is the structure of the sperm. This is the head region. Okay, this is the neck region. This is the middle piece. This is the middle piece. And finally, this is the tail region, right, guys? And over this is the acrosome which contains the enzyme. So this particular part is the head region, you know already. This particular part is a neck region. This particular part is a middle piece, and this is the tail. So we see all of the structure of this particular part, acrosome, contain enzymes, and head region contain the genetic material. The genetic material is present in the head region, genetic material. And the middle piece contain mitochondria, and this mitochondria, which is a spiral mitochondria, which is responsible for the energy generation. And this is the tail region, and tail region required for the swimming. I hope this particular part is clear, and that's how we are going to solve this question. So head region is that particular part which is going to contain the genetic material. So A will be 4. So let's see, where is the A? A is here, here is here. Middle piece contain the energy. So B will be 3. A4, B3. An acrosome contain enzyme C1, A4B3C1, A4B3C2. So that is why the correct answer will be this option. I hope this is clear for you. Let's solve the next question. Next question is coming from the menstrual cycle, very important. Okay, or I can say the gametogenesis basically. So reproductive division for the human female gametogenesis start earlier than of the male gametogenesis. So basically in this question you have to find out the correct answers. Okay, so let's read all the options and let's find out which is correct, which is incorrect. So reduction division for the human female gametogenesis start earlier than the male gametogenesis. You tell me guys, is this correct or wrong? So this statement is a right statement. Okay. Gap between the first meiotic division and the second meiotic division is much shorter in the male compared to female. I will explain this point. So basically it is asking the gap means time between meiosis 1 and meiosis 2. Is it equal in both spermatogenesis and the oogenesis, or it is lesser in spermatogenesis and more or longer and higher in oogenesis? So answer is it is not equal. In oogenesis, the gap between meiosis 1 and meiosis 2 is huge, while in spermatogenesis, the gap between meiosis 1 and meiosis 2 is very less. That is why this option will be also correct option. First polar body is associated with the formation of primary spermatocyte? No. When primary spermatocyte divide, produce secondary spermatocyte and first polar body. That is why this option is a wrong option. Luteinizing hormone surge lead to the disintegration of the endometrium. One set of menstrual bleeding. So this option is telling that luteinizing hormone surge lead to a disintegration of the endometrium. No. Luteinizing hormone, when it becomes surge, then it causes the rupturing of the Graafian follicle, which leads ovulation, means the release of I will say secondary oocyte from the ovary. So that is why this option will be also the wrong option. In this case, the correct options are A and B, not C and D. Okay, so let me explain here. This is spermatogenesis and oogenesis. So what is spermatogenesis? Spermatogenesis means formation of sperms, okay, in male testes. So these are the spermatogonial cell. Spermatogonium, they divide, and this division is a mitotic division. By the mitotic division, the primary oocytes are formed. Both are diploid in structure because this mitotic division is a equational division, okay. And then primary spermatocyte further divide by meiosis 1, which is a reductional division, and it make or produce two secondary spermatocyte which are haploid in nature. And finally, immediately, these particular secondary spermatocyte further divide by meiosis 2 and produces 4 spermatids which are also haploid in nature. But this type of the division is a equational division. So you can see here the meiosis 1 and meiosis 2 both are continuous process. There is no pause between them and it happens quickly, okay. There is no gap between them. But we will see the oogenesis process. So in this oogenesis process, we will find that oogonium cell, they divide by mitotic and produce the primary spermatocyte. And primary spermatocyte before birth only in the ovary of the fetal female, okay. So there only in ovary, the primary spermatocyte, they enters into meiosis 1, but immediately get arrested. There only get arrested. It means the meiosis 1 does not get completed there, okay. That is why you can see this particular thing happen arrested in the prophase 1. And that is why this particular time period, the second meiosis happen at the time of the fertilization, okay, after puberty. So you can see there is a gap before birth till the puberty and after puberty, which can be the gap of 15 years and more than that. So this is not a continuous process. There is a huge gap present, okay. And plus lot of arresting process is happening in middle meiosis 1, even after meiosis 2 also. That is why it's not a continuous division, okay. Let's see the next question. Select the correct option for the transport of sperm cell in the male reproductive system. Okay, so you can see here in the male reproductive system, hold on guys. All right. So you can see here the correct transport of the sperm. The sperms are formed in seminiferous tubule. Seminiferous tubule are the site of production of sperms. And immediately after that, these sperms have to transport outside. So they move to the ready testis to vas efferentia, then epididymis, then vas deferens, then ejaculatory duct, then urethra and urethral meatus. Very simple question, but it is PYQ. So you have to make sure that you are learning that particular topic very well. Now, you can see female reproductive system, one question from there only. So the presence or absence of hymen is not reliable indicator of virginity. This has taken from the NCERT. This is NCERT line, very important line, very important line. So let's see if this statement is correct or not. Statement 1, presence or absence of hymen is not reliable indicator of the virginity. Yes, it is not, okay, because the hymen can be ruptured by any injury, during any exercise, even during the menstrual cycle, the menses, okay. So this is not a reliable indicator for the sexual intercourse or the virginity. Okay, the hymen is torn during the first coitus only. No, as I told, hymen can be ruptured during multiple process. So if we see the statement 1 and statement 2, first is correct and second is wrong, and that is why the correct answer will be the A. I hope it is clear for you. Next, vas deferens receive a duct from seminal vesicles and open urethra as ejaculatory duct. Do you remember vas deferens? Vas deferens is a pair of duct which is coming out of the scrotum, entering into lower abdomen, and finally it is merging with the seminal duct and making one common duct, which is ejaculatory duct. So look at this diagram. This is testis. If you see, this is testis, okay? And this tube that you can see, this is the vas deferens. Vas deferens. Now this vas deferens is going, and this particular structure that you can see, this is seminal vesicle. Seminal vesicle. Now this vas deferens is joining. Vas deferens, let me mark, this is vas deferens, okay guys, and this is the seminal duct. So this vas deferens is joining this common duct, and this common duct you can see, this is ejaculatory duct. So they are asking this question. Let's read statement again, that vas deferens receive a duct from the seminal vesicle and open into urethra as ejaculatory duct. Yes, statement 1 is correct only. Statement 2, cavity of the cervix is called cervical canal, which along with vagina form the birth canal. This is also correct, okay. Cervical canal, which is a narrow canal, and the vaginal canal, both are making the birth canal because the baby deliver outside through this canal only. So in this case, both statements are correct, then that's why we will choose the statement, both statements are correct only. So B option is the right option. Let's see. Next question, guys. I'm checking your chats. Please let me know if you are, if I'm audible and visible, if you're able to answer this question. Guys, can you write down your options here? Because I cannot see any answer in the chat box. Please write it down. Please write down all the answers here. Okay, I will be checking your chats. So please write down your answers. Next. Okay, so this question has been taken from the mammary gland. So let's check this also. So mammary duct, alveoli, mammary tubule, lactiferous duct, and mammary ampulla. They're asking you have to arrange these components. If you remember, let me show you the diagram. So this is the diagram, okay? You can see this structure that you can see here, this is alveoli. This particular structure is alveoli. Alveoli is the place of the mammary gland where the milk is going to be stored. And from alveoli, one duct arises. You can see this particular duct. Let me mark. From alveoli, one duct arises, and these duct, every alveoli has one duct. The duct of every alveoli, we call it mammary tubule, okay? And all of the duct of alveoli which are present in one mammary lobule, they open into one common duct, and that common duct you can see, which is mammary duct. Okay, so these are the mammary tubule, guys. Let me mark. These are the mammary tubule. These are the mammary tubule. I'm marking with the black color. And this common duct that you can see here, this is the mammary duct. And finally, these mammary duct open into one more common duct, and this common duct we can see the, okay, later on it becomes swollen, that we call it the ampulla, and finally the open outside, which we call the lactiferous duct. So let's select the options. So the first is alveoli. This is alveoli. Every alveoli has mammary tubule. This will be the second. And then finally they merge into mammary duct. This will be third. And finally mammary duct has swollen part where the milk is going to store temporary, which is mammary ampulla. And the fifth will be the lactiferous duct. So let's arrange. So C, E, A, D and B. C, E, A, D and B. So option D will be the right option. Okay. I hope it is clear. All right. Next. Capacitation occurs in. What is capacitation? Whenever sperm enter into fallopian tube. Okay. With the secretion of fallopian tube. Okay. When the sperm is almost reaching the site of the ovum. So by the secretion of the fallopian tube and all of the receptors which are present in the fallopian tube, the movability of the sperm increases. Means some changes happen in the membrane of the sperm. That particular process we call it capacitation, and capacitation occur in female reproductive tract. Capacitation refers changes in the, definitely in sperm just before the fertilization. Okay, I hope this is clear for you. Next. So this is important. If you can see the question, please answer this question. Please answer this question if you can see the question. Please answer this question if you can see the question. Okay, let's solve this question. So here, this is LH. So GnRH means gonadotrophin releasing hormone. This gonadotrophin releasing hormone work on or stimulating the pituitary gland. This pituitary gland is releasing two hormones, and these two hormones are, both of the hormones are, we call them gonadotrophins. These particular hormones we call them gonadotrophins. Okay. Now these gonadotrophins, there are two gonadotrophin. One gonadotrophin is LH, you can see, and one gonadotrophin will be FSH. I hope you know already. Okay. All right. Now this LH is going to work, or this LH receptors are present on a special cell of the testis, and these special cell of the testis we call them either Leydig cells. Okay. Or guys, if Leydig cells are not given in the option, they must give the interstitial cells. Okay. They will give interstitial cells. IC, interstitial cells. Now Leydig cells are secreting androgen, and androgen are doing the formation of spermatids. Okay. Now what is the function of FSH? FSH is going to stimulate a very important cells of the testis. We call them Sertoli cells. And now Sertoli cells release one factor, and that factor is very, very important for one of the very important process. Let me tell you what is that important process. You remember I showed you the structure, this particular thing. I showed you this thing. You remember? So these are the spermatids. Okay. Spermatids are the non-functional cells. And these spermatids undergo the cell differentiation process. And this cell differentiation process does some changes in the cell, and this non-functional cell become functional movable cell. This particular functional movable cell, we call it a sperm or spermatozoa. This process, this changes happen during one of the process, and this process we call it cell differentiation, and cell differentiation only happen when Sertoli cells release some factors. Okay. This process is known as, this conversion process, differentiation process, it is known as the spermiogenesis. So here the Sertoli cells, they are controlling the spermiogenesis. What are they controlling? They are controlling spermiogenesis. Okay. So let's see. So basically A is FSH, B Leydig cell, C Sertoli cell, and D is spermiogenesis. So A is FSH, B Leydig cell, C Sertoli cell, and D is spermiogenesis. I hope the question is clear for you. Now let's see the next question. So here This question is coming from gametogenesis. Gonadotrophin LH stimulates synthesis and secretion of androgen. Is this true? They are asking what? They are asking, okay, they are asking the correct sequence, okay? Correct sequence we have to tell. So, gonadotrophin releasing hormone from the hypothalamus, androgen stimulates spermatogenesis, and its gonadotrophin FSH help in the process of the spermiogenesis, and gonadotrophins from the anterior pituitary gland, okay? So, let's arrange. So, first thing is that the first process in during this all of the hormonal mechanism, the first process which happen, this is the gonadotrophin releasing hormone. Where is that gonadotrophin releasing hormone from hypothalamus? It is released. Then this GnRH is going to work on pituitary gland. This is B. Okay, and then finally the gonadotrophin LH stimulate synthesis and secretion of androgen, which is C, and then androgen stimulate the spermatogenesis, which is D, and then gonadotrophin FSH help in the process of spermiogenesis, which is E. So here B, okay, 1 2, where is 2 2 3 4 5. So B will be the first and then E will be the second. B first, E second. So option C is the right option. Okay, let's see the next question. Primary follicles get surrounded by, here also they are asking, they have given the 2 and they are asking what? We have to choose the, if they are both are correct or not. Okay, primary follicles get surrounded by more layer of the granulosa cells. Yes, they are surrounded by more layer of granulosa cells. That is why they have become the secondary oocyte, secondary follicle, and then tertiary follicle, and then Graafian follicle. And atheca and shows fluid filled cavity antrum. Wrong. When primary follicle is surrounded by more layer of granular cells and they develop a theca, only one theca, this structure we call it secondary follicle. And secondary follicle does not have any fluid filled cavity or antrum. Okay, so that is why this option is wrong option. Okay, or wrong statement. Graafian follicle rupture to release a secondary oocyte from the ovary by process of ovulation. Obviously, this is the correct statement. So first is correct, first is incorrect and second is correct. That is why option B will be the right option. Alright, so you can see here, look at this diagram. This is primary follicle, guys. Primary follicle is growing, making secondary follicle. You will not find here in secondary follicle any fluid filled cavity. This is very important. I am writing this point. Presence of fluid filled cavity or antrum, it only occurs in tertiary follicle, not the secondary follicle. Very important. Okay, so let's see the answer, correct answer. Okay, so this is secondary, this is tertiary. In tertiary you can actually find out this fluid filled cavity, and the full fluid filled antrum is present in mature follicle. And the rupturing of the Graafian follicle, releasing of ovum, this particular process we call it ovulation. Okay, you can see. And after that this particular remnant will convert into corpus luteum. Okay, next. Which of the following are true for spermatogenesis but do not hold true for oogenesis? So basically in this question we have to find out something which is true for spermatogenesis but not true for oogenesis. Okay, so let's see. It results in the formation of haploid gamete. Yes. In the end of the both type of gametogenesis, the result, the gamete which are formed, both are haploid in nature. This is true. Differentiation of gametes occur after the completion of meiosis. Yes, differentiation of gametes occurs after the completion of meiosis only in spermatogenesis. Okay, differentiation process only occurs in spermatogenesis, but this is not a part of oogenesis. That is why this will be do not hold true for oogenesis. So this one is the correct. Meiosis occur continuously in mitotically dividing stem cells population. Here, oogenesis, the meiosis does not occur continuously. It is controlled by the luteinizing hormone and follicular stimulating hormone secreted by. This is correct for both. This is correct for both, but this is correct only for the spermatogenesis, not for the oogenesis. So let's see the answer. Answer here, the B, C, and E. Okay. Next, the release of sperms. Release of sperms into the lumen of the seminiferous tubule is called spermiation. Can you answer this question? Is this statement correct statement? Is this statement correct statement, guys? Can you answer this? Is this statement a correct statement? Can you answer this? So let's see. The release of sperm into lumen of seminiferous tubule is spermiation. This particular process is correct. And statement 2, spermiogenesis is the process of formation of sperm from the spermatogonia. This is also correct. So both statements are correct. Okay. Select the correct option of haploid cells from the following groups. So let's see. Correct options, haploid. They're asking, out of these, all are haploid or not. Secondary spermatocyte, haploid. First polar body, haploid. Ovum, haploid. Spermatogonia, no. Primary spermatocyte, no. Okay. And spermatid, haploid. So that is why the correct option will be the A. Next. Difference between spermiogenesis and spermiation. So let's see. What is spermiogenesis and what is spermiation? This is very extremely important. Extremely important. So spermiogenesis. Spermiogenesis is a process when the non-functional spermatids convert or differentiate into functional spermatozoa. Okay. And spermiation, when the spermatozoa, these spermatozoa after formation, they insert their head into Sertoli cells, and after taking nourishment, these spermatozoa released out from the Sertoli cells and released into the lumen of seminiferous tubule. This is known as the spermiation. So in spermiogenesis, the spermatids are formed? No. Spermiogenesis, spermatozoa are formed, while spermiation spermatids? No. In spermiogenesis, spermatozoa from the cell? No. And spermiogenesis, spermatozoa are formed, while in spermiation, spermatozoa are released from the Sertoli cells. This is correct. Next. So let's see the next. Correct sequence of sperm formation. In sperm formation, the correct sequence is spermatogonia. They are converting into spermatocytes. So this is the correct answer. Next, guys. Which of the following statement are correct regarding female reproductive cycle? Very important. Extremely important question. Okay. NCERT. So here, non-primate mammal cyclic changes during the reproduction are called oestrus cycle. Yes, non-primate like cows, buffaloes, okay, goat, those are non-primate. Primates are only monkeys, apes and human beings. Primates are apes and human beings, okay. So here these are non-primate animals. They have the oestrus cycle. The first menstrual cycle begin at the puberty and it is called menopause. It is known as menarche. Lack of menstruation may be indicative of pregnancy. Maybe, yes. And cyclic menstruation extend between menarche and menopause. Choose the most appropriate correct answer. So C is correct, D is correct, A is correct. So A, C and D. So here answer will be A, C and D. Next. Changes in GnRH pulse frequency in female is controlled by, see, GnRH level is controlled by both hormones, and these hormones are estrogen and progesterone. Okay, always remember this particular. How do they control? Estrogen trigger surge of LH, and progesterone, it basically decrease the GnRH, or this particular hormone increase the GnRH. So by seeing this, The correct option will be estrogen and progesterone. Two statements are given, A and B. Okay, let's see here. Endometrium is necessary for implantation of the blastocyst. Yes, if endometrium is not there, blastocyst is not going to implant. This is correct. In the absence of fertilization, the corpus luteum degenerate that causes the disintegration of the endometrium. This is also correct. But both are not correct explanation. That is why this will be the right option. Receptors for sperm binding in the mammalian are present on, these receptors are present on zona pellucida. Let me show you the structure. So guys, this is the ovum, okay? This particular membrane that you can see outside, this is zona pellucida. Zona pellucida have some proteins. These proteins are known as receptors that we call them ZP3 receptors. So this sperm is going to bind with this protein, and because after binding it make a receptor cone basically, and then only it releases its genetic material into the cytoplasm of the ovum. Okay, so always remember this. Hormones secreted by placenta to maintain pregnancy are. So hormone which are secreted by placenta to maintain the pregnancy, these are the HCG, HPL, estrogen and progesterone. So option will be C. Next, identify the correct statement on inhibin. What is inhibin? So basically inhibin is hormone, okay, and this inhibin is secreted by two organs. It is secreted by testis, okay, also it is secreted by ovary. Both particular organs secrete this hormone. In testis, it is secreting from the Sertoli cells, okay, and Sertoli cells secrete inhibin so that they can control FSH. So here, this inhibin secretion of LS-FSH produced by granulosa cell in ovary inhibit the secretion of FSH produced by granulosa cell in ovary inhibit the secretion of LH. So answer will be this, because in ovary secreted from granulosa cell. Next, fertilization in human is practically feasible only. How and when the fertilization is practically possible? Fertilization in fallopian tube, it is only possible when both sperm and the ovum are reaching at the similar place at a time. Okay, so here answer will be the ovum and sperms are transported simultaneously to the ampular isthmic junction of the fallopian tube. Next, breastfeeding during the initial period of infant growth is recommended by doctors for bringing a healthy baby. Breastfeeding is very important. Why the breastfeeding is very important? Because the initial milk of the mother, that we call it colostrum. This colostrum contains antibodies, okay, plus all of the nutrients. And you know guys, if the newborn baby, okay, once the newborn baby is born, that time the immune system is not very well developed. If the immune system is not very well developed, in such case, the baby is going to catch the pathogens and baby is going to be sick all the time. Okay, because his or her immune system is not developed yet. That is why the colostrum, the first mother milk, okay, it contains antibodies which basically provide protection to the newborn baby. So they are asking us as a reason breastfeeding is very, very important because colostrum has antibodies which protect the baby from the infection. In such case, the A and R both are correct and correct explanation as well. All right. Now next question is, this is coming from the reproductive health. Amniocentesis for the sex determination is one of the important strategy for reproductive and child health care. Okay, so amniocentesis for the sex determination is one of the important strategy for the child health care. This is wrong. Amniocentesis not for the sex determination. It was basically to identify the problems, okay, the mutations and genetic disabilities. Ban on amniocentesis check the increasing menarche of the female feticide. When the female feticide was increasing too much, okay, then they have done this permanent ban on the amniocentesis. So this is the correct option. So here answer will be A is not correct, R is correct. Next, non-medicated IUD. So non-medicated IUD will be what? Multi-load, progestasert, lips loop or LNG20. So here the correct option will be non-medicated will be lips loop. Copper releasing IUD will be multi-load. B will be second. Hormone releasing IUD will be LNG. C will be 4. So in such case option B will be the right option. Vasectomy. What is vasectomy? From testis, the vas deferens is cut. Vas deferens is cut and tied. Okay. So surgical cut of the vas deferens, it is known as vasectomy. So here it is a surgical method. So A will be third. So tell me which option will be the correct option? A third. Coitus interruptus. Coitus interruptus is a natural method. B will be 4. Cervical cap. Cervical cap is a barrier method. C will be second. That is why the C option is the right option. Read this question and answer me. Next, read the question. IUD decreases phagocytosis. They are asking what? IUDs are a small object made up of plastic or copper that are inserted into uterine cavities. So sorry. This is too much. IUDs are small objects made up of plastic or copper that are inserted into uterine cavity. So IUDs are, what is the role of IUDs? Okay. What is the importance of IUDs? IUDs decreases phagocytosis of the sperm within the uterus. They increases, not the decreases, increases. Released copper ions suppress the sperm motility. Yes. IUDs do not make the cervix hostile. They make the cervix hostile. IUDs suppress the fertilization capacity. Yes. IUDs require surgical intervention of their insertion in the uterine cavity. They do not. So here the option will be A and A. No, not A. B and D. So let's check. B and D. So correct options are B and D. Let's see what is diaphragm. Diaphragm is a basically barrier method. Okay. So they cover the cervix and they block the entry of sperm. Contraceptive pills. Contraceptive pills, they inhibit the ovulation and implantation. Intrauterine devices. Intrauterine devices, they increase the phagocytosis of the sperm within uterus. And lactational amenorrhea, it basically provides the absence of menstrual cycle and ovulation following the parturition. So here option will be, the correct option will be C. Next, progesterone alone or in combination with estrogen can be used a contraceptive in the form of, okay, can be used a contraceptive in the form of, which is pills, injections and implants. What is hysterectomy? Hysterectomy is a surgical removal of uterus. Always remember, very important, not given in NCERT. Okay, important. It is a surgical removal of the uterus. This is known as the hysterectomy. Vasectomy, vas deferens, tubectomy, fallopian tube, and hysterectomy is a uterus. Next question. Which one of the following commonly sexually transmitted disease completely curable when detected early and treated? Always remember, NCERT is telling HIV, okay, herpes and hepatitis. These three are not curable. Not curable. Okay. That is why HIV, herpes and hepatitis not, sorry, genital gonorrhea is the correct option. Okay, next. Venereal disease, VD. VD means sexually transmitted diseases. Okay, they transfer using sterile needle, transfusion of blood from the infected person, infected mother to the fetus, kissing, inheritance. Choose the correct option for the best. Okay, using a sterile needle. So here, if I using infected needle, so here correct option will be A, B and select the option including all the sexually transmitted diseases. Select the option sexually transmitted diseases. Gonorrhea is a sexually transmitted, malaria is not, genital herpes, AIDS is not malaria, not filarial, cancer not, AIDS is, syphilis is, and gonorrhea, syphilis and genital herpes. That is why correct option will be the D. Next. Now, we are going to learn the human health and disease. Okay, if you're watching this live session, answer this question. The question is related to cancer. So, we are going to solve the questions from cancer. What is the question? Neoplastic characteristics. Do you know what is a neoplastic? Neoplastic is basically those particular cells which they rapidly divide in uncontrolled way, and during division they also spread in body from one place to another place. Okay, while they are dividing, at the same time they are also transferring, proliferating, okay, spreading in the whole body. So a mass of proliferative cells, correct. Just now I said mass of proliferative cells. Rapid growth, yes. Invasion and damage to the surrounding tissue. Wherever these cells will go, they will damage those surrounding tissues and neighbor tissues. Those confined to original, no. If any cell is confined or limited to original place, that particular cell will not be neoplastic cell. Okay, that particular cell will cause tumor, and that tumor will be the benign tumor. But this particular thing related to the malignant tumor. Okay, so here let's see which options are correct. A, B and C. So B option will be the right option. Identify the statement which is not correct. Come on, read the question. Question padhiye aap log. If you're watching from Hindi, English, whatever, read the question. They are asking about the antibody. Each antibody has 2 light and 2 heavy chain. Correct. Antibody formula is H2 and L2. It means 2 heavy and 2 light chains. Okay. So that's how this particular statement is correct. No doubt here. Heavy and light chain are held together by disulfide bond. This is also correct. Antigen binding site is located as C terminal. No. Antigen binding site is located as N terminal. It is not located at C terminal. And constant region of the heavy and light chain are located at C terminal. So what are they asking? They are asking which statement is not correct, and that is why C statement is not correct. Look at the diagram, guys. This is antibody. So here, these 2 chain, this particular chain is light chain. This is also light chain. This particular chain is also light chain. The yellow color chain that you can see, this is heavy chain. These 2 are heavy chain. Okay, these 2 are heavy chain, and this particular region is the N terminal, you can see, and this particular region is the C terminal. Okay, and this N terminal is the region where antigen is going to bind. N terminal is the reason where the antigen is going to bind. N terminal is a antigen binding site. So you can see this is antigen. Antigen is going to bind with N terminal of the antibodies. I hope this is clear. After maturation, the primary lymphocyte, in primary lymphoid organ, the lymphocyte migrate for interaction with antigen to the secondary lymphoid organ. Let me explain. There are 2 types of lymphoid organ. One is primary lymphoid organ. Okay, and one is secondary lymphoid organ. Okay. So there is a list of primary and secondary lymphoid organ. Primary lymphoid organ are thymus and bone marrow. Bone marrow. Does anybody know the difference between primary and secondary lymphoid organ? If you know the answer, let me know. Anybody know the answer? The difference between primary and secondary lymphoid organ? किसी को आंसर पता है? Anybody know the answer? The primary and secondary lymphoid organ? So let me check. Primary and secondary lymphoid organ. Primary lymphoid organ is the site for production and maturation of lymphocytes. And secondary lymphoid organ, it is the site for interaction with antigens. Okay. Let's suppose when you get trained for fighting. Okay. So training for fighting is happening in primary lymphoid organ. And where exactly you are going to fight with the soldiers? Like soldiers. Okay. Soldiers get trained in the training centers. So those training centers are primary lymphoid organ. But when they are ready for the fighting, they are deployed to the borders where they are going to fight with the terrorist. Okay. So that borders are the secondary lymphoid organs. So secondary lymphoid organs are spleen, lymph nodes and Peyer's patches. So answer will be C, D and E. Answer will be C, D and E. So D option will be the right option. Which of the following type of immunity is present at the time of the birth and it is non-specific type of defense in the human body? So basically there are two type of immunity. One is innate immunity. One is acquired immunity. What is innate immunity? Innate immunity, the immunity which basically present at the time of birth. And this particular immunity present in the form of barriers. And this is non-specific. It is non-specific immunity. Non-specific. So here, time of the birth and it is non-specific. Answer will be the innate immunity. All right. Next question. Now, typhoid. Typhoid is caused by bacteria. The bacteria name is Salmonella. Leishmania is a protozoa. Ringworm is a name of disease and this disease is caused by the fungus. Okay. Like trichophyton is a name of fungus. Epidermophyton. Filariasis is the name of disease which is caused by the nematode. Wuchereria. Okay. So here answer will be what? Let's see. A will be 4. Where is the A4? Answer will be D. Common cold is a viral disease caused by rhinovirus. We all know. So A will be 3rd. Where it is 3rd? Answer will be A. Ringworm is the name of disease which is caused by the trichophyton fungi. So A will be 2nd. A 2nd. Okay, we have two options. Filariasis caused by Wuchereria. B 3rd. And malaria, it is caused by the Plasmodium vivax. So C will be 4. C4. So here answer will be the B. Okay. I hope it is clear. If it is clear, just give me the chat. Thumbs up. You guys are not speaking anything. Good, if it is clear. So let's see. Infective stage of Plasmodium. You know Plasmodium? Plasmodium which causes malaria. Malaria. So what is the infective stage of the Plasmodium? Infective stage of the Plasmodium is sporozoite. Sporozoite which enter into liver. Enters into liver. Okay. You must remember this particular point. So answer will be sporozoite. Next. Which disease does mosquito transmitted pathogen causes chronic inflammation of lymphatic vessel? The name of mosquito which transfer this disease, it is Aedes, Culex mosquito. It is Culex mosquito. And this particular Culex mosquito transmit this disease, and the name of disease is filariasis. Filariasis, also we call it elephantiasis. Elephantiasis is the name of disease you must have seen. Okay, the lower limb become inflamed, and that inflammation is because of the infection which is happening in the lymphatic tissues, and that infection basically occurred by one of the worm, and this worm is filarial worm. The name of the filarial worm is Wuchereria. Wuchereria, which is nematode, okay, or we can say worm. So one of the worm larvae are transported by the Culex mosquito by biting, and then these worms cause the infection in lymphatic tissues. Causes infection in lymphatic tissues. Lymphatic tissues, okay. That is why, what is the result? Result is heavy inflammation in lower limbs. Heavy inflammation in lower limbs. So here answer will be, guys, elephantiasis, okay. I hope it is clear for everyone. Next. Which of the following is not autoimmune disorder? I hope you know what is autoimmune disorder. Answer me in the chat box, what is autoimmune disorder? What is autoimmune disorder? What is autoimmune disorder? Tell me. What is autoimmune disorder? Autoimmune disorder, when your own immune system, suppose you have a dog in your house, and after some time that dog is supposed to be protect you from the outer bodies, okay, like from the thief, from the foreign bodies, okay. That is why the dog is guarding your house, and that is why you have kept dog in your house. But if something happened to the dog, and dog itself started to bite you and your family members, okay, if the dog is not able to recognize like who is my family member, who is outer people, then dog will not be able to differentiate, and dog will start biting the own family members. So this is what the autoimmune disorder, when our own immune system, our own defense system is not able to recognize what is foreign cell or pathogen, or what is own cell and own body parts and tissues. And that is why the immune system start attacking its own body parts and tissues or cells. This particular disease, we call it autoimmune disease. So autoimmune disease, cirrhosis, yes. Rheumatoid arthritis, yes. Vitiligo, yes. Alzheimer, no. So that is why the correct answer will be the Alzheimer. Alzheimer is not an autoimmune disease. Alzheimer is the neurodegenerative disease. Generative disease, okay. You must have seen in lot of movies that when people become old aged people, so they start to forget a lot of things, okay. And you have seen a lot of movies basically when the son visit to the hospital, doctor say your mom has Alzheimer, that is why she's not able to recognize you, or she's slowly forgetting the things, or he's slowly forgetting the things. That particular disease is Alzheimer disease, okay. It is not autoimmune, but it is a neurodegenerative disease. Because of some reason the neurons start to degenerate, okay. So I hope it is clear. Next. Organisms which causes disease in plants and animals. There is one organism which causes disease in plants and animal, which is nematode. Nematode. Answer will be worms. Okay. You remember melody gyne incognita? Meloidy gyne incognita. You remember this particular nematode which was causing, in biotechnology we have studied, which was causing the infection in plants, okay, in the roots of the dicot plants, okay, you must have remember. So answer will be the D. Bone marrow is a main lymphoid organ where all the cells including lymphocytes are produced. Yes, bone marrow is a place where cells are produced. Correct answer. Correct. Both bone marrow and thymus provide micro environment for development and maturation. This is also correct. So both the statements are correct, and that is why correct option will be which one? C. Both statements are correct. Answer the question. Answer the question. Next question. So here these are the barriers. Physical barrier. Physical barrier, basically they are talking about the skin. Okay. So you know at the time of the birth we get barriers which count or comes under innate immunity. Okay. So skin is one of the barrier. Because of the skin, the pathogens, okay, microorganisms, the foreign bodies are not able to enter into the body because this is protecting. Skin is protecting. Okay. Along with that, saliva, HCl and tears, everything is a physical barrier. So here physical barrier is coming under what? It is coming like saliva and tears. So D will be the 4. So let's see D4, D4, D4. So these two options. Now next is physiological barrier. Physiological barrier is the mucus coating of the respiratory tract. So C will be 1. D4 and C1. D4, C1. Correct answer is D. Cellular barrier. Cellular barrier, basically all the cells like neutrophils, natural killer cells and macrophages. And cytokine barrier, the interferons. I hope you remember interferons. Virus infected cells. This is NCERT line. Virus infected cells, they secrete some proteins, and those proteins bind to the on the surface of the non-infected cells so that the non-infected cell can be prevented from the pathogen or the virus. Okay, so this is the correct answer. You can see here. Okay, so these are the barriers, physical barriers, and these are the acquired immunity. Next, guys. Responsible for graft rejection. You know already, responsible for the graft rejection is the T lymphocytes, which make basically the cell mediate immunity, CMI. So here, inability, cell mediated response. Select the incorrect statement with respect to acquired immunity. Acquired immunity is non-specific type. It is a specific type. Primary response is produced when our body encounter a pathogen for the first time. Yes. Amnestic response is elicited on the subsequent encounter with the same pathogen. Yes. Amnestic response is due to memory. Yes. So option A will be the incorrect option. Okay, they are asking incorrect. Next, guys. Solve this question. Answer the question. When ready-made antibodies are directly given, it is known as the passive immunity. Is this correct? When ready-made antibodies are directly given, it is called passive immunity. Correct. Active immunity is quick. No. it takes a lot of time. Fetus receives some antibodies from the mother. It is an example for passive immunity. Yes. When exposed to the antigen, living or dead, antibodies are produced in the host body and it is called active immunity. Correct. So B will be the wrong statement. Next, colostrum. What is colostrum? Colostrum is the mother milk. Initial days. Colostrum is the mother milk in initial days, and this particular mother milk contain antibodies. Antibodies. This particular antibody is IgA. So here option will be immunoglobulin A. Okay, I hope it is clear. Next, MALT. What is MALT? MALT stands for mucosal associated lymphoid tissue. What is MALT? Mucosal associated lymphoid tissue. This particular MALT, NCERT line, it makes 50% of the total lymphoid tissue. Answer will be 50. Next, antivenom. You know, when the snake bite happened, that time the person the person who is basically bitten by the snake, okay, so to that person they give what they give antivenom. What is antivenom? Antivenom contain the performed antibodies. The antibodies were already active and they introduce those antibody in that person so that the person can be alive. Okay, because poison venom is a kind of protein, and that protein toxic protein, and that toxicity is prevented by the antibodies. Antibodies, while polio, are administered into the body. What is polio? Polio is a vaccine. And this particular polio vaccine contains half killed or attenuated pathogens. Half killed or attenuated pathogens. Okay, in this case answer will be D. Next, the cell mediated immunity inside the human body is carried out by CMI, carried out by T lymphocytes. So answer will be B. In which blood corpuscles the HIV undergoes replication and produce progeny viruses? Answer is T helper cell. T helper cells are known as factory, basically. Okay. Next, which of the following is correct regarding AIDS causative agent HIV? Solve this question. Now, correct regarding AIDS causative agent. You know already, AIDS is a virus. AIDS is caused by virus. Virus name is HIV virus. This particular virus has 2 strands of RNA, and those 2 strands are RNA double 2 single stranded RNA. Single stranded RNA. So HIV is undeveloped retrovirus. HIV does not escape and attack the acquired immunity. HIV enveloped virus coating one molecule, no. An HIV enveloped virus that contain 2 identical molecule of the single stranded RNA, 2 molecule of reverse transcriptase. Okay. You know the meaning of reverse transcriptase? Reverse transcriptase is an enzyme which is required for the reverse transcription. What is reverse transcription? So transcription is a term when the DNA convert into RNA, DNA change into RNA. And when RNA change back into DNA, this is known as a reverse transcription. When there are two single strands of the RNA, definitely two DNA strands are going to form. And for this conversion process, what they need the transcriptase enzyme. Okay, so that is why this will be the correct option. Which stage of HIV infection does one usually show symptoms of AIDS? Okay, when does exactly the HIV symptoms appear in the body? When there is one thing for the HIV infection, this particular virus slowly try to damage the immune system. Okay, and slowly, first initially it will make its own copies. It will attack the T helper cells and the macrophages, and it will produce its own copies in millions in number. Later on, it will start damaging the T helper cells and the T lymphocytes. And when it reduces slowly the T lymphocyte, then the immunity become weak. And when the immunity become weak, then the symptoms appear in the body. So here, when exactly the symptoms appear in the body? When the HIV damages large number of T lymphocytes. That's the correct option. Next, solve this question. Cocaine, heroin, morphine, marijuana. What is cocaine? Cocaine is coming from erythroxylum, coca. So here it will be erythroxylum. A will be third. This is the third. Heroin. Heroin is basically one of the chemical which is extracted from the poppy plant. Okay, Papaver somnifera. B will be the 4. And morphine. Morphine is that particular which is used to give in the form of sedative. Morphine basically it is made by the acetylation process. Okay, the poppy plant. Chemical it is extracted. And this particular drug is given to the patient who have undergone the surgery. Because this particular drug create the sedative effect. What is the meaning of sedative effect? Sedative effect means when the painful feeling is not felt. किसी को अगर पेन हो रहा है ना तो जो पेशेंट है वो पेन फील नहीं करते हैं. Okay, this particular drug we call it the sedative drug which is given during the surgery or after surgery. Morphine. And marijuana is extracted from the cannabis sativa. So here the correct option will be the B. Next, drug called heroin. It is synthesized by the acetylation of the morphine. Which part of poppy plant is obtained the drug smack? Answer is latex. Okay, the smack is basically extracted from the latex of the poppy plant, Papaver somniferum. What is the name of this plant? This plant is datura. If somebody eat datura, they will die. They will lose their mind. They will be like kind of, crazy people. And they can die also. So here, this is a flowering plant. Which drug is obtained from datura? The drug which is obtained from datura, those particular drugs create hallucinogenic effect. What is the meaning of hallucinogen? Hallucinogen means when, when people feel like, let's suppose, if somebody is having hallucination, okay, so they will see as I am multiple in number, but I am a single in number only. But if somebody is having hallucination, they will see like there are many people. Okay, they can see like 2 copies of people, 3 copies of people. They can see something which is actually does not exist in reality. This is what the hallucination. Okay, so this hallucination is basically effect created by the datura. The last chapter is animal kingdom. 3 chapters we have completed in one shot. I don't know if you have attended the whole chapter or not, but 3 chapters we have completed. So animal kingdom we are going to learn now. Are you ready to learn animal kingdom? Om Gamer @Mr. Gamer BSYT. Ready to learn animal kingdom? So let's see. Organ system level of organization. This particular thing we can find in Annelida, Arthropoda and Chordata. Okay, Annelida, Arthropoda and Chordata. Bilateral symmetry both are. True coelom with the segmentation. Yes. So here all three feature, if we see, they are only present in Annelida, Arthropoda and Chordata, because mollusca does not have the segmented body. Okay. So that is why. So here also mollusca and here also mollusca. Next. Platyhelminthes are triploblastic, pseudocoelomate and bilaterally symmetrical organism. Triploblastic is correct, pseudocoelomate. No, it is acoelomate. Platyhelminthes are acoelomate animals. And bilaterally symmetrical, correct. Ctenophores reproduce only sexually and fertilization is external. So B will be the right. In tapeworm, fertilization internal but sexes are not separate. This is also incorrect. Ctenophores are exclusively marine, diploblastic and bioluminescence. This is also correct. In sponges, fertilization external, development is direct. No, development is indirect. So in this case, the correct options will be B and D. B and D both are the correct options. Choose the correct answer here. Metamerism is basically the ability, segmentation process of the annelida. So A will be third, here and here. Complex are present in ctenophores. C will be second. C will be second. So here the correct answer is this. Next. Physalia. What is Physalia? Physalia is the Portuguese men of the bird. Men of the war. So this is Physalia. Limulus is the living fossil. B. Limulus is the living fossil. And Cyclostoma is the hookworm. And pink tada will be the pearl oyster. So here A will be second, B will be third, and D will be, C will be fourth. A second, B third, C fourth, and D 1. Gregarious pest. Gregarious pest basically pest animals which infect the vegetables, crops, fruits. Okay, so those are the gregarious pest. So here locust will be the gregarious pest. So A will be 4, and that is why the correct option will be the A. Next, which group animal belong to the same phylum? Let's see which group animal belong to the same phylum. Sponge, sea anemone, starfish, malaria, parasite, amoeba, mosquito, earthworm, pinworm, tapeworm, prawn, scorpion, and locust. So same phylum. So let's see. Sponge is Porifera. Sea anemone basically it is Cnidaria. Starfish it is Echinoderma. Malarial parasite is Protozoa. Okay, and here amoeba is Protozoa. Mosquito is Arthropoda. Earthworm is Annelida. Pinworm is Ascaris. and tapeworm is platyhelminthes. Prawn is arthropoda, scorpion is arthropoda, and locust is arthropoda, and that is why correct option will be the D. Well done. Pharynx is perforated by the gill slits. They're asking the non-chordates. Okay, what are the features which are given here which do not belong to the, which belongs to the non-chordate? Pharynx is perforated by the gill slits. Notochord is absent. Yes, notochord is not present in the non-chordates. Notochord feature is present only in the chordata. Central nervous system is dorsal. It is ventral. Central nervous system in non-chordate, it is ventral. So that is why this will be the wrong option. Heart is dorsal. Yes, heart is dorsal if it is present. Posternal tail is absent. This is also correct. So here B and D and E will be the right option. B and what are they asking? Yes, B, D and E will be the correct option. Next, they are asking about phylum chordata. Phylum chordata, Urochordata. So Urochordata, notochord extend from head to tail. In Urochordata, notochord only present in tail region. In tail. In larval tail. In larval tail. So in Urochordata, the notochord is present only in the larval tail. That is why this particular statement will be the wrong statement. In vertebrata, notochord is present during embryonic stage only. Correct statement. Central nervous system is dorsal and solid. Incorrect statement. And notochord is divided into three phylum: Hemichordata, Tunicata, and Cephalochordata. Okay. So what are they asking? Not true. Which statement is not true or true? So here two statements are true basically, but let's consider this one. Next, the pterophylum, hagfish, myxine, pristis, exocetus. What is pterophylum? Pterophylum is the angel fish. Angel fish, okay? If you carry this fish and keep in an aquarium, then you will see the angel because it's very much colorful and beautiful. That is why we call it angel fish. Myxine is the hagfish. So here B will be 1 and A will be 3. A 3, B 1. So correct option will be the D. Okay, D option will be correct option. Is that clear? Are you listening and understanding, or you're simply just sitting there and chatting each other? Simply standing and just chatting with each other? No? Then answer this question. Next. Who is chatting in the chat box? Unique mammalian characteristic. How can you recognize the mammal? If you see any animal, do you know how can you recognize that particular animal is a mammal? Let me tell you. There are three important features. If you see those important features, you can actually recognize that animal is a mammal. The first important feature, presence of body hairs. You have body hairs? Do you have body hairs? Yes or no? Even if you're bald, still people have body hairs, right? Skin is covered by the hairs. We have eyelashes, okay? We have hairs. So we have hairs all over the body. If the animal is having hairs on the body, that particular feature is purely mammalian feature. Means that animal is a mammal. Second, presence of ear pinna. Ear pinna. Presence of ear pinna. This ear pinna, external ear. It can be small, it can be big. If you see the rat, it is very small. If you see the elephant, it is very big. Okay. So presence of ear pinna is the mammalian feature. And the last, presence of mammary gland. Mammary glands are the special feature of mammalia. From mammary gland only the mammalia word have come. Okay. So that is why the unique feature which help us to recognize the mammals, those are hairs, not this, hairs, pinna and mammary gland. Okay, I make hairs, pinna and mammary gland. This will be the correct option. Okay, I hope it is clear. Okay, we are learning the last chapter. Okay, be there in the chat box and write down all of your answers and make this particular session very interactive session. Don't sit silent. Come on, answer the question. हाँ, same ear pinna जिसके थ्रू आप सुनते हो. Okay, if you're not listening me right now, maybe something happened to your ear pinna. So this ear pinna collect the sound and send into your ear canal. Okay, so if you're not listening me, it means your ear pinna is not collecting the sound. Check your ear pinna whether it's collecting the sound or not. Now, correct statement. All reptiles have 3-chambered heart. What do you say? Reptiles have 3-chambered heart. Yes, reptiles have 3-chambered heart. But there is one reptile which is not having 3-chambered heart. That reptile basically crocodile. Crocodile आपका मामा है. So crocodile basically has 4-chambered heart. Crocodile is having 4-chambered heart. Okay. So all reptiles are not having 3-chambered heart. All Pisces have gills covered by operculum. No. Some fishes have gill cover. Some fishes do not have gill cover. Okay. All mammals are viviparous. No. You remember there is one mammal which we call it the platypus. So platypus is a mammal which does not have the gill. It does not give birth. It produces or lays egg. So all cyclostomes do not possess jaws and paired fins. This will be the right option. All right, solve this question now. Solve this question. Which of the following represent the correct combination without any exception? Let's see. Let's read. Sucking and circular mouth, jaws absent, integument without scale, paired appendages. Cyclostome. This is correct. All of the cyclostome, they have sucking, circular mouth, and they do not have any kind of scales, and body covered with feather, skin is moist, glandular, forelimbs form wings, lungs with the air sac, mammary glands, hair on the body, pinna, 2 pair of limbs. Mammals. Okay. Mammary glands, yes, hair on the body, pinna, 2 pair of the limbs, correct. Mouth ventral, gills without operculum, skin with placoid scale, persistent notochord. Correct answer will be the D. D is the right option. Okay. Okay, this is not, one feature is not matching here. So D will be the correct option. Alright guys, so that's all from my side. I hope you have enjoyed the session. I tried to explain you all of the chapter through the questions. So if you have any question, you can ask me right down. Let me tell you the quick strategy to revise this. Quick strategy to revise. So the quick strategy is this. First, you have to find out weak topics, revise your notes, plus NCERT, and the last and very important, practice questions. If you revise like this, okay, let's suppose any chapter, let's suppose evolution is a chapter that you don't know, or you know already that you are suffering, okay, in that particular chapter. So what you have to do, maybe the whole chapter is not very weak for you, only few topics are weak for you. Okay, so you have to find out the weak topics and then immediately give a reading, 5-minute quick reading from the notes in NCERT. Okay, and then practice the question. So that's how within 15 to 20 minutes you are able to revise the whole chapter. So you have to find out those weak chapters and weak topics, and then you have to after finding out if it is zoology, botany, then give the thorough revision, quick revision from the NCERT, immediately solve the question. So this is the last strategy that you can do right now. Okay, right now the too much time is not left. So that's all from my side. I wish you all the best, whoever is watching me. Even if you're watching in the future, please make sure you're giving your 100%, you're sleeping on time, you're eating on time, very important. Okay, without food and without sleep, if you go to an exam hall, maybe you will not be able to give your 100% and then you will regret it later. So make sure you are eating and sleeping properly, and then you are doing the study. All the best, guys. Thank you so much for attending the session. Keep watching the sessions like this. Keep giving thumbs up and likes. Okay, all the best. Thank you so much.